Welcome to this course on Complete Ethical Hacking 2.0 using Python and Kali Linux. So if you're ready to become a penetration tester and ethical hacker and enjoy a fascinating high-paying career, or just want to learn additional tips and techniques, taking your existing skill set to a whole new level, this course is for you. My name is Syed and I'll be the instructor for this course. I've been in the training industry for a little over 20 years and I've trained thousands of students who've become successful network admins, security analysts, and penetration testers. Let me walk you through the course agenda and how this course is structured. The first half of this course is all about the basics of Python programming, and I will detail out using hands-on tutorials Python programming from scratch. The second half of the course is all about Kali Linux, how to install the virtual box, installing Kali, and then writing Python programs to test the network for potential vulnerabilities. So if you're a beginner, that's great. I walk you through step by step using hands-on tutorials, starting from Python programming and then getting into Kali Linux. If you are an intermediate or advanced user, that's great. You can just jump directly to the second half of the course. And for those students who've taken my Python courses, you can directly go to the Kali Linux section. I welcome your feedback. Your positive reviews are very important to me because they allow me to make my courses better and better over time. Udemy and I offer a 30-day money-back guarantee, and I've also included several bonus lectures and additional resources so you can practice. Each lesson is followed by a quiz and several practice tasks. I enjoy to keep my students engaged, and I welcome posting discussions and sharing knowledge so that other students can also learn from your projects. So my goal is to make sure that all of my students remain engaged throughout the course. So feel free to post discussions, feel free to ask questions, and that's the best way to learn. Each lesson in this course is structured in such a way that not only you learn the concept, but also how to apply those concepts in the real world. So what are you waiting for? Click on Take This Course button now, and I will see you in class. Welcome to this course on Introduction to Python Programming for Beginners. Here's Module 1. We'll first take a look at the introduction and the course agenda. In our first lesson, I'll talk about the course agenda, which means the various modules and lessons within the Python programming. This is a beginner's course, so you don't need any experience in programming. I'm going to introduce you to the basic programming concepts and then take you step by step by means of tutorials, and we'll do both. We'll do concepts and then we'll apply those concepts by means of a tutorial, and that's the best way to learn. And then in lesson 2 we will highlight some of the areas as to why do programming, what is programming all about, and the basics of flowchart and logic as well. So just introducing you to the programming end of things, and of course later we'll get into the actual Python program. We'll also discuss what Python is and so on. But in this first module, I'll just introduce some of the basic concepts of programming and then take you through the course agenda as well. In Module 2, we'll get into the basics of Python. This module has 7 lessons. Lesson 1 is downloading Python. So from scratch, I'll demonstrate how to get hold of Python, what is Python, where do you go find it, how do you download it, whether on a Macintosh computer or on your Windows machine. I'll explain the various steps that are required in downloading Python and some of the prerequisites as well. So I'll highlight some of the areas to download Python. And what does it come with? In other words, what does the package has? What are the various features of Python program itself? Lesson 2 is the Python interpreter and idle. These are the two elements that get installed when you install Python on your computer. So once the installation is complete, I will demonstrate the use of Python interpreter and then the idle. What these are, what they do, what are the various functions of the interpreter and the idle. Lesson 3 is Python expressions. This is where we'll get into some of the language elements of Python. I'll just give you the flavor of what Python expressions are. Lesson 4 are Python strings. So for instance, if you need to write some text within the program, how do you go about doing it? What does it look like? What does it do? And why do we do this? And explain in lesson 4. And lesson 5 is getting input. For instance, if you're working or writing a program, you have to provide an input to the program so that it does something for us. So we'll take a look at what getting input means in lesson 5. In lesson 6, it's all about reading and writing files. Fetch a file from the computer and open it, for example, and other features will be covered within this lesson. And lesson 7 is the nuts and bolts and starting the idle. So in this lesson, I will explain the actual interface itself, what each line means. So I'm going to open up a sample program and I'm going to demonstrate various parts of the program. For instance, there may be certain code that may be in different color, for example, or that performs a certain function. So I'll explain to you what those elements are so you get familiar with the interface itself, which is called the idle within the Python. So module 2 overall, you'll be familiar with the basics of Python before you can actually start getting into and start coding or programming within the Python language. Module 3 is integer arithmetic, has 3 lessons. So lesson 1 is creating your first program. So in the previous module, we would have covered the basics of Python. In the first lesson in this module, we'll take a look at how to create our first program. A simple program, just so that you get a flavor and understanding of how to write a simple program in Python. Lesson 2 is placing comments in code. So in this lesson, I'll demonstrate line by line how to place comments within your code. In other words, these comments are simply that tells the programmer or another user or a person taking a look at your program or your code as to understand what you're actually about to do within your program. So these are just like placing comments, and you would do the same within your Word document. For example, if you're using a word processing program, you place comments for other users so they can understand your code better. Lesson 3 is introduction to strings. We'll get into more into strings, how to use strings within your Python program. Module 4 is functions and variables. So moving forward in this module, which has 4 lessons, the first lesson is what are functions. So we'll define what functions are, what do they do, how do they store values, what's the purpose of a function, why do we need them within the Python language programming. Lesson 2 is the print function, by far the most common function. So for example, if you tell a program to do something, then you need to also tell a program to print the output or the results as well. So we'll explore the print function in lesson 2. Lesson 3 and 4 are escape codes and the input function. And once again, these are simply a step forward within our programming as we go about creating a program, and then we enhance our programming, enhance our logic by using the escape codes, and of course the input function, which implies that, for instance, you may want to write a code where you would prompt a user to enter something. Use a certain software, you click on something, and it prompts you to enter your username. So that's basically the input function behind the scenes. So in module 4, we'll talk about the concept of functions and variables. Module 5 is function definition. This has 5 lessons. First is global variables, how to define global variables and what they are and what they do. Lesson 2 is the concept of dictionaries. And lesson 3 is concept of lists. And these are, again, you define a certain set of values and then you use code and use those values. And lesson 4 are what are tuples. These are very similar to lists. In fact, they are kind of lists. The only difference is between lists and a tuple is that you cannot change the tuple unless you change it back to a list and then you create a tuple again. So I'll explain later on once we get into these lessons what's the purpose and why do we use these. And lesson 5 is Introduction to Loops. And this is important because loops are inevitably more important as you program things. For instance, if you were to play a number game, the first prompt or the input is enter a number that you want to guess, and if you guess the number incorrect, then it was going to prompt you again for a number, a new number, and once again you enter that number, and if that number is also incorrect, the software or the program is going to prompt you again to enter the number, and you'll keep repeating the steps until you find the correct number or you enter the correct number. So that's what a loop is all about. So until and unless you find the correct value, the software or the code is going to keep looping around until the result is finalized. So we'll take a look at the loops in lesson 5. Module 6 is object orientation. We'll get into more in lesson 1 about graphics. Lesson 2 is conditional execution. Lesson 3 is if statements. And again, these are more conditional logic. So for instance, if it was going to rain, I need to take an umbrella, right? So that's just a simple English statement that if something happens, then I will do something else, right? So if, then, else is a basic logic that we use in programs, Python programming language, or we write the code and letting the software know that, hey, we need something done, here's our conditional logic. So we'll explore the concept of if statements and additional if statements, which means they're nested within if statements. So there will be multiple if statements. And lesson 5 is the while loop. So while is again wait and then loop around to do something. So module 6 is about object orientation. And module 7 is about projects. I've listed a couple of lessons here, project A and project B, which simply means that we will do from scratch, we will create certain projects using Python. So maybe we'll create a number game, we'll create some other games, for example, in Python, or do some other programming that may help you within your work environment. So we'll explore by using and creating from scratch a couple of projects. And I might create other projects as well, even though I've listed a couple of lessons, but I may end up doing, for practice purposes, additional lessons within this module as well. And all of the modules are reinforced within these projects. And finally, in module 8, we will conclude, and the course conclusion will cover essentially recapping all the concepts, all the lessons that we've covered within the Python programming. The objective here is to ensure that you not only understand the basics of programming and why we program, but also how to program and using Python language. So in conclusion, we will recap essentially all of the important concepts that we already covered. So without further ado, let's get into our first module and explore various lessons. The entire course is about concepts and then applying those concepts using Python interpreter and idle. So we'll explore and I'll demonstrate by hands-on tutorials how to understand a certain concept and then how to apply it and how to see the output. What does it do? So let's get started and let's begin our. In this lesson, we'll take a look at why do we need programs? What is a program and how to learn to program. So I'm going to talk about a lot of concepts and then I'll do some tutorial as well as we move along. So learning to program is becoming increasingly important in a variety of fields. So no matter whether you're in the financial industry, pharmaceutical industry, health industry, and so on, learning to program is very important. And in a sense where most of these software programs or these various enterprise level softwares, they need customization. So each organization is different. Every company has its own set of requirements. So most times they engage these developers or programmers to customize their environment or their software to their own needs. So as processes and workflows become automated, virtually every field of human endeavor will be reliant on software and the people who create it. And we see this especially with the influx of mobile devices, apps, cloud computing. We know on the back end of things there's a lot of programming that is involved. So programming is important and is becoming a necessity as technology is exponentially growing. Computers follow instructions. So computers are simply machines that are built for one purpose only, and that is to do things for us. But the computer itself does not really know what to do. We need to tell the computer, and we need to speak their language to describe what needs to be done. For example, if I were to click somewhere on the screen here, that implies that the computer is going to execute my command. That is, click of a mouse button. And then the computer is going to wait for my next command. Otherwise, if I do not send a command to the computer, nothing's going to happen. So essentially, all computers do is just follow instructions by humans. And similarly, when software developers, they create programs using language such as Python, for instance, all we're doing is we're telling the computer step by step what needs to be done. And in order to tell the computer, obviously we need to know the language that the computer understands. And that's what Python is all about. Users versus programmers. What's the difference? Users essentially see computers as a set of tools. So if I'm a user, I'm going to use the computer, I'm going to click on certain buttons, use various tools, and I'm going to gain some output. For example, word processor or spreadsheet. So I'm using an Excel spreadsheet here, and I'm going to calculate or add certain values on the spreadsheet. I'm going to issue some commands to the computer, and I'm going to get my total. Similarly, if I'm using a word processor, I can bold text, highlight text, increase the font size, and so on. Programmers, on the other hand, learn the computer ways. In other words, the way a computer understands the actual language. So programmers have some tools that allow them to build new tools, and they also sometimes write tools for multiple users as well as for themselves to automate certain tasks. So a good example using Excel as a programmer would be create a macro or create a Visual Basic script, for instance, that is going to automate your addition, subtraction, or any task that you're doing in your Excel environment. Similarly, you can also create macros in word processing programs and a host of other enterprise-wide applications or other software programs. So users simply use the tools, and programmers automate those tools or create or speak the computer language. What is a code? What is a software or a software program? What are all these terms? What do they mean? So it's simply a sequence of stored instructions. As I mentioned earlier, it's a little piece of our intelligence essentially that we give to others. We figure something out, and then we encode it, and then we give it to someone else to save them the time and energy of figuring it out. So we write programs and we tell the computer to do certain things automatically so that others don't have to do it. So essentially, it's just a piece of creative art, some innovation, particularly when we do a good job on user experience. And within your experience, you might have come across certain software that are really easy to use, easy to navigate, easy to understand. The tools are right there on the screen, and you can simply use those tools to accomplish your task or certain goals. And that's what we mean by user experience. So a good programmer essentially keeps that in mind from an end user perspective. Instead of making things difficult, a good programmer's job essentially is to make things easy for the user. Some example of what a code looks like or what a program looks like. At this point, obviously, it's all foreign, but no problem. We'll take a look at once we get into subsequent lessons, you'll be able to in fact do all of these. So this is just an example of various lines that we use within the Python program and create functions and create the program or create a script and then run these to get an output. Okay, so all of these are entered into the Python software program essentially, or the idle or the Python shell, and I'll talk about in subsequent lessons what those are explained. But for right now, just to give you an idea of what the code looks like, let's talk to Python. So for instance, if I were to open up my Python interface and add certain commands, for example, how does Python work those commands? Okay, as I mentioned earlier, the computer is going to wait for my instructions. So if I instruct the computer to do something, it's going to do it. If I'm not, it's just going to stay as it is. Okay, let me in fact demonstrate. So for example, here's a simple command called import sys. In other words, I like to find out the version of Python installed on my computer. So in order to do so, I need to open up the Python program and then input this command called import sys, and then finally print parentheses sys.version and close the parentheses. And this would give me the results that you see on this screen. Okay, let me in fact demonstrate. So I'm going to switch to the Python application here. So here's my Python shell, which is, again, I'll explain in subsequent lessons, but for right now, once you install Python, you open up the actual Python shell, and this is what you're going to see. And the cursor is blinking. In other words, Python is now waiting for me or for my command. So for instance, if I were to, as a first example, just type copyright, okay, and hit enter on my keyboard, I'll get the copyright results for Python. Similarly, I can type credits or a license for more information if need be. Let me demonstrate the example that we looked at on our earlier slide. So I need to see which version of Python is installed on my computer. So first I'm going to run the command called import sys, hit enter key, and next I'm going to print parentheses sys version. This is closed. And notice at this point it tells me that version 3.5.0 is installed and gives me other details as well as to the last upgrade, since Python was last, it's an open source. So on September 13, 2015, at this time and this version, that's the version I have installed on my computer. So this is a good way to check whether on your own computer, once you install Python, it's a good way to check whether it's installed properly or not. Okay, so this is again just a flavor, just to show you the Python shell, where essentially we'll be spending most of the time in this course. So I'm going to switch back to my slide here. So I demonstrated both the import sys commands as well as the copyright and license and credits you can also take a look at. So talking to Python is really using the Python shell. Whatever you do in that shell, Python would execute the command. Some of the elements of Python, 3 broad categories here. First is the vocabulary and the words. Just like any language, if you were to learn French, for instance, obviously you need to learn certain vocabulary, and as you gain more experience, your vocabulary increases. So Python uses vocabulary words and also uses the variables, and certain words are reserved. So for instance, you cannot use a reserved word as a variable. Sentence structure is the second category. You need to have valid syntax patterns, otherwise Python is not going to understand what you want done. And third is your story structure, constructing a program for a purpose. And story structure is nothing like a flowchart, for example. So it's a series of steps that you want the program to execute. And the more efficient your story, the more productive your story, the better program it is. So elements of Python essentially entails 3 broad categories. You need to know vocabularies, words, sentence structures, and then eventually your story structure. Here are some examples of reserved words in Python. Once again, you cannot use these reserved words as variable names or identifiers. And some example reserved words are return, break, global, for, continue, while, import, and I just demonstrated this example import in our previous slide where we imported our current version and took a look at which version of Python is installed on this computer. Python sentences, for example, we need to define and let Python know what needs to be done. What do we need accomplished? For example, if x equals 2, which is an assignment statement, so I'm assigning the value to x. And then I can assign it with expression. In other words, I can say x equals x plus 2, which means it's simply 2 plus 2 is 4. So when I print x, it's going to print the result 4. Let me once again demonstrate this using Python. So let me switch back to the Python shell. Here I'm going to say x equals 2, enter, and then I'm going to say x equals x plus 2, and finally I'm going to say print x. I get the error because print is with a capital P. So instead of capital P, it needs to be print. And notice Python is good at this because it knows whether this print is the correct value or not. And you can see this by the differentiating color. Here I had the capital P, which was in black, obviously, so Python does not recognize this. But when I use the lowercase p, it recognized that this is a valid command. So I'm going to say print x one more time, and my answer is 4. Okay, so you need to be careful. Obviously, once again, computer will only understand what you tell the computer to do. If you don't speak the language, you will get errors. And that's the best way to learn. As we move along this course, you will see that how you can develop efficient programs and understand the vocabulary, the sentence structure, and then finally your story. Okay, so this is a good example of the sentence and assignments. So let's switch back to our slide. So once again, Python sentences is x equals 2, x plus 2, and then you print your statement. Great. So in this lesson, we took a look at why we need program, the difference between programmers and users, a little bit of Python shell that you took a look at, what a program looks like, and in fact, I demonstrated a small flavor of Python language as well, so that you could see that we need to understand the vocabulary and words, the sentence structure, and then finally your program or your logic or storyline as you start creating these programs. So with this, let's move to our next lesson. In this lesson, I'm going to demonstrate how to download Python and install the program itself. So we can take a look at and we can start using the Python program to create some programs. So here I have my Chrome browser open. You can use any browser, whether it's Internet Explorer, Firefox, or Chrome. I tend to use Chrome, and I have my home page as Google open. So I'm going to go up to my Google search, for instance, and I'm going to say download Python. And it's going to bring up the web page with the results. And the very first one is obviously the python.org. I could have just gone directly and typed python.org to get to that website. But if you do not know where Python is, how to download it, you can simply search on Google and it will give you the results. So once I have the download Python link, I can click on this particular link and this will take me to the python.org website. And here, right off the bat on the home page, I'm able to see the download the latest version for Windows. If I need other versions, I can click on the Linux, Unix, Mac, OS, or others as well. Since I'm using a Windows computer, Windows 8 machine, I can simply click on the download Python 3.5.1 version, or I can choose Python 2.7.11. Now really, what's the difference between these two? Obviously, the 2.7.11 is an older version, and the newest version is 3.5.1. But why would you want to download the older version? Should there be just one latest version so everyone can download this? Well, here's the difference between the two downloads. The reason why people download, or programmers, developers download the earlier version, which is 2.7.11, is mainly because of the library support. In other words, there are tons and tons of programmers that create code that is written in this particular version, 2.7.11. Whereas since 3.5.1 is a newer version, which also means that certain syntax might be different, certain commands might be different, because most of the commands are added, newer commands are added. For example, the syntax or the sentence structure or the assignment may be different from the earlier version. Therefore, there's less library support as compared to earlier versions. So that's the only main difference that I want to talk about, apart from other differences as well. But this is the main one, that why you wish to download the older versions. Okay, but nevertheless, let's stick to the newest version, because that's where programmers move towards and the right code in the newest version, and eventually you'll have your library support and other tools and features with this version as well. So once you are on the home page, just simply click on Download Python 3.5.1, and it opens up area where you need to save the program. Notice the file name is python-3.5.1.exe, which means an executable file. And I'm going to download in my data files folder, and I've created a folder called Python, and this is where I'm going to save the application. So once I click save, on the bottom here, notice it's going to start to download. So the actual file size is about 27.4 megs, and it's going to download Python 3.5.1. And once it's downloaded, then I'll go back to the location of this executable file. I'm going to install Python. In the meantime, while this is downloaded, on the python.org website, there's a couple of good links that you can take a look at. For example, the documentation link is good. So if you're more savvy about documentation, you can always find different documentations of Python 3 version docs or the earlier version as well. So you can take a look at. There are also a couple of other links, such as Beginner's Guide, Developer's Guide, Frequently Asked Questions, and other books as well. Okay, but typically these are helpful. These links are helpful if you know the program itself and you're comfortable programming using the Python language. Then you can fish through these and find out various code or set of code, and visit perhaps the community site and take a look at the Python wiki and find different codes. For instance, if you're developing a program, you can always search python.org and get to the place where you need to be. All right, it seems like our program has successfully been downloaded. I can click right off of my browser to install Python, but just to verify whether it was downloaded on my computer, I'm going to switch to my Windows Explorer so we can see. So if I were to navigate to the directory where the download was specified, I now see that I have python-3.5.1.exe, and it tells me the actual size of the application. And once again, I can simply run this program by double-clicking on this program. It brings up a dialog box, simply tells me, do you want to run this file? And I'm going to say run this file, and it's going to start the installation process. The first step that I see in my install is that this is Python 3.5.1 32-bit version. And I can simply click install now, and it will install the program in the respective directory. So for instance, the current installation directory is displayed. I already have Python installed, okay, so that's why it picks up the default directory. I can always change by click on customize installation and choose the location as well as features as well. So if I were to click on customize installation, notice it gives me several options, such as it will install the documentation along with the program, it will install the PIP, the TCL TK and the idle, Python test suite, and the PyLauncher, and it's going to make it available for all users. So I can pick and choose depending on some of the optional features. I'm going to leave it as default, in other words, install everything. On the bottom, install launcher for all users, which is recommended, and add Python 3.5 to path. Okay, so we're going to leave as is. I'm just going to leave the path also, and I'm going to click on install now. And it's going to run through the installation process. It's going to initialize, and it's a pretty straightforward process. So it's just going to ask you a couple of screens, next, next, and then it will install the program itself. And it usually takes some time because it installs the development libraries, the actual program itself, the executables, and the progress bar shows you that it's been installed in the background as well. And once again, it also installs the optional items that we selected before the installation process, such as the documentation, the scripts, the TCL TK support, and so on. And finally, it displays a message that setup was successful. And once it's done, you can always click close, and you've successfully installed Python. But how do you know whether it's there or not? In other words, where do you go and in fact open the program? Well, it creates a desktop shortcut. Okay, so I'm going to navigate to my desktop so you can see the actual program, or I can always find within my Windows as well. So if I were to open up my, since I'm using Windows 8 here, if I type Python in the search, notice it's going to bring up a list of items that contain the word Python. Okay, so since, as I mentioned earlier, I already have the Python 3.5 64-bit installed, it's already listed. And now I've successfully installed the Python 3.5, the 32-bit, which is down here. Okay, so notice these are a couple of options here. It's Python 32-bit, and then I have the idle Python 32-bit, same versions. In my next lesson, I'm going to demonstrate and talk about what these are and how do we open these. But for right now, it also installed the manuals and the documents as well. Okay, so I have two versions of Python installed. First, obviously I was using the 64-bit, so that's there, which is again the first two options here on the list. And then my 32-bit that I just demonstrated, and I installed the 32-bit version. And I can click on the Python idle, for example, the 32-bit version, which I just installed just to make sure that it runs, and it will open up the Python shell for me. Let me maximize this, and here it is. So here, for example, just to see whether I'm using the current version or not, I'm going to type import sys, and then I'm going to say print sys version, and this will display the version of Python that's installed. Notice in this instance it's version 3.5.1, and the date is December 6th, 2015, which is pretty current. But then again, this is a 32-bit install. So in this lesson, I demonstrated how to search Python, in other words, where to go and find the Python program. Software program is free. You can download it. And I also demonstrated how to go to python.org, download the software, install it on your machine. Fairly straightforward process. Open the Python shell and then check to see whether the version is correct or not. So practice, and let's move to our. In this lesson, I'm going to demonstrate how to work with Python idle and Python interpreter. So once Python is installed, essentially two executables are installed with it. You can either open up the Python shell, which is 3.5.0 version, or you can open up the Python interpreter as well, which again is 3.5 version. So in this instance, I've opened up both of these so we can take a look at and see how Python works and what the difference is between these two. First, I'm going to talk about, on the right side of the screen is the Python interpreter. Notice I can of course drag and drop. It is just a command. It is just a program, that executable program that I can open. Okay, and if I close it and open it up again, it's going to bring this up. So I'm going to move this aside. Okay, the cursor is blinking, so it's asking me for input. So for instance, before I actually start working with these, just so you know that both of these are similar. Okay, so there's no difference in terms of execution of commands. So whichever command I execute here, I can also use the Python idle to execute the command on this line where my cursor is blinking. Okay, so either way, whether I'm using the interpreter or the idle, the command is the same. So it's still Python language, doesn't really matter. And you'll see the difference of why we use one or the other. First, I'm going to work with this area, which is the Python interpreter. So for instance, here, if I give Python a command such as 4 plus 6, hit the enter key on my keyboard, and it displays the result as 10. Pretty straightforward. And Python, by the way, is a simple language. As we move along, you'll notice as we start creating programs, things will be clear to you. But just to give you an example, I just took two numbers, 4 plus 6, and I added them together, hit the enter key on the keyboard, and the answer is 10. Now what happens when I go to my idle? Same thing, 4 plus 6, hit the enter key, and my result is displayed. The only difference obviously is the color coding, because the results are displayed in blue, and within my interpreter environment it's just the prompt. Okay, so that's one of the differences. So as you're entering commands, it's much easier to work with the idle here as opposed to using the interpreter. Okay, great. Second, let's go to our interpreter one more time. So here, for instance, I'm going to say x equals 5 or 4, hit the enter key, and I'm going to say x equals x plus 5, hit the enter key, and I'm assigning just variables here, and I'm going to say print, let's move this aside, x, and it's going to say it's 9. Okay, same thing within my idle here. I can do the same thing. I can say x equals 4, hit enter, and then I'm going to say x equals x plus 5, hit enter, and I'm going to say simply print x within parentheses, and the answer is 9. Once again, notice the color coding. The print function is in a different color, the results are in different, output is in a different color, whereas within my interpreter here, it's just one single color and it's going line by line. Now what if I were to create a program, right? So this is, again, this is fine. I can simply run the commands or tell Python to do something and it does it for me. But one of the shortcomings here obviously is that I cannot really edit any one of these. So for example, if I need to change the value of x from 4 to 8 or 10 or 9, I would not be able to do so. I would have to re-enter the entire set of commands. Okay, so I cannot really change this. And obviously within my interpreter environment, I'm also not able to change any one of these. I have to redo or retype. Well, that defeats the purpose of programming, because you need to be able to go back to your code and obviously change those things. So in essence, the Python interpreter is good for just testing whether your command works or not. Okay, so that's, keep that in mind when you're working with Python. So typically you would just use the idle environment for the most part when you're working with Python. So typically you'll be working with the Python shell here as opposed to the Python interpreter. Okay, so I'm going to close the interpreter for now, and once again this is just to test whether your command or the input that you gave or the function or the variable works or not. Okay, so I'm going to close this for now, and here's my shell. Okay, now once again, going back to my shell, I can again enter a set of series of steps or commands or use variables, functions, whatever I want to use, and it's going to give me the results. But recall, we talked about the fact that I cannot really go back and change any one of these. So what's the solution? So what Python does, it allows me to actually create a program. I can also do so in Notepad++, or any other editor and then run within the Python shell. But let's explore the menus first. First, I'm going to let you know what Python idle is. So about idle, if I click on help and just simply click on about idle, it gives me Python's integrated development environment. So now you know that idle stands for Python's integrated development environment. Okay. So this is where you would actually start using Python and start entering your code. Okay. So let's close out of here. So within this Python shell, some of the other menus are, for example, file, and within the file menu, I have an option called new file. So if I click on the new file, it brings up another shell window. I'm going to move this aside, make this a little smaller so we can actually see. Okay, great. So this is where you would actually start typing your program, and then you would run it in the Python shell. Notice the set of menus are different as compared to the menus within the Python shell. For example, there's a run menu option here, whereas in the Python shell you don't see the run menu option. So let me give you an example here. So for instance, here if I type the same thing, so I'm going to say x equals 5, and the next line I'm going to say x equals x plus one more time 5, and then I'm going to print x. Okay, and notice it uses the same color coding, same set of commands, but if I hit enter in this area, nothing happens because I'm not executing this command anymore. All I'm doing is writing my code. So this is where you can always go back and change and start building your code. Obviously I'm using very basic examples, and in next subsequent lessons I'll demonstrate what functions are, variables are, so you know. But right now we're just discussing when I'm demonstrating the Python shell and then the editor where you would build your code. Okay, so here's my simple code. If I need to run this code within the Python shell, obviously I can copy and paste here within the Python shell, or I can use the run menu, and then it gives me the option to run this in Python shell. Okay. There's a shortcut also. I can use my keyboard to run this module by using the F5 key on my keyboard. Okay. Or I can simply click on Python shell, which takes me to the Python shell itself. But I need to run the module, so I'm going to click on run module, and of course it asks me to save the module first before it actually runs it. So I'm going to click OK to save it, and it brings up my window here, and I'm just going to call it first, and let's see if I can find where I would like to save. Here's my data files folder and a Python folder, and click save. And as soon as I click save, notice my results are displayed and the answer is 10. And Python also shows me the location of my Python program. So this is essentially a program. It's called first.py, and the location is displayed as well of where this Python program file is stored, which means in essence that I can always open this file anytime I like and then build my code. Okay, so this is a very powerful way where you can program in Python. So the interpreter, which we closed earlier, I'm going to reopen it one more time. Here's the interpreter. Okay, so this doesn't really allow you to build your code. It is just there to check whether your command is successful or not successful. Okay, which is similar to the Python shell here. Whereas the shell also allows you to write a set of lines and codes, but it gives you color coding that you can take a look at and see whether it's a valid function or not, or you've assigned the variables correctly or not. And then our editor here, which allows us to actually build the code, and I can save this file by giving it a name, and the file extension name is .py, or call it pi. So here, for example, if I need to enter something else, let's say I'm going to say print, of course it's case sensitive, and I'm going to say something like hello world, if I do something incorrect, Python tells me that, hey, wait a minute here, it's not the correct syntax. So as soon as I type the correct syntax, notice it displays in color coding, so it tells me that, okay, fine, this works now. So hello world, and I can again build my module. If I need to run the program, I can simply click on run and run module. Of course, it saves the module first every time, and it displays my results. This time, if I need to change something here, for example, if I need to change the value of x from 5 to 7, I can easily do so within my editor, which I'm unable to do within my Python shell or the Python interpreter. So here, I've just changed the value from 5 to 7. I need to run it again, run module. Of course, save first, and notice here's my result. This time is 12. Okay, so this way, it's a powerful way to keep building programs. So in subsequent lessons, we'll be using the Python shell and the editor here, and we'll create several programs as we move along. And this is the core part of our course, where everything that we do, whether we learn about lists, dictionaries, variables, assignments, functions, reserved keywords, and so on. So we'll be using and creating several of these scripts. These are also called scripts, right? Because obviously you're telling the computer a set of commands, or using Python language, you're telling it to do something. Okay. Next, let me demonstrate a few sample demo programs in Python. Okay. Obviously, this is a program that we just created because it gives us something as an output. But within the Python shell, under the help menu, there is a turtle demo. I'm going to open that up, and this gives you several examples of Python programs. Okay, so for example, let's say I select the forest. So on my left is the code in Python. Don't worry about this, you'll get to this stage as well. Once we click start, notice it creates the program for us, and this is all built in Python language. Okay, so very powerful language, easy to use language as well. So if I click on start again, it's gonna run the program. Similarly, I can click and check other examples such as color mixer. Here's the Python code on the left. I click on start, and I can now in this instance drag, and it changes the color. Okay, so it just depends on what set of code you've written, and the output is displayed. Okay, so Python is very powerful. Let me close this demo. So in this lesson, once again, we took a look at the Python interpreter, the Python shell, and of course the editor where we actually write our programs. So practice. Hope this helps, and let's move to our next lesson. In this lesson, I'm going to demonstrate a sample Python program and then explain what each of these lines within the program mean or imply. So in other words, here's a sample program that I've already opened within my Python idle. And on the right side is just a Word document explaining, for instance, what line 0 means. So just note here that the numbers on the right are not part of the program file. They're added for reference purposes. And by numbers, I mean these numbers that you see, 0, 1, 2, 3, 4, 5, all the way down to 39. These are just for reference purposes. So I've added them just so that I can explain that what line 7 means, what line 8 means, for instance, or what line number 25 means, for instance. Okay, so these are just for reference purposes. When you're actually creating a program in Python, you don't need these numbers. So I've placed them myself just so that I can explain the Python program line by line. Okay, so let's start. Line 0 here, for instance, the first line within our program starts with a number sign. So anytime a line that starts with a number sign, this implies that this is a comment by the coder. Okay, so Python ignores this line, and this does not form part of the actual program, although it's listed or it's written in the program, but Python ignores this. As soon as it recognizes it starts with a number sign, it knows it's a comment. So in other words, Python is not going to do anything to this particular line. So comments are useful because it helps the coder or the programmer to actually know sections of the code. Sometimes your software or your program may be very, very long, so these are helpful. So line 0 is technically not part of the program. It is just there to tell the operating system what version of Python to choose. Since, here's a word of caution, the older Python 2 version is incompatible with the newer Python 3 version. And the reason why, because the syntax is different. So if you write a program using the Python 3.5, which is the current version, for instance, it may not work if you use it as a Python 2 or within a Python 2 environment. So we will mostly run programs from inside the idle programming environment, as I mentioned earlier, where this line is not really required. And to run just by clicking on the program in the operating system window. However, the line is important if your computer has Python 2. So just to tell or to identify which version you're using. And you can place anything in the comments section as well. So line 4 or 1 through 4, this is a multi-line text enclosed in triple quotes. So every time you see these triple quotes, for example, and anything in between these triple quotes, this simply implies it's a multi-line text. Coded text is called a string. A string at the very beginning of a program, like this is documentation for the file. Okay, so these are just strings and is highlighted in green color. So every time you see anything in green when you're coding in Python or using Python language, that means it's a string, and string means text. Lines 5, 21, 29, 37, in other words, every time you see a blank line between the code here, so it'll be line number 5, for instance, and line number 21, line number 29, and so on. So blank lines are included for human readability to separate logical parts. The computer ignores the blank lines as well. So Python is going to ignore line 21, line 5, and these are just entered to break or to make it look simpler. Just like when you're writing a document, right? You're writing an essay, for example, and you enter a new paragraph or you enter a line to separate your logical concepts. So blank lines are inserted in Python as well. Line number 6 is the story format, equals, and then the triple quotes. So the equal sign, every time you see an equal sign in Python, this tells the computer that this is an assignment statement. So what essentially is happening here, that the computer will now associate the value of the expression between the triple quotes as a multi-string line with the name on the left, which is the story format. So here you're assigning this entire text, so to speak, to the story format. So if I were to, let's say, just say story format, which actually would mean all of this text. Okay. Lines 7 through 20. So lines 7 through 20, which is the body part of the story format here, contain the body of the string and the ending triple quotes. This story format string contains some special symbols, making it a format string, unlike the string in lines 1 through 4. The story format string will be used later to provide a format into which substitutes are made. For example, notice within the story format here, you see something like braces and then animal. And then as it says, this animal like to eat food, and food is also in braces. Similarly, animal, food, city is also in braces, and so on. So the parts of the string enclosed in braces are places. A substitute string will be inserted later. So this is essentially going to prompt, let's say, a user enter the name of an animal, enter the name of food, enter the name of a city at a later point in time. So this substituted string will come from a custom dictionary which will contain the user's definition of these words. So these names of animals, food, and city is going to come from a custom dictionary that we'll create later. And the words in the braces, as I mentioned earlier, like animal, food, and city, indicate that animal, food, and city are words within that particular dictionary. And this custom dictionary will be created in the program and contain the user's definition of these words. So these user's definitions will be substituted later in the format string within the curly braces. Okay, so this is between lines 6 and line 17. Next is line 22, which is definition, tell story, and then a set of parentheses. The def is short for definition. This line is the heading of a definition which makes the name tell story becomes defined as a short way to refer to the sequence of statements that started indented on line 23 and continue through line 28. So again, this definition tell story is simply from line 23 to 28, and it's just a sequence of statements that make part of this definition called tell story. The equal sign in line 23, once again, every time you see an equal, it's an assignment statement, right? So the equal sign in line 23 simply tells the computer that this is another assignment statement, and the computer will now associate the name user picks with a new empty dictionary created by the Python code called dict and a set of parentheses. And as we move along, once we start creating programs, once we practice with this, you will get to remember these Python codes, the functions, the built-in words, the reserved words, and so on. But for right now, line 23, which says user picks equals dict parentheses, is simply creating an empty directory created by the Python code. And line 24, 25, and 26, where it says add pick animal, food, and city, is just a sequence of instructions defined in subsequent lines for adding another definition to the dictionary based on the user input. So the results of these 3 lines is to add definitions for each of the 3 words animal, food, and city to the dictionary. Line 27, story equals story format dot format user picks is simply assigning the name story to a string formed by substituting into story format using definitions from the dictionary called user picks to give the users a customized story. Okay, so for right now, just understand that every time there's an equal sign, there's an assignment, for instance, and there are certain built-in Python code and the concept of a little bit on dictionary. You can add a sequence of instructions. So let's scroll down here and bring up the rest of our code. So line 30 is a line where it's simply a heading of a definition which gives the name add pick as a short way to refer to the sequence of statements indented on lines 34 and 36. So once again, line 30 is simply def add pick q comma dictionary. The name add pick is followed by 2 words in parentheses, q and dictionary, and these 2 words are simply associated with an actual keyword, and dictionary given within the definition is invoked in lines 24 and 26 above. Right here, when the user is prompted to enter a name for animal, food, and city, this is in fact where it's going to use. And line 34 is the plus sign here is used to concatenate parts of the string, so to join 2 strings together. For example, you may have first name, last name, and then you want to display them together instead of in two different columns, for instance, or two different separators, for instance, you'd actually join two words. So we use concatenation. So the plus sign, anytime you see a plus sign within the Python code, it simply is joining two things together. And line 35, which is the response equals input prompt. The right-hand side of this equal sign causes an interaction with the user to input text from the keyboard. So every time you see this prompt, in parentheses, right? Input means it's going to require input from the user, and prompt means the cursor is going to start blinking, right? It's going to wait until the user enters something. So the prompt essentially is just asking the user to do something, and that's in line 34. So the prompt string is printed on the computer screen, and the computer waits for the user to enter a line of text. And that line of text then becomes a string inside the program. This string is assigned to the name response. So again, every time there's an equal sign, it's an assignment statement, right? Line 36 is dictionary Q equals response. The left-hand side of the equal sign is a reference to the definition of the keyword in the dictionary. The whole line ends up making a definition of the current Q, where it becomes a response typed by the user. And finally, we have a couple more left, line 38 and 39. And line 38 is tell story parentheses. The definition of tell story above does not make the computer do anything besides remember only what the instruction tell story means. It is only in this line with the name tell story followed by parentheses that the whole sequence of remembered instructions are actually carried out. And finally, in line 39 is input press enter to end the program, and this line is only here to accommodate running the program in Windows by double clicking on its file icon. Without this line, the story would be displayed and then the program would end. So you want this to make sure that you as a user ends the program. So this line forces the program to continue being displayed until there's another response from the user. And meanwhile, the user may look at the output from tell story. So a few important things that we took a look at within a sample program. For instance, the prompt, equal sign, the three quotations, and our comment code. Okay, so just to give you an idea of what a sample program looks like, and a line-by-line explanation of each of these areas. And there are many other functions and codes and variables that we'll take a look at and we'll work with. So not to worry, this is just so that you can get a gist of what some of these areas within the Python program looks like. So as we move forward and start creating our own programs, this will be helpful. So practice, take a look, and let's move to our next lesson. In this lesson, I'm going to talk about Python strings. What they are, what do they do, how do we use them within the Python language. The Python shell on the left already open. Now recall from previous lessons, the shell executes one command at a time. If I need to write a program, then I need to open up by going on File, New File, and then it opens up the shell again where I can actually type the program itself and then click once to run and it will run the program. Okay, so just quick recap from last time. So I'm going to close this for now. So strings are amongst the most popular types in Python. We use them all the time. Whenever you're writing code, you're creating a program, you're bound to use strings. We can create them simply by enclosing characters in quotes. So for example, you can use single quotes or double quotes. A string can have any number of characters in it, including 0. The empty string is enclosed in two quotes with nothing between them. And quotes can turn digits into strings as well. And if you were to use the backslash on your keyboard, that can be used to escape quotes. So let's take a look at how actually Python uses these quotations when we talk about Python strings. Okay, so I'm going to click on the Python shell here. And if I were to just, as an example, type something let's say I'm going to say New York. Python does not understand the word. In other words, Python wants us to tell or provide an instruction. Simply writing text is not really an instruction unless we place the text within the quotation marks. Only then Python would know, hey, wait a minute here, this is now a text, and it's going to treat anything between the quotations as text. So for instance, if I were to type the same thing within a single quote, and notice Python automatically colors this as green, and hit the enter key on the keyboard, and it displays the word as a string. What happens if I use double quotes? New York in double quotes, it will return the value similar to whether I use the single quotes or double quotes. A string can also have a number of characters in it, including 0. So for example, if I were to type the number 5 within a single quote or a double quote, doesn't really make any difference, hit enter. Now this 5 is not a number, it's considered as a text. Okay, so it's confusing at times, but when you get used to the strings or using the quotations, you would automatically know that we're talking about text. We're not talking about numbers. If I were to write just number 5, hit the enter key, now that's a number. So Python knows that this is a number. And let me demonstrate this further. So if I go 5 plus 4, hit the enter key, it's 9. What happens when I use quotations? So for example, if I use the quotations, I say 5, and then I add 4 to it. Okay, let me try that again. 5 plus 4. And at this point, if I hit enter, Python is going to recognize both of these as strings, and it's going to join and says 5, 4. From the look of it, you may say it's 54, but in essence, this is just a string. So keep that in mind. So the strings can also include digits. The empty string is 2 quotes with nothing between them. And you can use the backslash to escape those quotes. And we'll take a look at next as to how to use the backslash as well. But for right now, I just wanted to demonstrate quickly the basic concept of what a string is. Okay, here are certain examples that you can also practice yourself. But quickly, if I were to go back to my shell and type something like play football, if I can spell this correctly, play football, right? And it simply displays the same. Next, let me clear the screen, so I'll open up the shell again so that you can see when we use the backslash within Python strings. Okay, the use of backslash is fairly straightforward in Python. For example, if I were to use the word doesn't within my single quotation, just as a plain English word, and hit the enter key, notice it gives me the syntax error, where it says, well, wait a minute here, these quotations within the word doesn't, or right after the letter N, Python sees this and tries to figure it out that this is a string, but in essence, we're just typing English language. So to tell Python to escape or don't worry about this particular quotation mark after the letter N, we use the backslash. And that's the basic concept behind the backslash. So now, for example, the same word, doesn't, and right after the word N, I'm going to use backslash. Try again. And I'm going to use backslash this time, and then my quotations, right? Hit the enter key, and now it writes as doesn't. Okay. So similarly, you can use either single quotes or double quotes. Doesn't really make any difference. If you're quoting another person, for example, then you would use something like, hello, my name is John, and I want to use it as a coded text from someone. So here we go. Hello, my name is John, and right after John, I'm going to say backslash, and then how are you? Okay, run this, hit enter key, and notice at this point the words hello, my name is John are in double quotes because I'm coding someone, and then whatever you want to write. So it's a good way to work with the backslash. And it's pretty common. Once you take a look at the Python code, for instance, you will see this quite a bit. So if you don't want characters prefaced by a backslash to be interpreted as special characters, what we do is we use the letter R before the first quote. So for instance, let me demonstrate this. If we were to say something like print, open the parentheses, C:, wonderful, New York. Now in this instance, if I hit enter, notice it gives me an invalid syntax. Why? Because obviously I forgot the strings. So I need to make sure that I add strings. So I'm going to quickly copy this again and paste it. Go to my C and add my strings, and of course automatically it changes the color. Tells me that now I'm on the right track. Hit enter. And notice what happens. Python truncates after the letter L. So it says wonderful, and then the \n, it treats it as a new line, so it completely forgets about the letter N. So this could be problematic if you're writing something and then you're trying to figure it out. Okay, well, what happens? Where did my letter go? So in order to make sure that you have a letter, what we can do is we can use raw strings by simply adding an R, which would allow Python to skip the \n. Okay, so again, one more time, I can do something like print, my quotation, C:, wonderful, New York, and I'm not done yet because I need to place the R, which is the raw string, right before when I open this string. So Python now knows that if I use the /n in this instance before the word New York or new, it's not going to truncate. So if I hit enter, now it's going to display the entire word for me. Okay, so practice with these strings. They're pretty powerful and used frequently in Python. Next is string concatenation. So the plus operation, or the plus sign on the keyboard, or the addition sign, means concatenate the strings. Python looks at the type of operands before deciding what operation is associated with the plus sign. In other words, string can be glued together with the plus operator, and then you can repeat them with the asterisk or the multiplication sign. So for instance, if I were to have strings such as new, if I were to just hit enter, obviously it's going to type the string. But if I do something like new as one string and then York as the other one, is going to type New York. Okay, and we've done this before. Okay, so simply taking two strings and then combining them, and these are fairly common when you talk about first name and last name. Okay, so these are common. So if you're going to combine first name and last name into one single string, you would use the plus sign. The multiplication sign or the asterisk is simply multiplying the same word. So I can say something like for asterisk or multiply and the word new. Hit enter, and it's going to simply recognize that what I would like to do is write the word new 4 times. So Python writes this word 4 times. Here are a couple of other examples, string concatenation examples, but you get the idea as to how to join two words. You can concatenate one word, 2 words. So I can say something like, for example, 7 times new plus 4 times York. Okay, hit enter, and what Python does is write 7 times new and then 4 times York. So it depends on your own requirement, what it is that you're trying to accomplish, but just to give you an idea of string concatenation and provide several examples. Okay, next let's talk about string formatting. Strings can be indexed, superscripted, with the first character having index 0, and this essentially means that the way Python recognizes these words, for example, let's take the word New York here, okay, any word. What Python does, it assigns numbers to these words, right? Binary digits, for example. So it'll say something like 0, 1, 2, 3, 4, 5, 6. 0 essentially is the letter N, 1 is the letter E, 2 is the letter W, and so on. And there's no specific or separate character type. A character is simply the string of size 1. So for example, if I say something like word equals Python, so I'm assigning, this is an assignment statement, recall from our previous lesson. So I'm assigning Python as a word, or word equals Python. Now if I were to say something like word and then use my brackets and say 3, for instance, hit enter, is going to display H, which is in fact the 4th letter within the word Python. But recall and keep that in mind always, that the letter P is always 0. So Python starts with 0. So it's going to say 0, 1, 2, 3, which is the word H. So the H in this word Python, according to Python language, is at number 3. Similarly, let's say word 5. You guessed it, it's the letter N, or the last letter within this word. So just keep that in mind, that strings can be indexed with the first character having the index 0. On the other hand, we can use negative indices also. For example, strings can be indexed with the first character having 0, and you can run it backwards as well. So for example, within the same word, which I've already have it assigned up on top here, I can say something like word brackets -1. It's going to say N. Similarly, word brackets -2. It's going to display O. So in this instance, it's counting from right to left. So right to left. 0, 1, 2, 3, 4, 5, and 6. Notice the difference here. If I say something like word -6, it gives me the letter P, which is my first word. So it's 1, 2, 3, 4, 5, and 6. Okay, so you can either tell Python to index backwards or forward. You can use both values. It just depends on your own self. The triple quotes, powerful feature in Python. Python's triple quotes comes to the rescue by allowing strings to span multiple lines. For instance, if you were writing a paragraph, or you're telling a story, or you have multiple lines of text, we can use triple quotes. And the syntax for triple quotes consists of 3 consecutive single or double quotes. So for example, within my Python shell, if I say 3 quotes, this would imply now Python recognizes the 3 consecutive single quotes or double quotes as spanning to multiple lines. And end of lines automatically included in the string, but it's possible to prevent this by adding the backslash at the end of the line. So I can say 3 single quotes. This is a new story of Python language. Hit enter. Notice I'm able to now enter a new line, and I can continue on with my story. My name is John, and I love Python programming. And I can continue on until I finish my story. So as soon as I start, the idea here is that as soon as I start with the 3 quotations, whether single or double quotes, Python knows that now I need multiple lines of text within the string. Okay, so let me next clear the shell before I move to my next slide here. Okay, let's do the quick example of the 3 quotations. So for example, I can say something like print, and notice I'm leaving a single space in between, even though within my example here on the slide there is no space after the word print, but when I'm in my shell, notice there's a space that I leave. Okay, Python recognizes as no big deal whether I leave a space or if I start my parentheses right after the word print, so it doesn't really make any difference. So print, use the backslash. I'm going to New York next week to study. Enter a new line, and I can say something like chapter 1 of my studies, and I just tabbed, by the way. Python is great. Chapter 2, Python is awesome. Okay. And I can tab and keep writing as I go along. Once I'm done, I can simply use the 3 quotes again, close my parentheses, and automatically Python highlights the whole thing as, okay, it's done, recognizes this as a multiple lines text, and now it's going to print it. So it's going to say, I'm going to New York next week to study. Here's my text. So a powerful way of embedding this option within your code so that it's easier to write as you're writing the code in Python. Great. So in conclusion, we took a look at concept of strings, concatenation of strings, using numbers as strings, and identifying or understanding the concept of index. For example, the word Python, you can use these as indices and assign, and Python automatically assigns the first letter as is 0. And we also took a look at the letter R, where, for example, \n is to enter a new line, to avoid or to tell Python to skip over entering a new line, we use the letter R. And finally, the 3 quotations, whether single or double, if you need to use multiple lines within Python. So practice using strings, very important. We'll use this off and on almost all the time within our code. And let's move. In this lesson, I'm going to demonstrate the concept of the input function in Python language. But before we get into the input function, let me just briefly talk about the Python language itself. So the Python language is an interpreted, object-oriented, high-level programming language with several dynamic semantics. What it does is it allows for rapid application development. Python can be used as a scripting or glue language to connect existing components together. In other words, you can connect various modules and so on. Python's simple, easy to learn syntax emphasizes and facilitates readability and code reuse. So in essence, we use Python language in comparison to Java or other program languages like C++ or C++. Python is fairly simple, straightforward, and you can use Python both as an object-oriented or a functional language as well. Next, the Python input and output function. There are hardly any programs without any input. In other words, whenever you write a code or you write a program, you would like the user to enter something or enter some text or some values. And this input can come in various ways. For example, from a database, the computer, mouse clicks, and movements, or from the internet itself. And Python provides the function called the input, open parentheses, end parentheses. If the input function is called, the program flow will be stopped until the user has given an input and has ended the input with the return key, which simply implies that Python is going to prompt a user to enter something before it executes the next line of code. Here's an example. In this example, notice this is an assignment statement called name equals, here's the input function. So input, and then your string called what's your name. Next line of code, Python is going to print the string that says nice to meet you, plus the name, and then plus a exclamation mark. Next, it's going to prompt you with another input function called the age. So age equals input, and then your age. And then finally, the print statement is going to print the text string which says, so you're already plus age, plus years old, plus name, plus the exclamation mark. So really, there's a logical flow of things here. In other words, the user will be prompted to enter a name first, and then Python is going to display a message that's going to say, nice to meet you. Next, the user will be prompted to enter his or her age. And then subsequently, Python is going to display a message that's going to say, so you're already X years old, and print your name as well. Let me in fact demonstrate this using the Python shell here, using the idle. and let's see if we can create the input function. Okay, so I'm going to say name. I'm going to make an assignment statement here, just like it shows. And here's my input function, input, and then I'm going to use my string. I'm going to say, what is your name? And recall, these color coding is fairly straightforward and very important. The purple color is the function, and then of course your string is in green. And within the idle, I can execute one line at a time, right? But if I need to write a program or this entire script, then I would need to create or open up the new file by clicking on the file, new file, and here's my shell again. I'm going to minimize this so you can see. There we go. Okay, so let's write our program, which requires an input function. So I'm going to say name, or before I even say name, it's a good practice to use comments within your code. And we did take a look at how to enter a comment within the Python language in previous lessons. Okay, so let me in fact enter a comment first. Comments always start with a number sign. So I'm going to say number sign, the following will ask the user for a username or just for a name. And then I'm going to say name equals input, parentheses, and then of course my string. What is your name? Close my parentheses. So here's my first assignment statement. Notice in this instance, if I click enter, which takes me to the next line, and if I were to write the same within my Python shell here in the idle, if I were to hit the enter key, it would execute this statement, right? Recall the Python idle. All right, great. So we have our first line, and now we're in our next line. So next line, we're going to say print equals and display a message. Nice to meet you. And a space bar, which in fact adds a space to this message. Otherwise, it's going to combine the next character or variable that you're going to use. Okay, so we're going to say nice to meet you, enter a space, close my string, and then I'm going to add. Remember the concatenation, right? To join, which means I'll use the plus sign. So I'm going to say plus, and then I'm going to say name. Now what this does so far is all I'm saying here, display this message that says nice to meet you plus name. Now name in this case is what? Is basically the input function. So whatever you enter as your name in the first line of code, Python is going to display it right here where it says name. Okay, it's fairly logical, right? Step by step. And then I'm going to add plus and another string and my exclamation mark here. And close my parentheses. And Python tells me by highlighting it that the line is complete. Next, I'm going to enter. So far, I've entered 2 lines of code. The first line is just going to prompt a user to enter a name, and then it's going to print nice to meet you, and then the username with an exclamation mark. Next, I'm going to assign another variable here called age, do another assignment statement, and basically follow the same line of code here. What is your age? And then once my assignment is complete, and of course what I missed was the input function, of course, right? I'm going to say input, and then what is your age? Go to my next line. I'm going to say print equals so you are already and I'm going to add, right, the age here, plus I'm going to put some more text within the strings, years old. Notice how I'm in fact writing an English statement here or sentence. All I'm doing is telling Python to enter age from the preceding line of code, right? Anything else is basically in green is all text. So you're already plus age plus years old. And of course I can always leave a comma and a space. It's part of my English language. And then plus the name again, plus my exclamation mark. There we go. Okay, so let me expand this so we can view the entire code. Great. Since I've written this code, let me execute this code by clicking on the Run menu option and then run the module, where I can use the keyboard shortcut using the F5 key. So once I click on the Run module, of course Python asks me or wants me to save this module before it gets executed. So I'm going to click OK, and I'm going to scroll up to my Documents folder, Data Files, and then my Python folder, and I'm going to say my input function, and of course the save as type is always .py or .pyw. Click Save, and here's what Python does. It executes the first line of code and prompts me, because I've used the input function, and prompts me, what is your name? So I'm going to say John, enter key, what is your age? Of course it's not my real age, I'm going to say 22, and then it ends the program here. Now notice it doesn't really do the print, right? So let me go back to our code here. Move this aside so you can see. Okay, so let's evaluate this. First it says name equals input, and then it says what is your name? Of course, let's add a space here, because once I add a space here, notice in my results you'll see a space after the name. Or I can even make it better. I can put a colon here to make it look nicer. So it's going to say what is your name, colon, space, and of course I can always add a question mark because it's a question. Here we go. Okay, but notice there's something wrong with the print code here, because it's not asking me the next line. In fact, when I enter my name, it should print nice to meet you and my name. And of course the reason why, because right after print I do not need an equal sign, because this is not an assignment statement. This is simply a print command. Okay, so print parentheses nice to meet you, and then of course my rest of the code. Same thing with the print after age. I'm going to delete the equal signs here, and here we go. So just one more time, let's evaluate line by line. So it's name, my input function in purple, and then my green in strings, and then it's going to print nice to meet you, which is fine. Age, another assignment statement. It's going to ask me for my input, what is your age? Use a colon and a space here as well, and of course it's going to print, and it's going to say, so you're already age, years old, space, and then name, and so on. Okay, let's run this code one more time by clicking on the Run module. Click OK to save. And the first line of code is what is your name? So I'm going to say it's John. Hit the enter key on the keyboard, and Python displays nice to meet you, John, and then prompts me for the next input. What is your age? I'm going to say 22. Of course, that's not my real age. Hit the enter key, and Python says, so you're already 22 years old, comma, space, John. And notice after 22, there's no space between 22 and years. So I can go back to my code and make sure I have a space here. So we get the idea of the input command. Of course, I can build more. So if I need to say something like color, make an assignment statement, and say, what is your favorite color? Simply need to make sure that it's an input So once I create another input function called color equals input, what is your favorite color? Same thing, question mark and a colon, and add a space. And then I can say something like print, so your favorite color is, and then I'm going to add the color, because whichever color I enter as an input will be displayed here where it says color. And then of course I can add an exclamation mark if I want to, and close my parentheses. Okay, let's run this one more time. Click Run One Module, click OK to save, and my first prompt is, what is your name? So I'm going to say it's John. Nice to meet you, John. What is your age? It's 22. So you're already 22 years old, John. What is your favorite color? My favorite color is purple. So your favorite color is purple. Great. So very powerful, the input function in Python. You can take a look at it, and you can save this module called myInputFunction.py, or you can call it any other name, and you can keep building the module as you move along. So it depends upon your own requirements, and for practice using the input function, such as enter a number, add two numbers, and so forth, the sky is the limit. But I just wanted to ensure that you get the concept of the input function. Now, one more thing before I end the lesson here is that we use the comment code in the first line. For instance, the following will ask the user for a name. Now, after that, there are no comments, but it's a good idea, like I mentioned earlier, to use comments. You can use comments in a separate line or in front of the code itself. As long as there's a number sign to start with, Python is going to recognize that as a comment and ignore whatever follows after the number sign. So here, for instance, I can say something like age. In this line, I can enter a comment. This will prompt the user to enter age. Okay, so let me expand that a little bit so you can see. Great. So same thing I can do for the color here. This will prompt the user to enter the color. So this way it's easier when you're writing code and someone else is taking a look at the line here, for instance. They would know exactly what this code would do, or what this particular line would do. Like this will prompt a user to enter color. So a couple of ways you can use it. You can use it as a separate line. For example, I can just copy this, cut this from here, enter line, and paste. So I can use this convention as well. So whichever is easier for you, you can do both or either or. So it depends on your own requirements and your own style of writing code. So the input function is very powerful. It simply prompts the user to enter a certain text or value so you can evaluate and write the code. So practice, and let's move to the. In this lesson, I'm going to demonstrate how to use Python code and to be able to read and write files and even create new files on the fly using the Python language. First, a little word on reading and writing files. The first argument is a string that contains the actual file name. So whenever you're writing the code itself in Python, the very first thing you need to identify and tell Python is the fact that where is the file located. Okay? And then of course the name of the file. The second argument is another string that contains a few characters describing the way in which the file will be used. So for example, it could be read, which is R, W for write, or A for append. So it depends on your own instruction to Python what it is that you want Python to do with this file. So in essence, what we're doing here is we are telling Python to go into a certain directory within our computer, locate the file, and then either open it or write some text to the file, or add text to an existing file. And this is useful because when you're coding or programming using Python, many times you need to access certain files within your code. So in order to do so, we use the file open command, for example, and we use other methods, for example, in Python, to be able to read and write files. But just so that you get an idea of the basic concept of reading and writing files. So in essence, it's just the path of where the file is located, and if it's not located, in other words, when you tell Python to go and access the file and it doesn't find the file there, what Python would do is that it has the ability to create the file. Okay, so just wanted to elaborate upon the concept of reading and writing files. Here's the syntax of reading and writing files using Python. So the first line is file equals open, pretty straightforward, and then of course you need to define the path. This is where the file is stored or saved on your computer. For example, it could be in a certain folder, it could be in a certain subfolder, or multiple folders. So you need to first know the path and then be able to write the path here, and that's how Python is going to go find it. Remember, whatever instruction you give to Python, it's going to do only what you provide to it. And then the second aspect of this is the actual file name. So you need to be able to know which file name Python should go and open. The W here that you see is for write. So what Python is going to do is, for example, it's going to first go to this path, find the file name, and if it doesn't find the file name that you specify here, using the W option, Python is going to create the file automatically. Okay, so it's going to create the file and it's going to give the name, whatever name you specify here as your file name. So that's your first line of code. Next, you will tell Python to write within that file, and the syntax is file.write, and of course the sample text, and this could be anything. So it's just populating your text file or your document or whatever file you're creating. And then our last argument is file.close, and this is useful because it will not use the buffering within your computer, and it will close the actual file name. Otherwise, you may not be able to see the sample text that you write in the file. I'll demonstrate that as I move forward. A word of caution here is that you need to be careful when using the write option or the W. And the reason why is because when you use the write option, Python is going to write to that file. So for instance, if you have a file created and has some text that contains multiple lines or paragraphs or whatnot, and you were to rerun this code with some new text instead of your original text that you specified earlier, Python is going to wipe everything out and then provide you the new text. So keep that in mind, and I'll demonstrate that as well. Okay. So here's an example. Let's take a look at this syntax here. It's file open, and then of course the path. So it could be in this folder and then subsequent folders. It could be multiple level of folders within your computer. And then finally the name of the file. In this case it's hello_again.txt, and then our write option. So when I execute this, for instance, Python is going to go to this location and then try to locate the hello_again.txt file. If it finds it, fine. If it doesn't, it's going to create it. The next line is file.write, and this is some sample text. So for instance, Python is going to open this file called hello.again.txt. If it doesn't find it, it's going to create this file and then write the text within this file, and finally close this file. And this close is not actually closing the document or the file, but actually just making sure that it doesn't stay in the buffer. Okay, so let's take a look. Let me in fact demonstrate the reading and writing files in Python. So here's my Python shell. I'm going to open up my idle here so I can write the actual code. So I'm going to click on File, New File, and this opens up my Python idle so we can write the code. And my first line, of course, is my comment here. This will provide Python instruction to locate the file, and if not located, then create the file. And once again, these comments are very useful because when you're writing large sets of code, this will be very useful when you revisit the code itself, because you're breaking down the code and you're telling yourself or setting up reminders or in fact explaining what is happening within the next lines of code. So here's just a comment that I started off with, and then I'm going to say file equals open the parentheses, and of course my string, and here's the path, users, folder here, documents, data, files, Python, and then of course the name of the file. So in this example, I'm just going to use some other file, and notice Python is smart because it displays a list of all the files that are stored in this path that I just typed. So if I know the existing file, I can simply select from any one of these files. If not, I can type my own name here. So let's say I'm going to say something like new sample file.txt, and then I'm also going to make sure that I have the right option here. So in this instance, Python is going to go to this folder. Let me in fact make it larger so you can see the entire code here. Much better. Great. So Python is going to go to this location all the way down to the Python folder here within my subdirectory or the folder level structure, and then take a look and see whether the new sample file.txt exists or not. If not, it's going to, and then once this is created, my next line of code will be, of course, to write something within this file. So I'm going to say file.write, and this is the method that I'm using, and we'll get to methods once we move along into subsequent lessons. I'll explain what those are and the concept behind those, but for right now it's just a built-in method that we use to tell Python to write something. Okay, so here's the parentheses, and of course my string. I'm going to say my name is John, I enjoy, something like that. Okay, all right, great. So once I'm done, I'm going to close the parentheses here, and I'm not going to use file close for now. I'm in fact going to run this just so that I want to show you first what happens or what Python does once you just tell Python to open a file, if not, create the file and then write something within the file. Okay, so of course I'm going to go to run, click on run, and then let's click on run module. Of course it wants me to save, the source must be saved. Click OK to save, and let me navigate to my documents folder here, and then under data files I have my Python folder. So here are all the Python files already listed within this folder, and notice at this point, if I make this a little bigger so you can see all the rest of the files, there's no such file that's called new sample file.txt within this folder. The only files that I see have the extension .py, so these are Python files. So there's no text file within this particular folder. Now you might also be wondering, how do I know the path? Like for example, this path up here. How do I know what to type? Where is the path? How do I find the path? Well, a couple of ways you can do it, and I'm going to demonstrate that next, but let me first save this file, and I'm going to call it mysample.py. And notice we're not actually saving this file. In fact, Python is going to create this file for us called new sample file.txt. We're actually saving the program or the module called mysample, and click save. And what Python does, it restarts the shell and then creates the file within the mysample.py. Now when I go to mysample.py and open it, I should be able to see something like, my name is John, I enjoy fishing, and this text will be part of the new sample file.txt. So let me next open up my Windows Explorer, navigate to my Python folder, and let's see whether we have the new sample file.txt created or not. So I'm going to open up my Windows Explorer here, and within this, here we go. So we have our new sample file.txt created. If I were to open this file, notice this file is currently empty, even though within my code I have some text that I wanted this file to display. So Python first went to this directory, saw that there's no such file name called new sample file.txt, so it created this file but did not really add any text to it. And that's why we need to close the file, because we need to make sure it takes it out of the buffer, right? So let me navigate back to our, let me close this for now. So here I'm going to write another line called file dot close. Okay. Now if I rerun the module, click on run module, of course it wants me to save. Every single time when I make some changes to the module, click OK, restarts the shell, runs the code, and let's navigate back to our Windows Explorer. And this time when I open the new sample file.txt, notice here's my text. It says, my name is John, I enjoy fishing. So this is how you would simply create the file, tell Python to either read a file. If it exists already, just use the R option within your code. If not, use the W and it will create the file and write the text to it. Let's close this. Let's go back to our code here. So this gives you an idea of how to use the file open, how to read a file, how to open a file, and how to write and add text to it. Now what happens when I in fact add more text? Of course, if I add text here and rerun the module, it's going to add some more text. Let me in fact demonstrate this. So my name is John, enjoy fishing. I live in Chicago. And let's run the module again. Click OK to save it. Make sure the shell displays that it ran the mysample.py file and the new sample.txt correctly. And let's navigate to our Windows Explorer. Let's click on new sample file text. And of course, it adds to this file. Here's what you need to be careful of. What, for example, you were to change or add text within this new sample file.txt. So if I write something like, I enjoy watching football, and I simply save this file. This is a text file now. I can use my keyboard Control S to save, or I can click File, Save, and close it. If I go back to my code here in Python, Python doesn't really know whether I made any changes to the file or not. Only I know that I added some text to it. If I were to run this module again without anything, Python is going to ignore the additional text that I added to my text file. In fact, it's going to rerun the same code and only display this text up till here. I live in Chicago. Let's demonstrate this. So run, click on run module. It successfully ran this. Let's get to our Windows Explorer, open up new sample file.txt, and notice at this point I enjoy watching football is gone. I live in Chicago. And that's what I meant by when I mentioned earlier that you need to be careful using the W option in your code. Every time you use W, it's going to write the text based on your code. So let's close this, get back to our code here. Alright, so what is the way out here? What do you do? So instead of a W, if you need to add some text to the file, you would use the letter A for append. And if you use that option, then Python is going to append text to your existing text. So it's not going to write over it, it's going to add to your text. So just to give you a word of caution, I want to demonstrate this so that you understand the concept of reading and writing files and how Python uses the file open, file write, and file close options or methods. But before I even end this lesson, let me in fact demonstrate the append option for you as well. So for example, I'm going to use the same path here, same file. Instead of a write, I'm going to use A for append. And what this would do is add text to my existing file. So for instance, the current text within this new sample file.txt is my name is John, I enjoy fishing, I live in Chicago, and hello there. Okay. So if I were to append, use the A option here, within this, it's going to append the text. But before I even use the append, let me first, from scratch, rerun the write file, and then I'll use the append. Okay, so I'm going to switch back to my W here and run the module. It's going to save and then show you first going to Windows Explorer, open up my new sample file.txt, and here's the current text. So at present it says my name is John, I enjoy fishing, I live in Chicago, hello there. So this is the text within this file. Let's say I'm going to make some changes to this text. I'm going to say I'm going to visit New York tomorrow. Okay, so I added some text to the new sample file.txt file. At this point, of course, Python doesn't know that I've added this, so I'm going to save this file, save, and close the text file. Let me get back to my code here. Now once again, if I were to run the module again, it's going to delete my addition that I added to the text file, of course, because I'm using the write option. But in this case, if I use the append option instead of W, I'm going to say letter A for append. The text remains the same. In fact, I'm going to remove all of this text. I'm going to append and create some new text. In New York, I'm going to see the Statue of Liberty. Okay, now to recall, I'm using the letter A, which is append option. So in this case, when Python is going to write this particular text within this string, it's going to append to my existing text within the document. So let's run this. Let's click on run module. Of course, source must be saved. Click OK. And it successfully ran. Let's go to our Windows Explorer. And here's a new sample file text. Let me open this. And let's see what Python did. Great. So it said, I'm going to visit New York tomorrow, which is fine. In New York, I'm going to see the Statue of Liberty. So this text has now been appended to my existing file. So it did not really delete or erase all the text because I did not use the W or the write option. So be careful using the W, use append instead if you need to add to this file. Whether you add directly to the new sample file.txt or you use the Python code, either way you have the option to either append or write the text. So pretty powerful. Play with it, practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate and talk about Python expressions and operators. So what are expressions? Essentially, expressions represent something, for example, like a number, a string, or an instance of a class. And any value can be an expression. So for instance, you may have something within the parentheses, or if you're trying to evaluate 2 plus 4, and that would be an expression. Anything that does something is a statement, on the other hand. So for instance, if you assign a variable to a statement, for instance, let x equals 2, so in that instance, that would be a statement. So it's not an expression, it's a statement. And we have been doing this in the previous lessons where we have assigned or created an assignment statement. So any assignment to a variable or function call is a statement. Any value contained in that statement, however, is an expression, right? So for instance, if the variable is x equals 2 plus 4, then that 2 plus 4 would be an expression, and the entire line of code would be a statement. So just quickly, I wanted to talk about the Python expressions, and then next I'll demonstrate and talk about the operators as well. But before I talk about operators, let's take a look at this example. So in this example, it's a statement called howdy equals hello, which is a statement that assigns howdy to the value of the expression hello. So the word hello in quotes is an expression, and howdy equals hello is a statement. Since the code hello is a simple expression, meaning it contains no operations, nothing is actually evaluated. So howdy is just assigned to hello. On the other hand, let me next demonstrate. For example, if I say something like y equals 2 plus 4, something like that. Okay, so this part would be an expression, the entire line of code would be a statement. So just to give you an idea of the difference between the statement and the expression in Python. Operators are the constructs which can manipulate the value of operands. So for example, if I were to say something like 4 plus 9, and hit the enter key, the answer is 13. So this is going to evaluate. So this is in fact evaluating the contract 4 plus 9. So here once again, 4 and 5 are called the operands, or 4 and 9 in this example are the operands, and the plus sign in between is called the operator. And this could be plus, minus sign is an operator, divide, and so on. So Python language supports many kinds of operators. Some of the basic ones that I'm going to cover in this course are arithmetic, comparison, and assignment operators. The other ones are, for instance, bitwise operators, which I'll discuss in my subsequent courses. But for basic Python language, these three are pretty common when you're typing code or writing a program. So arithmetic operators, comparison or relational operators, and then our assignment operators. So next, let's take a look at each one of these in details, and I'll also demonstrate some examples as well. Here are some of the basic arithmetic operators. So for instance, you can do the addition, subtraction, multiplication, division, modulus, which is represented by a percent sign, exponent, and then our 2 forward slashes, which is called the floor division. And these are different types of arithmetic operations. In fact, the basic one I demonstrated earlier by saying 4 plus 9, which is 13. Similarly, I can do 5 plus 6. I need to have my plus sign here. 5 plus 6 is 11. Similarly, I can do subtraction. I can do something like 12 minus 4. Pretty basic, straightforward stuff. Now, multiplication is also the same way. I can multiply 7 times 7, which is 49. I can also divide. So I can say something like 10 divided by 2 is 5. With the modulus, I need to use a percent sign. And what modulus is simply, it shows you the remainder, right? So if you're dividing something like 3 divided by 2, for example, the remainder would be 1. But in this instance, since we're using Python 3.5 version, you will get a floating number. This number is also known as a float number. In other words, it has certain decimals to it, so it's not a whole number. So this will be the exact answer to 3 divided by 2. But if you were to use Python 2.7 version or earlier versions of Python program, then it would show you the remainder. Let me in fact demonstrate another example. Let's do 9 divided by 4. It's 2.25. Okay. So this is a simple division which we're doing, which is right here. Divides the left-hand operands. Now what about modulus here? Okay. I need to know the remainder. So if I need to do 9 divided by, instead of division, I'm going to use percent sign this time because I'd like to find the remainder of 9 divided by 4. So hit the enter key and notice it's 1 because 4 only goes one time in 4, so 4 times 1 is 4, 4 times 2 is 8, and the remainder is 1. Okay, so straightforward. So when you use the percent sign in Python, this operator is used for remainders. Exponents, which is to the power of, for instance. So if I need to say 2 to the power of 5, this would be 32, which means 2 times 2 times 2 times 2 and times 2. So it's 5 times 2 is 32. And this is represented by the operator called 2 asterisks, right? Or 2 stars. And floor division is the same way. For instance, if I need to do 9, use my 2 slashes divided by 2 will give me 4. So the division of operands where the result is the quotient in which the digits after the decimal points are removed. So it's 4 in this instance. So pretty straightforward, the arithmetic operators. A couple of new ones that you may not be comfortable with, such as the 2 asterisk for exponents, and then the 2 slashes for floor division, and then the percent sign for the modulus. But the other ones like plus, minus, multiply, and divide are straightforward. Okay, let's take a look at the comparison operators. In this instance, the first operator is the 2 equal signs. So if the 2 values of the 2 operands are equal, then the conditions become true. For instance, if I were to say something like 2 is equal to 2, which is true. So Python returns the value as true. If I say something, on the other hand, like 3 equals 3, which is also true. But in this next example, if I say 44 equals 54, and notice in this instance, Python returns the value as false. So likewise, the exclamation mark, equal sign, if values of 2 operands are not equal, then the condition becomes true. Similarly, if values of 2 operands are not equal, then the condition becomes true, which is represented by the operator greater than and less than sign, which is similar to the exclamation mark equal sign operator. Then of course we have our greater than sign, less than, greater than or equal to, or for instance the last operator is less than or equal to. If the value of the left operand is less than or equal to the value of the right operand, then the condition becomes true. So we can use any of these operators or comparison operators in Python when you're evaluating expressions. So for instance, if I say 2 is greater than 4, it's going to say false. If I say 5 is less than 1, it's going to say false. Likewise, I can continue and say 8 is greater than 9. This is also going to say false because 8 is less than 9. So you get the idea. So this way we can work with comparison operators as well. And the last ones are the assignment operators. Here, for example, is just an equal sign. And this simply assigns the value from right side to the left side. And notice this equal sign does not mean that the two sides are equal. In Python, if you want to make two sides equal, then we use the double equal signs. If I were to use something like x equals 2, this is an assignment statement. So you're assigning variable x as the value of 2. And if I hit enter and assign y equals 4, and all I'm doing here is assigning the variables x the value of 2 and the variable y the value of 4. So if I say x plus y, and notice I'll get the value 6 because Python knows that the value of x is now 2 and the value of y is 4. So when I add these two variables, I'll get the answer 6, which is different from the two equal signs. So keep that in mind when you're working with different operators in Python. A single equal sign is essentially an assignment statement. Same thing, plus sign equal sign, minus equal sign, multiplication equal sign, and then the division equal sign and our modulus. So each of these operators will allow us to evaluate expressions and write our code accordingly depending upon our own requirements. Practice with these expressions and operators, and we understand the concept as well as the differences between assignment statements, expressions, and operators. And let's move to our next lesson. In this lesson, I'm going to demonstrate how to create a simple Python program. But before we in fact dive into the actual Python programming language, a few concepts along the way are always helpful. First, let's talk about what are commands and functions in a programming language. So all programs are partially constructed with various functions. Basically, a function is nothing but a set of instructions performed by the computer when instructed. And you might have heard this term function over and over again. If you dive into any programming language, a function is nothing but simply a set of instructions. For example, the print function. So let me demonstrate this, for example. Let me go to my Python shell here, the idle. And I'm going to say something like print and just say hello world. And Python would do as instructed as soon as I use the print function. And here the word print is a function and hello world is our parameter. So what Python does, it color codes the function called print in purple and then a parameter in green. And of course, you can create your own color scheme by going to options within the shell. But by default, this is how Python color codes it. And the output is color coded in blue. So once again, the word print is a function and hello world is our parameter. And typically, you would just call that function by typing the word print. Okay, next is Python data types. What I've done here is I've compiled some of the important ones. There are others as well, but Python has many native data types. And here are some of the important ones. For instance, we can use the Boolean operator such as true or false, and we've seen this in our previous lessons as well. The next is numbers, and numbers can either be integers such as 1, 2, 3, 4, and so on, or floats such as 1.1, 1.2, fractions, 1 divided by 2, 2 divided by 3, and so on, or even complex numbers. So the important things to note here is that numbers in Python can either be integers, floats, fractions, or even complex numbers. Strings are sequences of Unicode characters, so for example, such as an HTML document. Bytes and byte arrays is another Python data type. An example would be a JPEG image file or a PNG image file. Lists are simply ordered sequences of values. So for instance, you could create a list in Python that contains colors, orange, purple, yellow, and so forth. So you're building a list. Tuples are ordered immutable sequences of values. These are very similar to lists, but they are permanent, right? So you can't really change them until you convert them back into a list. And dictionaries are unordered bags of key value pairs. So not to worry about some of these data types at this point. I'm going to have other lessons that are going to explain each one of these, and we'll of course program using Python each one of these data types. But for now, just giving you an idea of what Python data types are important, so that if they come across, you would know what they mean. And most times when you're creating a program, you'd use any one of these data types. Very important, Python is case sensitive. So all names in Python are case sensitive. So variable names, function names, class names, module names, exception names. If you can get it, sell it, call it, construct it, import it, or raise it, it's case sensitive. Okay, so just keep that in mind when you're working in Python. And let me in fact demonstrate this one more time. For example, if I were to say something like print using the capital P as opposed to the lowercase p, and notice automatically it does not color code. So Python does not color code the capital P because it doesn't really know. But in any case, let me demonstrate. So I'm going to say print, and I'm going to say my name is John, spelled correctly, and then close my parentheses. Now my parameter is correct, so there's nothing wrong with my parameter because you can see the color code automatically. So this is one good way and a valuable way of using color coding, and Python does that for you. So while you're writing your code, you don't have to worry about whether I'm writing correctly or incorrectly. It automatically would not color code the function. So if I were to execute this, click enter, and notice I will get an error because Python does not recognize the name print is not defined. Whereas if I were to use the lowercase one more time quickly, and Python is going to print the output. So Python is case sensitive. Keep that in mind when we're programming in Python. Objects, another important area in Python. Everything in Python is an object, and everything can have attributes and methods. And we'll get to attributes and methods and classes later on, but right now just understand what are objects. So all functions, for instance, in Python have a built-in attribute such as _doc_, which returns the doc string defined in the function's source code. And the sys module is an object, for instance, as an example, which has an attribute called path. But here, just for now, everything in Python is an object, and everything can have attributes and methods. So this is the important element that you need to know about objects at this point. We'll get into detail. I'll have a separate lesson on objects. A few important things about objects. Different programming languages define object in different ways. For instance, in some programming languages, it means that all objects must have attributes and methods, In other programming languages, it implies that objects are subclassable. In Python, the definition is much broader. So in Python, some objects have neither attributes nor methods, but they could, on the other hand. And not all objects are subclassable. However, everything is an object in a sense that it can be assigned to a variable or passed as an argument to a function. Another important element when you're writing a code is indenting your code. Code blocks are defined by their indentation. And by code block, we simply mean functions, if statements, for loops, while loops, and so forth. So for example, let's open up a sample Python file by clicking on File, Open, and let's navigate to our Documents folder, Data Files, and Python folder. And here are several Python modules here. For example, I'm going to select one of them, like myInputFunction.py, open, and here's the code. So it depends on your own requirements how you indent. Python doesn't really specify the indentation rules per se, so you can create your own indentation. Typically, it's just blocks of code. So in this particular scenario, the variables are, for instance, name, age, and color, and the rest of the code is indented. And using blocks of code and indentation simply helps you as a developer or a programmer to go back and revisit your code and add lines. And that's very common in programming. So when you're writing a program, you'll always go back to one of the code blocks and add to it. It's not something like you would just write one program and that'd be the end of it. You would have to revisit your code and add, because requirements change, or your logic within your program entails that you need to go back and change the code or add more lines to your existing code blocks. So I just wanted to quickly show you the concept of indentation. So let me close this. So code blocks imply functions, if statements, for loops, while loops, and so on. Indenting starts a block and unindenting ends it. And there are no explicit braces, brackets, or keywords. This means that white space is significant and must be consistent. So when you're writing code blocks, you need to be consistent. Another important element of writing your first program is we need to follow a simple logic, right? So whenever you write a program, it has to be logical. And a flowchart is the best way to not only understand logic, but also document your program as well. All programs start with a logic. In other words, there's a start and there's an end. So in this particular example, it starts by asking a question, is it raining? And the diamond represents the decision box. And if it is raining, the next step would be to ask, do you have an umbrella? And if the answer is yes, only then you will be able to go outside and the program would end, which means the answer is true, therefore you'd end the program. However, if you do not have an umbrella, then in your code you would ask or write another line, such as wait a while, for instance, and then after a while check whether it's raining again or not. If it's raining, you will loop back to wait a while, because you have to wait until the rain stops. But if the rain stops and it's not raining, so if the answer is no, then you would go outside and the program would end. So very simple logic. So anytime you write a program or you think of creating a program, think of your program and follow logical steps in order. And each step would then contain your code block, right? So you would create a code for, is it raining? You would create a code for have an umbrella, wait a while, you do a loop here, a code for loop block, and then end the program. So just a basic simple logic that you would follow. And it's a good idea to first document or diagram your program itself that you're about to create before you actually start using Python shell and start creating your program. And since this is a beginner's course, it's always a good idea to use few words on comparison operators one more time. We did take a look at these operators in earlier lessons, but just quickly, the not equal to, or the equal to rather, as a first operator is your double equal signs, right? Not equal to is exclamation mark, equal sign. Then we have our less than, greater than, less than or equal to, and greater than or equal to. So these operators are helpful because when you're writing your code, you would use most of the times, quite frequently, these operators. Okay, finally, let's get to our program. Let's see if we can create a simple program in Python so that you take a look at, and I'll demonstrate what Python can do. First, let me go ahead and open up our Python idle here. So by clicking on File, New File, brings up the window. Let me minimize this so we can actually see. Okay, so let's begin by writing a simple program, and we'll try to use some of the concepts that we've talked about earlier and in previous lessons as well. So in this program, I'm going to use a simple logic. First, I'm going to ask the person's name, the person's age, and ask a couple other questions such as what's the temperature outside and whether they would like to go work out or not. And I'm also going to use some condition or loop as well. For instance, it would be something like if the temperature is greater than 70 degrees outside, then you ought to wear certain types of clothes, and so forth. So you get the logic, right? So it's a simple program that is going to be made in Python. So first, a good convention is always use the number sign, which is your comment code here. And I'm going to say enter your name. And add a few spaces. Then I'm going to use an assignment statement using a variable called name, and then my input function. Notice every time you use a function, Python color codes it, right? Whether it's the print function or the input function. And then I'm going to say use a string called what is your name, and add a few spaces and a question mark, of course, just so that when it prints in the idle, it allows for a space. Otherwise, it would not, and you would have to use or enter a name without a space in between. Okay. So once I've created the input function, so the first line of code is going to ask the name of the person, and then the person is going to enter the name, and then I'm going to tell Python to print hello, and then of course concatenate or add the name variable here. And then I can always use something like concatenate more, and maybe an exclamation mark, and close my parentheses. Okay. So here's the enter your name. Next comment, enter your age. Same thing, we're going to repeat the first function here called the input function. So this will be age at this point. Age equals input, and use a string what is your age. Okay, so just repeated the first function that we used earlier as name. So age is the same one, so I'm going to tell Python to print once the person enters the name. Python is going to say that's great, and then of course I'm going to use the variable called name, concatenate one more time, and use my exclamation mark as well. Okay, great. Next comment, next logical step would be to ask for temperature outside, and here I'm going to use the same thing, temperature equals. Now in this instance, the temperature can be 71 degrees, 72 degrees, 68 degrees, or it could be 68.2, or in decimals, right? So the temperature is not an integer, it could be a floating number, right? So recall the data types in Python. So it could be float. So we cannot really use the integer value. What if the person enters 72.1 degrees, where he looks at the temperature and the temperature scale shows that it's 71.2 degrees. But if you do not specify or tell Python to get the input of a float number, of course it will not work. So we need to make sure that we add the data type called float. So it's temperature equals, I'm going to use float, and then I'm going to use my input function, right? So it'll be float input, and then parentheses one more time, and use my quotations. What is the temperature outside? And of course I can always use the name as well, or I don't have to. It just depends on your own logic, right? And the exclamation mark, and close the parentheses. And recall, since we began with 2 parentheses, I'm going to use 2 parentheses to end this, right? So one for the input and the other one is for the string as well. So go to my next line. Let me in fact make it a little larger so you can see. Okay, so here's the temperature equals float input. What is the temperature outside? And of course it's going to add or concatenate the name and plus our exclamation mark, not the 1. Okay, so so far it's going to prompt again for an input or ask the user a question, right? Like, what is the temperature outside? And then I'm going to add a condition to it, right? So I'm going to say if temperature is greater than, right? This is the greater than sign, the operators, remember, is greater than 70, then print. And notice as soon as I hit enter, recall we talked about using a semicolon, right? So you enter a semicolon, that means indent. So Python is going to indent the print here. So I'm going to say print. So if the temperature is greater than 70 degrees, then wear shorts. Okay. And then also I'm going to say a couple of other things like print, enjoy your day. And I'm going to concatenate one more time with the name. Okay, so just a simple print function. So if the temperature, first it's going to ask what is the temperature outside. If the temperature is greater than 70, then the output is going to be wear shorts and enjoy your day, and then display the name. Of course, if I'm using if, what if the temperature is not 70 degrees outside or greater than 70 degrees outside? Then what should be done, right? So we need to also specify that. So I'm going to say else, and of course indent again, simply print, and I'm going to say wear long pants, and use the name again. And notice I'm being consistent with my coding here, right? So I'm making sure that the output is consistent at all input. So here's my exclamation mark, and I'm going to do another print here, and I'm going to say wear long pants and get some exercise, or get some good workout, or get some exercise. Fair enough. Okay, get some exercise outside. Okay, great. So what are we doing here? We're entering a name, asking for a name, asking for the age, and then simply using a logic by first specifying a float number as temperature, And then if the temperature is greater than 70, wear shorts, enjoy your day. Otherwise, else, wear long pants and get some exercise outside. Okay. So once your code is complete, let's do a save, and I'm going to call it temperature. Click save, and let's run the module and see what happens. So first, click on run module, and the very first thing that Python asks is, what is your name? So I'm going to say it's John. It says, hello John, what is your age? I'm going to say 22, of course not my real age. That's great, John. What is the temperature outside, John? So I'm going to say it's 78.6 degrees. Wear shorts. Enjoy your day, John. And the program ends. Okay. So notice here the last part that is printed is get some exercise outside only if the temperature is less than 70. Otherwise, I'm going to get this message. Enjoy your day, John, right? Let's try again. Let's run the program again, and this time the temperature is going to be less than 70, right? So in my first example, I showed temperature as being greater than 70 degrees. Next time, if the program runs again, let's use a value that is less than 70 and see what happens. So let's go run module again. And what is your name? I'm going to say John one more time. Hello John, what is your age? It's 22, that's great. What's the temperature outside? So I'm going to say it's 68 degrees. And automatically I get the message saying, wear long pants, John, get some exercise outside, right? So this way you can create your own program by following a simple logic and of course using comments within each code block. So in this lesson we created our first Python program with a simple logic, and of course it's always a good idea to create a flowchart of your program first before you actually write the program. Now of course you can always go back to this code and add more to the code as well. For instance, if you need to add another print function here under name, so it will first ask you what is your name, and then it's going to say hello John, and then I'm going to say hope all is well. Of course I need to use my string here. Okay, and then of course if I run this again, click on the run module option, of course it's going to save first, and it asks what is your name. We'll say it's John, and notice it says hello John, hope all is well, what is your age, right? And then it goes to the next line, age, and it's going to prompt you for the age, and then the temperature block is going to run again. So this way you'll have to revisit your code and make changes to it because the requirements may change, and that's why it's helpful to use blocks and use spaces in between your code blocks, use comment code, and of course the color coding helps in Python, and you can start building your code as you move along from one program to the other. So practice creating a simple program, follow simple logic, and let's move to our next lesson. In this lesson I'm going to demonstrate how to use comments in Python. We have been using comments in previous lessons, but here I'm not only going to talk about comments but also a couple of other things that relate to the concept of placing comments in your Python code. So first, as programs get bigger and more complicated, they obviously get more difficult to read, and it is often difficult to look at a piece of code and figure out what it is doing or why is it doing so. And it's always a good idea to add notes to your programs to explain in natural, plain English language what the program is doing. In Python, these notes are called comments and represented by the number sign symbol. So here's a small example of placing comments in Python. So for instance, if I were to bring up my shell here by clicking on File, New File, and let me minimize this or make it smaller so we can see. So here, for example, if I were to begin writing code or create a small program in Python, I'd have to start with the number sign. So anytime I start with a number sign, Python first of all color codes it as in red, and as soon as I begin with the number sign, Python knows that this is a comment. In other words, Python will ignore this line while executing the code. So here, a simple example, I can say something like this is a print function, and I can say something like print, how's the weather today? And I can simply place a new line here, and I can do something like print, happy holidays. And I can always click on run and then run the module. Of course, Python wants me to save this first. I'm going to click OK, and it's going to run how's the weather today and happy holidays. Let me bring up my code here so we can also see this. And here's our simple code. So the comment first is obviously the first line, which is this is a print function. And then of course my code begins following that. If I need to place a line after the word today, I can simply say comma and then recall, it's the \n for the new line, and run the module again. Click OK to save, and this time Python displays a line between the two sentences. So simple concept of using comments. So let me close this for now. Similarly, every time you start writing code, you're going to place a comment such as compute the percentage of the hour that has elapsed, and then write your code, and then place another comment. And comments can be placed either as an individual line or right beside your code, as long as they start with the number sign, and that's important. Okay, choosing variable names. As long as you follow these simple rules of variable naming and avoid reserved words, you have a lot of choice when you name your variables. In the beginning, this choice can be confusing both when you read a program and when you write your own programs. Now, variable names can be, for instance, if I go to my shell here, can be x equals 5. Obviously, you've created a simple assignment statement. Or it could be underscore y underscore equals 3. Okay, now this is the same thing as assigning a variable name. So depending upon the convention or your own choice, you can create using variable names. And you want to be consistent in your programs when you're creating and writing code and using variables. So for example, if you're using underscore y underscore as one of your variable names, then all of the other variables that follow should follow the same consistency. And it's easier because as your code grows larger, you would know, or you can identify the underscore y underscore or any letter that has an underscore implies it's a variable name. So this way you can pick and choose and define your own variable names. So here's an example of creating variables. For instance, if I were to say something like a equals 35, b equals 12.5, and c is the multiplication of a and b, and I can print c. So for instance, quickly, I can say a equals 35, b equals 12, for instance, and then finally c is the multiplication of a times b, and I can say print c. Of course, I need parentheses, and this will give me the result as 420. So here I've used a, b, and c as variable names. So the Python interpreter sees all three of these programs as exactly the same. So whether I use A, B, C as variable names, or I use hours, rate, pay as variable names, or I can use any other combination of text or numbers as variable names. But Python sees all of these as being the same. So as humans, we will most likely to understand the intent of the second program, for example, the hours, rate, and pay, as opposed to trying to figure out what A means, what B is, what C is. It's easier to see that hours equal 35. That means, okay, it's 35 hours. And then the rate is $12.5 per hour. And then I'm simply going to multiply or calculate my total pay, which is hours times the rate, and it will print the pay. Because, or you as a programmer can choose variable names that reflect the intent regarding what data will be stored in each variable. And we can always call these wisely chosen variable names as mnemonic variable names. So depending upon your own, again, requirements, it's easier to use the second type of naming conventions, in other words, which is easier to understand by humans. So as a programmer, you may want to create variable names like this, like the last option, the third option here, x1, q3, z9, and so on. But for another user who's looking at your code, would really not know or have no idea what you're essentially doing. So as a good programmer, you need to use something that makes sense. Okay, here are some reserved keywords in Python. When using variable names, you need to watch out for the reserved words. For instance, if I need to bring a list of all the reserved words in Python, I can simply type keywords. So here before the keywords, I need to call the help function. Once I call the help function, which is simply the Python help. So I can either bring up help on keywords, modules, symbols, topics, and so on. And notice within my shell, the help prompt is displayed. And here I can simply say keywords, and Python is going to give me a list of keywords such as false, none, true, and so on. Another way to bring keyword in Python is, for example, let me first quit out of this. It takes me to the shell prompt, and here I can say import keyword, and this is a module, and then I can simply choose keyword dot KW list, and this will list out the same keywords. So a couple of ways you can do it, but typically as a beginner you can always type help, set of parentheses, and this will give you the help menu. Now once you're in the help prompt, you can always type, for instance, modules. So if you need to take a look at all the modules in Python, and Python is going to give you all the modules, a whole list of modules. So just a word of caution that you need to be careful about using keywords as variable names. Okay, at this point, the syntax error that you're most commonly or likely to make is an illegal variable name, like class and yield, which are keywords, or $, which contains illegal characters, for instance. And if you put a space in the variable name, Python thinks it is two operands without an operator. For example, bad name equals 5, and it will give you an invalid syntax. Let's try it. Let me first quit out of this, and it takes us to the shell prompt. So I can say something like bad name. So if I say 5, and it will say syntax error, because Python again is looking for the connection between bad and name and cannot find it. But if I were to use bad name as one word equals 5, okay, Python now understands that you are creating an assignment statement, and bad name is a variable. So just keep this in mind when you're working with variables. And here's a simple example. The runtime error you're most likely to make is a use before the definition. that is trying to use a variable before you've assigned a value. And this can happen if you spell a variable name wrong. For instance, here the principal is spelled P-R-I-N-C-I-P-A-L, and then you're multiplying, of course, and spelling the variable name incorrectly with the PLE at the end, and obviously this will generate an error. Similarly, if you were to use the word latex as L capital and then some words in lowercase and some in uppercase, obviously this variable is not the same as all lowercase latex, even though the word is the same, but Python is going to treat them as two separate variables. Some of these rules in mind when you're talking about variable, and I demonstrated how to use the help function, how to bring up the keywords, how to bring up the module list, and of course working with variables and using comments within your code. So practice, and let's move to our next lesson. In this lesson, I'm going to talk about the concept of strings, how to manipulate strings, and everything that you need to know about string, just so that we get started. We did take a look at the basic string concept in earlier lessons, but here I'm going to add a couple of more concepts to it, so that when you're writing programs in Python, some of these concepts will be very helpful. First, the basic manipulation of strings. Strings are simply lines of text that are declared with a single or double quotes. And again, we've been doing this earlier as well. So for instance, let me quickly demonstrate this one more time. So if I say something like happy, and then I'm going to use the plus sign, and recall the plus is for concatenation, right? Joining two strings together. And then I'm going to use my double quotes, and then finally the other string. When I hit enter, notice it prints it. The reason why it doesn't have a space between happy and birthday is because I need to leave a space between my two quotations. So if I were to do this again, and this time add an empty space, hit enter key, and there'll be an empty space between the two words happy birthday. So basic strings, no big deal. Similarly, the other example, you can practice yourself. My name is John. You can join two strings together. Now, a couple of other things that I want to show you here regarding the basic manipulation of strings here. For example, if I were to say something like happy, and then place a comma and a space, and then use my other string. So I'm going to say happy holidays, hit the enter key, and notice in this instance it provides an empty space in between as well. So I don't have to use the two double quotes to create an empty character, right? I can simply use this within my strings as well. Same thing, let me copy this one more time. If I leave an empty space before holidays or the word H and remove my comma here, for instance, notice there'll be two spaces in between. So strings are very powerful. It just depends on how you wish to use them and the type of program or code that you're using. Obviously, the convention that I used earlier, such as the word happy in its own string, the word birthdays in its own string, is much easier to read, right? For another user or programmer who is reading your code, it'll be easier for that person to identify the two words as two separate strings, and then that empty space as its own set of strings. But just a quick word on manipulation of strings and the conventions that you wish to use. Next, we also talked briefly about triple-quoted string. It is sometimes convenient to have a multi-line string, for instance, which can be delimited with triple quotes. So for instance, if I need to write multiple lines of text in Python, I need to use my triple quotes. And these could be either single or double. Python treats them as the same thing, so there's no difference between whether you use double quotes, as long as there are 3 quotations. So let's demonstrate this. So for example, I'm going to quickly create an assignment statement here. So I'm going to say new text equals, I'm going to do my triple quotes, say, I'm going to use my next line here. I live in Chicago. Add another line. Say something like, I love Python. And end with my triple quotes. So if I hit enter, notice all I did was I used a variable called new text, and I assigned new text multiple lines of text as opposed to just one value or one string. So in this case, I don't have to join strings together. I can simply use the triple quotes and write the entire text, maybe a story or a paragraph. And this time, when I print, or tell Python to print new text, Python is going to print the entire text as it is, right? So powerful way of using triple quotes when you're working with strings as well. So whether you use different strings and join them together, or you use triple quotes as one paragraph. All right, next is object orientation. Python is an object-oriented language. Every piece of data and even functions and types are objects. So in the newer paradigm of object-oriented programming, all data are in objects, right? And a core group of operations that can be done on some particular type of object are tightly bound to the object. And these are called objects methods. Okay, so here's the beginning of the concept of methods, right? So everything is an object in Python, and when you attach methods to objects, we get certain outputs, right? We get certain things done quickly, and Python recognizes that, hey, I need to follow a particular method, and method is nothing but a command, for instance, right? So we use methods and attach methods to objects and tell Python to execute those. Let's take a look at a couple of examples next. So here, for instance, we have a variable called assignment statement simple called s equals hello, and then we're using the s dot upper with a set of parentheses. So here upper is simply a method that is associated with strings, which means that upper is a function that is bound to the string before the dot. Okay, so one way to think about this is that each type of data knows operations or methods that can be applied to it. As I mentioned earlier, that S is connecting or attaching to a method called upper. In other words, upper in itself is going to do something, and it's going to do something to this word called hello. Okay, so let me demonstrate. In fact, it'll make more sense. So here I have s equals hello, simple assignment statement, and next I'm going to use s upper, and notice what happens. Takes the word hello and converts it into an uppercase. Okay, so now the concept of method is clear, right? So once you attach a method or a function to a string, it's going to take the entire string and manipulate it, right? So powerful way in Python using methods. And of course, programming, as we move forward, we'll be talking a lot about methods and functions and calling those functions and so on. So make sure that you understand the concept of method, right? And these are, again, built-in words that Python has. So it's not something that I made up. These are reserved or built-in keywords that we took a look at in earlier lessons also, which allows Python to manipulate strings using these methods. Let's do another example. For instance, this time I'm going to say C equals hello world, and notice this is all in caps, right? Hit the enter key, and this time when I use a method, I'm going to use C, of course, is the name of my variable here, and I'm going to say lower. And notice Python is smart, so as soon as I put a dot, what Python does, it gives me a list of the reserved keywords. So here's a list of all those keywords that I see that Python says that, hey, we can choose one of these. So I'm going to say c.lower, and this time it's going to take the uppercase hello world and convert it into lowercase hello world. So a powerful way of manipulating string. And we can use multiple keywords. There are about 30, 31 keywords which are common that you can use, and as you program more and more, you will get to remember these built-in methods, right? So anytime you're writing a program, you can always use those within your Python code. All right, next is methods and strings. Strings support a variety of operations. You can obtain a list of these methods by using the directory or dir parentheses built-in function on any string. What this really does is simply give you a list of all those keywords, right, that I was just talking about. So for instance, if I go to my Python shell, dir, set of parentheses, enter. Now these are string formatting, but if I need to have a list of all the reserved words, then I need to do dir and my strings, and this time I'm going to get a whole list of reserved words as well. So for instance, in the previous example we used something called upper, right, and lower. So let's see if I can locate the reserved word upper here and lower. So here's lower. Okay, so that's a reserved word that we used. And notice there are several of them. So we can use split, strip, split. So they're swap case and so on. We can use decimals, is digits, and there are a whole bunch of them. You can capitalize text within your strings. You can count text. You can center the text, and so on. So depending upon your own requirements, you can use any one of these methods and strings. Let's do some example. So for instance, let's say I'm going to use the s.replace method, right? And what this does, it simply returns a new string with up to the first count occurrences of the string sub replaced by replacement value. The replacement can be the empty string to delete sub, or you can tell Python to specifically replace or add to it. So for instance, if I have something like s equals, just following the example here for now, -1, 2, 3, and then I'm going to have t equals, and here I'm going to use the string and then replace method. Replace my original value that I wish to replace, and Python sort of tells me, it says, okay, s.replace, the format that I'm going to use is old, comma, and then the new. Okay, and then a count value, if any. So my old value that I would like to replace is the minus sign, and that's all I want to replace. And then I'm going to use an empty space, for instance, comma, and then 1. And what this would do is it will make t equal 1, 2, 3. Hit enter key and use the print function to print t and see what it looks like. And notice it says 1, 2, 3. Okay. Similarly, I can do another one. Replace t this time as opposed to replace s. And once again, Python automatically gives me a list of all the built-in words because it knows that I've entered a dot, and next I want to use a method. Like, what do I want to do? Okay, So I'm going to use replace. So here's my replace. Click on it. Replace. And this time I'm going to replace the minus sign and then my quotations, comma, and then 1 again. And this time if I print T again, notice it's still going to say 1, 2, 3. So regardless of any variable name, since I'm using the same replace method, it's going to use and replace the same. Now what if I have another variable such as u equals 0.2, 0.3, 0.4, right? So I have this sample value in u, and v is going to replace, so v equals u dot replace, and this time I'm going to replace just the dot or the decimal, and I'm going to replace the decimal to the count of 2, right? So if I choose 2, and this time if I print v, for instance, I'm going to get 23.4. So all I did was I took this decimal right before 2 and it moved 2 spaces or 2 characters after the word 3. So now the final value is 23.4. So this way you can work with the replace methods, and any one of these in fact methods like join, partition, swap. And Python is very easy. It tells you as soon as you put a dot, it knows that you're going to use a method, right? So you can pick a method and then work with the syntax. Here's another example. For instance, the syntax for the method called count. So it's s.count and then my sub. So count and return the number of repetitions of a string sub that appears as substrings inside the string s. So for instance, following this example, I have a variable called tail, simple assignment statement equals, this is the best of times, and all I'm doing here is telling tail.count. In other words, count the word I within this sentence. How many times does the word I appears in this sentence? And of course, when I run this, it says it appears 3 times. Let's try it. So for instance, here I'm going to use a variable called new text equals, I'm going to create a string here, right? So I'm going to say, my name is John, I live in Chicago, the Windy City. The city of Chicago, I'm just making this up as I go along, is famous for its architecture. Okay, so here's my new text, right? So let's say if I need to find out the count or the number of characters within this new text variable or this assignment statement. So I can say something like new text dot count, and then what do I want to count? Let's see if I'm looking for the letter I within this entire paragraph. So I'm just going to use I, hit enter key, and notice at this point it gives me an error and it shows me that the next text is not defined. And yes, of course, because I misspelled my variable name. So here I said new text, and when I wrote I said next text, right? So be careful. This tells you that you need to be very careful with your spelling, right? Whatever the variable name is, you need to specify exactly that variable name. So let's try one more time. This time I'm going to say it's new text dot count and then the letter I, and this time it tells me that 12 is the answer or the output. In other words, I is being used 12 times within this paragraph. Okay. Similarly, I can also search for words, so I can say next text or new text rather, dot count. And this time, let's say I'd like to find how many times the word city appeared within this paragraph. And Python tells me that it appeared twice. So one more time, you can always go to your directory and bring up your string count by typing dir, parentheses and quotations, right? And then it tells you the built-in words that you can use in Python. So I've demonstrated a couple of examples, and you can take a look at the rest of them and practice with some of these. So in this lesson, I simply wanted to elaborate upon the concept of strings a little bit further, and also introduce methods that we can use with strings, right? So we can use methods. These are built-in words in Python, and once you get to practice with some of these methods, you can always use them with strings, and they're very, very powerful. So practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of functions in Python. In other words, what are functions? How do we use them in Python? And as we write code, what do they do for us? So basically, a function is a block of organized, reusable code that is used to perform a single related action. Functions provide better modularity for your application and a high degree of code reusing. And Python gives you several built-in functions, and we've been working with functions like print. You can use the function several times, telling Python to print the output. So in a nutshell, simply think of functions as blocks. So it's a block of code that you can use several times within your entire program that you're creating. Okay, and this block of code contains multiple lines of instructions telling Python to do something for us. The benefit of using function is that you don't have to repeat every single time the same code over and over again. Essentially, you're combining a set of code or multiple lines of code into one block, giving the block a name. And all you do is you call that name, and Python would execute the entire code within the block. Okay, so just the concept of functions. Here's an example. So let's say we have a simple print function, and within this example there are 4 lines of code using a single print function. So we have print happy birthday to you, and then it's basically a birthday song, right? Within this block, so think of the entire code as one block, and what we can do is we can name this block or define this block. And Python allows us to use the keyword called def, or definition, right? DEF, and I'll demonstrate that shortly. But for now, just the concept that multiple lines of code can be grouped together into a single block, and that block can be given a name. Okay, so let me bring up, for instance, the Python shell here, the editor, by clicking on File, New File, and let me resize so that you can see. Okay, great. So here, for instance, I'm going to start with a comment, a simple print function, and I'm going to say print happy birthday to you, and repeat the same thing. Of course, I can always copy and paste, do the same thing, copy my lines so I don't have to type all the time, right? So just making things go faster. So happy birthday, and I'm going to say dear Emily, and then my last line of code would also be happy birthday to you. And then I can use maybe a blank line. I'm going to say print hope you have a wonderful birthday. Okay, so just a simple block of code. Now think of this as if you were to use the same lines of code in later part of your program, right, that you're writing. You'd have to copy and paste again or type the entire code again. And we can group this code and give it a definition. In other words, create a definition for the entire block of code. But first, let me run this. So I'm going to go run module. Of course, Python always asks me to save. Click OK. And I'm going to go up to my documents here, bring up the data files and Python folder, and I'm going to call it block. Click save, and Python would execute the program for you. Okay, so move this away. There we go. Okay, so here's the output. And notice the \n within my code simply means it's a new line or an empty line. So just wanted to quickly demonstrate an example writing a block of code using the print function. Okay, we can also create functions. So functions are simply blocks begin with the keyword def or definition followed by the function name and parentheses. So for instance, we can say something like def happy birthday Emily and a set of parentheses, or def happy birthday Jack, set of parentheses, and so on. The code block within every function starts with a colon and is indented as well. For right now, just creating functions that we can either use the built-in functions like the print function, or we can create our own functions as well. But before we actually create our own functions, just understand the concept of definition here. In other words, if I were to use the def happy birthday Emily parentheses, I can take this entire code, for instance, or here's my code, right? Let me bring that up. Here it is. So I can take the entire code and I can define the code and call it happy birthday Emily. So for instance, if I were to define this block of code, I can say something like def happy birthday, I'm going to say Emily, okay, and of course my set of parentheses. So all I've done is simply created a definition and I called it happy birthday Emily with a set of parentheses. Of course I can use some parameters within the parentheses, but for right now I'm going to demonstrate that later. For right now, just the definition concept, right? You can define happy birthday Emily, and then this definition called, or which I named happy birthday Emily, you can name it anything else, would contain all of these print functions in between, right? So here, for example, right after the happy birthday song, I can say happy birthday Emily and a set of parentheses. We'll make some spaces so we can see. Of course, we need to make sure that our spellings are correct. So essentially what we're doing here is make some spaces so we can see. Perfect. So here's our definition. We defined happy birthday Emily, right? Now what does this happy birthday Emily contain, right? This block contains these 4 statements, so these 4 print strings. And at the end, I can say something like happy birthday Emily, I'm calling it, right? So let's run this by clicking on run module. And of course, we forgot our colon, right? So we need to place our colon after the definition. There we go. And wants me to indent also. And notice the reason why I'm showing you step by step so that we follow the rules, right, that I mentioned earlier that are displayed on the slide here. That the code block within every function starts with a colon and is indented. So if I did not indent, Python tells me that, hey, we need to indent our code block. Great. Let's run one more time. Click OK. And this time your code is executed. So here Python ran the 4 print statements for you. So it's a simple print function, and then of course we use the definition. Now what happens when I go to my shell directly and simply say happy birthday? Let's see what happens. So when I say happy birthday Emily, set of parentheses, and notice in this instance it will simply print all of the 4 statements once again. So now essentially happy birthday Emily and a set of parentheses is a function, just like we have our print function with a set of parentheses. So I don't have to within my code every time write print or recreate the happy birthday song every time. All I have to do is just call this function within my code. Okay, so I hope this concept is clear at this point. We need to first make sure that we create a definition, give it a name. In this instance we called it happy birthday Emily, set of parentheses, and of course the rule says that we need to have a colon, and right after the colon the code needs to be indented, just like right here, and then we call the function. Okay, so here's a simple concept. And within your shell you keep running the same, you call the same function, it will run the set of code that is within this block. So here's the example that I just demonstrated. Function blocks begin with the keyword def followed by the function name and parentheses, such as def happy birthday Emily and def happy birthday Jack, and so forth. So here once again, let me bring my code back up, expand this. What if I were to create another definition? Okay, so let's just copy it, so save some time. Copy this code, go right after the print, paste it. In this instance I'm going to say def happy birthday Jack, right? So all I did was create another definition, but this time is for Jack because both of their birthdays are today. So instead of Emily I'm going to say Jack, and the rest of the song stays the same. And here I'm going to use the rest of the code also. Okay, of course make sure our names change and they follow the same definition name, happy birthday Jack, and I'm going to call the function here, and of course I'm going to say have a wonderful birthday Jack, and here on top I'm going to say Emily. Perfect. So nice program that we're creating, right? So it's 2 definitions now, happy birthday Emily, and then I have happy birthday Jack, same birthday song. Of course within the strings you can have any text you want. And let's see what happens when I run this. So click run module, click OK, and notice within the Python shell it gives you both blocks of code. Of course right after Emily we can always create a new line here, and let's run again. So this way you can go back and forth within your code. So right after you create a new line, notice you have your birthday song and hope you have a wonderful birthday Emily, and then your birthday song and hope you have a wonderful birthday Jack. And all you did was created a definition or a block, and you called it happy birthday Jack, and you called it, you call your functions. So within my Python shell, for instance, if I were to say happy birthday Jack as an example, it's going to give me the birthday song for Jack. Now in this instance, since my birthday song is between the definition, it's not going to give me the hope you have a wonderful birthday Jack, because that's after you call the function. If this was part of the function, then I will get my output. So I hope the concepts of functions and creating functions is clear, or defining functions at this point. All right, now parameters in functions. So for example, happy birthday Jack, set of parentheses. Now within this parentheses I can also provide or give certain parameters. So the syntax is simply defining or giving a function name such as happy birthday Jack, and then within the set of parentheses you give your parameters. So essentially you define the function docstring, your function suite, and then eventually end your block by a return expression. In other words, you have to type return within your code if you're giving parameters within your functions. So the statement return or expression exits a function, optionally passing back an expression to the caller. So it's a good idea to use return. And calling a function, you simply define a function that only gives it a name, specifies the parameters that are to be included in the function, and structures the block of code. And once the basic structure of a function is finalized, you can then execute it by calling it from another function or directly from the Python prompt. So for instance, we have been calling functions directly from the Python prompt. You can also call a function within a function, right? So you can embed functions within other functions. But for right now, we're going to keep things simple so that we understand at this level the concept of function, creating a function, and then calling a function. So next, let me demonstrate the concept of providing parameters within a function. So for instance, Happy Birthday Jack has a set of parentheses. Obviously, we can provide a parameter within these parentheses. So we can define the print me string as in this example. This prints a passed string into this function, and we can call it later on and end it with return. And now you can call print me function, and it will print the desired text within the string. So let me in fact demonstrate. Let me bring up my code. Here's my code. So I'm going to click File. Let's click on New File because we are going to create a new one. And of course, let me close this previous one. Here's our blank editor. Great. So here, let's create a function definition, for instance, one more time and assign a parameter. Okay. So of course, I'm going to use a comment here. So I'm going to say function definition is here. And then let's define print me, for example. And I'm going to call it str. Okay, so here's the parameter, call str as string. And Python, notice, automatically indents it. So as soon as I place the colon within my line of code, it knows that here is a definition. So the next line, as I enter on my keyboard, the cursor automatically starts blinking at an indentation. So here I'm going to say this prints a pass string into this function. And then I'm going to provide the print function, call str, and then of course return to end. And I use a semicolon to return end. My next comment would be something like, now you can call the print me function, right? So now we can call the print me function. And here, of course, my standard print. I'm going to say like I am first call to user defined function. And the reason why I call it user defined because it's something that you're creating, right? You're creating your own functions. You're not using the built-in functions in Python. You're actually creating your own blocks of code or own functions. So I'm first called to define user function, and my next print would be again, and it'll be something like again my second call to the same function, right? Perfect. So here's our function definition print me. This prints a pass string into the function, and I call the string and return to end. So let's run this and see what happens. So click on run module. Of course, the source must be saved. Click OK. I'm going to give it a name, call function. Click save. And what Python does, it executes the code and simply says, I'm first called the user-defined function, again, call to the same function. So I hope this helps practice using functions. In this lesson, I demonstrated And we talked about the concept of functions, how to use the built-in functions, and how to create our own functions. And of course, the concept of calling a function. So functions are simply blocks of code that you write, you give it a name, and then you call the function by that name. So practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of print function and a couple of things that are important regarding this print function. We have been using this in previous lessons quite a bit, but it's a very important function and it comes to you in various forms. In other words, you can use the print function in multiple ways, and it's a very powerful function in Python. So within the interactive use of the Python interpreter, you can type an expression and immediately see the results of its evaluation. And this is fine to test out the basic syntax, but in a program that run from a file like the first sample program or multiple programs that we ran in earlier lessons, for instance, Python does not display expressions this way. If you want your program to display something, you can give explicit instructions within the print function. And we'll take a look at different ways you can manipulate the print function in Python. So here's a few examples that we'll take a look at. It's a very short lesson, but I wanted to demonstrate a couple of examples primarily using the print function. So here, for instance, I have x equals 3 and y equals 5, two variables. So let me go to my Python shell and simply follow this example, and then we'll take a look at what Python does. So x equals 3, y equals 5. And notice if I were to do the print, for instance, in a single line here, I'm going to say the sum of, I'm going to put a comma, or rather parentheses, because I'm going to make that a string, and then use my variable here, and then enter another string, comma y, and of course is another string, and then x plus y. I'm going to add the two variables together, close my parentheses, hit enter, and the output is the sum of 3 plus 5 is 8. So a simple print statement, but if you were to use this over and over again within your code, for instance, then it's always better to create a definition, right? Create a user-defined definition of this so you can later call the definition by its name. Another example using the print function is, let's say you have a variable called a equals 3.564, and this is again a float number, right? So anything that has a decimal is considered a float number in Python. So I'm going to print this variable. I'm going to say a equals, I'm going to enter a new line, comma, and the variable itself, and of course the results are a syntax error, and recall y because I did not close the parentheses. So let's try again. A equals, and of course my new line, close my parentheses, then place a comma and call the variable. See how Python is very logical, so if you make a mistake, it always tells you that this is not right. But this time when I hit enter, it prints the output called a equals 3.564, and the value 3.564 is on a new line. Let's do another example. What if I were to just say print, I'm going to say hi as my string, and I'm going to add or concatenate plus string 5. So notice at this point the output is high 5. However, if I were to say something like print and then use the same high 5, but this time what I'm going to do is I'm going to use the string for high and then simply add 5 to it, right? So I'm not going to use the string 5 within parentheses. I'm just going to say 5, and this time Python gives me an error, and the error is it cannot convert the integer object to string implicitly. So 5 in this instance, according to Python, is a number. So obviously you cannot take a number and you cannot add a number to a string. However, in the previous example where I used the str5 within the set of parentheses or string 5, Python would give me the correct output. So the print is pretty powerful, and of course whatever goes in the print function you can manipulate based on your own requirement. So practice. There are several examples that you can think of, and let's move to the next lesson. In this lesson, I'm going to demonstrate the escape codes in Python. What are escape codes? How do we use them? How do we avoid them when we do our coding? For example, if you're creating a string and there's a bunch of text within that string, there may be instances where the output is not displayed correctly. So we'll take a look at what those are in terms of how to fix and make sure that Python prints the output as desired. So what is an escape code? In Python, as in most languages that evolved in a Unix environment, encoded string literals, the backslash has the magical power of an escape character. This means that a backslash isn't interpreted as a backslash, but as a signal that the next character is to be given a special interpretation. So typically on your keyboard, when we use a backslash, it would just enter a backslash on your Word document, or when you're giving a path to a file name, and so on. But in Python, when you use a backslash, Python interprets that as something special. Okay, so whatever follows that backslash, Python is going to act on that. Here are a few code types. For instance, the 2 backslashes essentially implies that Python treats it as a single backslash. Okay, this may be confusing, but once you get used to it, it's really simple. If you were to enter a single backslash with a quotation, Python would interpret that as a single quote. If you were to use a backslash and double quote, Python treats it as a double quotation within your text string. Similarly, backslash A, backslash B, F, N, R, T are some of the common ones that you may come across when you're programming in Python. For example, if you need to enter a tabbed text, you would enter backslash T. So anytime Python reads your text and it comes across backslash T, it would tab the text. Okay, so here are some basic few code types, important ones that we use on a regular basis. There are others as well that we'll take a look at a little later. Let's do some examples. For example, here's the first line that says my file name equals, and then a string, C : backslash new project backslash type names.txt. Now in this instance, when Python interprets this, the backslash n, for instance, and recall backslash n is entering a new line. So Python gets confused and doesn't know what to do. So it thinks it's a new line, and therefore the backslash n that begins similarly with the new project was also interpreted as the new line character. And the backslash t in the type names.txt was interpreted as a tab character. So for instance, let's see what happens when I type this variable here, file name, simple assignment statement, and I'm going to use my string. So I'm going to say C : backslash n, just a file path on your computer, for instance. New project / type names.txt. Okay, let's see what happens. When I hit the enter key, it takes it as a variable name. Now if I were to say print my file name, Notice in this instance, right after C:, the \n was interpreted as a new line. So it's a new project. And similarly, notice there's a tab in between, right? This is a tab. So \t was interpreted as a tab. But what if you wanted to print the entire file path? And that's exactly what we mean by using escape codes in Python, where Python would make sure that it gives you the full path and not treat the \n or the \t as being a new line or a tabbed text. So to put a backslash into a string, we simply need to code 2 backslashes, that is escape character followed by a backslash. So here, for instance, if I were to use the same thing again, let me copy and paste it. Let me correct the n here. What if I were to use 2 backslashes before the word n? Okay, and hit enter, and let's see if I print my file name one more time. And at this time, what Python does, it treats the \n as not a new line, in fact, because we use 2 backslashes. Okay, so you need to understand that if you simply place a single backslash, Python is going to treat it as a new line. If you use 2 backslashes, Python is going to skip or escape the backslash. And we can do the same thing with the type or tab names .txt. So let's see what happens. Let me do this again. Use backslash here in my new project, and I'm going to enter backslash, a couple of backslashes right before the type names.txt. And now if I print my file name, and here the output is now the complete path. So there are no tabs anymore, and there are no new lines created by Python. And this is what we mean by using the escape codes. Let's do some more examples. Okay, these are pretty straightforward. Let's take a step forward in using escape codes. For instance, let's say I have a couple of variables, s equals, or let's say s6 equals, I'm just making this up, and I'm going to use the string called something like I contain \t, which means one tab after the word contain. And if I need multiple tabs, I can simply go /t again and /t again. So how about 3 tabs, right? So I'm going to say I contain 3, and then 3 tabs again, tabs. I close the parentheses here, and let's correct our text. So here I have S6. What happens when I say print S6? And notice it shows you that I contain, that's 1, 2, and 3 tabs, and then 1, 2, and then your third tab. So \t is tab. You can use it multiple times. Let's do another one. How about S7 equals, all right, I'm going to show you, let's say I contain a tab, something vertical, a vertical tab, right? So it's vertical tab. Correct my string here. Okay, great. Hit enter and simply do print S7, and Python creates an output and creates a vertical tab, right? And it shows you by this symbol. So I contain a vertical tab if you were to use the \v as an escape code. Similarly, you can use the \t, v, a, b, or any of these escape code characters that I've shown you earlier in the previous slide. Or a few more examples before I end this lesson. Quickly, let's say I have another variable called S8, equals, and this time I'm going to use some example of I contain a backspace, right? So how about a backspace? So it's \b and a space. So this time when I do print S8, it's going to give me a symbol that says that I contain a backspace. So this way we can work with various escape codes. There's a whole list of them that you can take a look at. I've provided some of the important ones, the common ones, like backspace, new line, a form feed. And let's see if I can get back to the slide so I can show you the types of codes. So here's the \A, \B, F, N, R, and T. So based on your own requirement, you can practice using the escape codes while working with strings. And these are important because if you forget to place a double backslash, for example, Python is going to treat this as a new line. Okay, so be careful when you're working or typing your code. These are important. So practice with using few codes, and let's move to our next lesson. In this lesson, I'm going to demonstrate how to use the input function in Python. By input function, we simply mean that the user will be prompted to enter some value or piece of information. So when we're writing code or creating a program, there may be instances where we would like user input, and that's exactly where the input function. So by simple definition, the input and output functions in Python exist so that programmers can speak to users through the code instead of having to manually enter in data by themselves. The real goal is to automate various processes by allowing maximizing user input. And this way, the programmer or the developer doesn't really have to enter a lot of extra code, because most times the user can be prompted to enter the information. And this is pretty common. For instance, you're browsing on the internet and you go to certain websites and you're prompted to enter your username, password, or if you enter an incorrect username, you are displayed with a message, and so on. So wherever the user input is required, the input function in Python is a very powerful function, and we'll take a look at what that does for us when we try to code. Why do we use input function? If we want to ask the user a simple question like, how old are you? Or what is your name? We're asking the user for some input. What is your age? What's your favorite color? And so on. We can pose a question, give a prompt, and wait for the user to enter in the answer. Python has a built-in function called input that does exactly this. Next, let's take a look at how the input function works. So in this particular example, using the shell prompt, you simply type input and then parentheses, quotations, enter your name. So the function is input, and you simply, within the parentheses, prompt the user to do something. So for example, let me demonstrate this. So if I were to say input, and I'm going to say how old are you, and then I'm going to put a question mark here and then close my parentheses. Okay, as soon as I hit enter, Python asks for input, how old are you? And I can enter the value 22, of course not my real age, and Python displays the output. Now so far the output is displayed as a string. Okay, and I'll get to that in a subsequent slide, how to convert from string to numbers and how to make sure that our lines of code is correct. But just a basic idea of the input syntax is the input function and then of course our parentheses, and you prompt the user. So by using the input statement along with a string containing the question you'd like to ask the user, you can get a response you're looking for. Since the input is string, in other words text, the output will also be string, even though you're asking a question that entails numbers or integers, and integers and strings do not match, or numbers and text do not match. You cannot really add text to a number. Since your input was string, the output will also be string. But if I were to say something like input and then enter your name, if I hit enter, it prompts me for enter my name, and I can say it's John. And this time it's printed as a text string, which is fine. And of course I need to spell correctly, like enter your name. Let's try again so we make sure we're on the right track. And I'm going to say enter your name, close my parentheses, and this time I have the correct output, which is John. So in this instance, the input was string and the output is also string or text. And we'll get back to the concept of converting numbers and how do we handle this issue in Python. Let's take a look at a couple of other examples, and let me in fact open up our Python editor here. So I'm going to click on File, New, and let's resize so you can see. So let's create a small program, all right, where we're asking user to enter some data. Let's say you're having an interview, right? So you're working for a company and you like to interview certain candidates, okay, or that scenario. So let's see if we can create a few lines of code that requires user input. So I'm going to start off with my comment here first. It's always a good idea. So enter first name of the applicant who's there to interview. Variable here, call applicant equals input. I'm going to prompt the applicant to enter the applicant's name. Enter the applicant's name. And the next variable is the interviewer, right? The person who's going to interview this guy. And I'm going to prompt one more time, give an input. And I'm going to say enter the interviewer's name. Okay, close my parentheses. So I have two variables here that I've specified. Next I'm going to say time, and I'm going to also use the input one more time for time, and then say enter the appointment time. Okay, great. So three inputs that Python is going to prompt for. First, enter the applicant's name. Second, enter the interviewer's name. And third, enter the appointment time. And finally, I'm going to say print all of these variables, right? Print interviewer, like who interviewed this guy. And of course, I need to make sure my spellings match or my variable names are correct. Interview. Okay. And then the applicant, of course, which is the variable again, applicant. And I'm going to say at, which is my string, and then my last variable at time. Great. And of course, I can always copy my comments and make sure my code follows a consistent convention. So enter interviewer name, or I can simply say who's interviewing. Okay. And of course, I can run the comment for time and then finally print. So let's say we have this small input program. I'm going to run it by clicking on the run option, click on run module. Of course, the source must be saved. Click OK. I'm going to go to my Python's folder, which is under data files, Python. I'm going to call it input 1. Click save. And when Python runs it, it asks me for the applicant's name. So I'm going to say it's John. Enter the interviewer's name. So I'm going to say Emily. And the appointment time. So I can say something like 10:30 a.m. And Emily will interview John at 10:30 a.m. Okay. Now, of course, Emily will, it's W-I-L-L, but I have a single L, and that's because within my string, I need to make sure my code is correct. and the spellings are correct also. So let's correct it, run one more time, and this time we're good to go. There's John, Emily, and then the time 10:30 a.m. There we go. So a good example of using the input command, and you can prompt every single time for user input. A very powerful way of creating code. Now before we actually convert text to number, I'm going to show you that, but I'm going to run through a couple more examples. For instance, let me do another example. So I'm going to open up my editor here one more time. And let's click on new file, close the previous file. Here we go. All right, great. So here I'm going to use another example, similar concept, but different. The more examples we work with, the easier it becomes. All right, great. So I'm going to use xstring, for example, as a variable name. And here I'm going to ask for input, and I'm going to ask the user enter a number. Okay, great. And of course, make sure I have the correct spaces. And next, I'm going to declare another variable here. I'm going to say x equals integer, and I'm going to say x string. Now, this is where I'm in fact telling Python that I'm interested in converting this x string, which in fact is a string. So enter a number is a string, but I need to convert it into an actual number format. So that's why we say, or we declare a variable called x, and the function is int, or integer, right? So integer x string, close my parentheses, and here are my two variables. Same thing, I'm going to go with y string equals input, and this time I'm going to say enter a second number. And finally our variable y equals, I'm going to convert integer y string as well. String, close my parentheses, and finally do a print function. And here I'm going to add both of these. So I'm going to say, for example, the sum of my variable x and y, and then I'm going to say is, and I'm going to add those two variables together, x plus y. And of course, I need my parentheses for my string values. So the sum of x and y. And Python again is nice about this, because if you don't have the syntax correct, it's not going to color code correctly. Okay, so you can take a look at before you even run the module, you can always make sure that your syntax is correct. And this looks correct. Why? Because we have the string in green color, we have our variables in black, and we're adding variables which is also in black, and our print function is in purple. So this now makes sense and looks consistent as well. So let's run this module. Click on run module, save it first, and I'm going to call it number. And the first instruction is enter a number. So I'm going to say it's 5, hit the enter key, enter a second number, and it's 8, hit the enter key. And Python displays the sum of 5 and 8 is 13. And that's exactly what I wanted Python to do. Okay, all right, great. Next, needing to convert string input to numbers is a common situation. So you'll come across this almost all the time when you're writing code in Python. You need to convert strings to text, numbers, and so on. So let's do another example here. So bring up the editor one more time, open up a new one, and let's close this. Okay, great. So here I have variables, simple variables like a equals 10 and b equals 99, and then I have my variable c, which is simply doing a simple addition of variables a and b. Okay, and I do print C. Simple, right? So let's see what happens. I want to show you something interesting here. So I'm going to click on run module, save it. I want to call it number 1 here. All right, great. So what Python does, it prints 1099, right? 1099. And I want to show you the code also. Here it is. So what I'm doing here is I'm declaring a variable a equals 10, which is string. So it's not a number. B is 99, which is also a string and is not a number. When I add both of these strings together and see the output is 1099, which is not a number. So in Python, you may see 1099 and intuitively you think of this as, well, this looks like 1099 or 1099, but in fact it's a string. Let me clarify. Let me demonstrate how do we find out what's going on here. Let's convert the value of C into an integer. So instead of 1099 as a string, I'm going to go ahead and make our C as an integer, or convert this variable C simply using the int for conversion, and I'm going to say C. Okay. This time when I rerun the module, source must be saved, click OK. My output is the same. It's still 1099. So there's no difference between the previous output and the current output. However, in this case, the 1099 is in fact a number. It's not text anymore. Well, how do I double check? How do I make sure that this is the number? And how do I know whether the previous 1099 was not a number? All right, well, let's double check. Let's run some few lines of code again, or add some new lines. So, or right after print. Okay, let's do another one. Let's do a D here, variable. So let's say the value of D is 7. So what happens when I add variable D, which has an integer value of 7, to my C? If C is an integer, then my value will be added, or it will be correct answer, because numbers add numbers. I'm not adding numbers in text anymore because C is now an integer, and I'm just double checking or confirming whether C is an integer or not. And if C is an integer, then my addition will be correct. So I'm going to say print D plus C. Perfect. Let's run it. Click on run module, click OK, and here we go. So it's 1106. In other words, Python correctly added 1099 plus 7, and the result is 1106. So this means that C is now a number. Okay, how do I know the previous 1099 was a string? And I can confirm that also by adding D to a string. So let me remove or delete the conversion where I'm converting string to a number. So I'm going to delete this line, for instance, the integer. So here now I have a variable called A, which is value of 10, which is a string, B 99 string, and I'm simply adding the two strings together. I'm printing the output. And now I have a new variable called D equals 7, which is a number. And I'm simply adding D plus C. Let's run this and see what happens. Click OK. And notice this time we get a type error, because Python is looking for the operand. So it says unsupported operand types for plus, integer, and string. In other words, integers and strings cannot be added. So therefore, wherever there's a string, it needs to be converted into an integer before you can do the addition, subtraction, multiplication, or any operator that you wish to use. So the input function is pretty powerful, and I demonstrated how to work with input function both in string format as well as in numbers, and also how to convert your string to numbers and also to make sure our code is correct and Python recognizes the input correctly. So I hope this helps practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate and talk about the concept of global variables in Python. So far, we've been declaring variables that are local. In other words, they're within a certain function or function definition. We declare local variables. So here, let's take a look at what global variables are. So what is a global variable? Typically in computer programming, a global variable is a variable with global scope, which means that it is only visible or accessible throughout the program, unless otherwise shadowed. So once you declare a global variable, you can call it from anywhere within your program. The set of all global variables is known as the global environment or global state. And global variables are typically not used in programming. In other words, the use of global variables is discouraged. On the other hand, a local variable is a variable which is either a variable declared within the function or is an argument passed to a function. As you may have encountered in your programming, if we declare variables in a function, then we can only use them within that function. And this is typically what we've been doing so far in previous lessons. How does Python treat variables? While in many or most of other programming languages, variables are treated as global if not otherwise declared. Python, on the other hand, deals with variables just the opposite way. In other words, in Python, variables are local unless you tell Python or declare a global variable. It is better to utilize a parameter for getting a value into a function or return value to get it out instead of using a global variable. And this is why, because Python imposes good programming habit by default or by its own design. Here's an example of a global variable. Simple function definition, a print statement, a string, and we call the function. Let me in fact demonstrate the differences between global variables and local variables and how do we use them. So I'm going to go to my Python shell, and in fact let me open up my editor by clicking on File, New. And let me resize so we can actually see. Okay, great. So here, let me quickly demonstrate the use of global variable. So here's our first line of code. I'm going to use a simple print and then use my string. And I love Paris in the summer. And then I'll call the variable here. Okay, great. Of course, we need to make sure that our indentation is correct. And let's run the module again. Click Save. And this time the output is displayed. Move this aside. Okay, great. So here's our simple definition of global variable and the output s and then calling the function. Now the variable is defined as the string I love Paris in summer before calling the function f. So here the s equals I love Paris in summer is defined before you in fact call the global variable. The body of the function f consists solely of the print s statement. There is no local variable, that is, no assignment to s. The value from the global variable s will be used, and that's exactly how we see the output I love Paris in summer. So the output will be the string that you see as an output. Now what happens when we in fact change the value of s inside the function of f? Will it affect the global variable as well? Let's test it out. So what we'll do is we will create, instead of a print statement, I'm going to declare a variable here, s equals I love Chicago, and then I'm going to leave it as print the variable s. And here I'm going to change this to say something like I love Paris. Okay. and then call our function. And after we call our function, we're going to tell Python to do a print s. Okay, so all we did here was change the value of s inside the function, right? So we changed the value of s within this particular function. Let's try to run this. Click on run module. And of course, the source must be saved. Click OK. And here's the output. So what Python does, it provides both of these output, even though, notice the assignment statement s I love Chicago and s I love Paris are the same. They're the same variable. But in Python, if you're declaring a global variable within the same names, it will treat them differently. What if we combine the first, let's say, example that we did with the second one? In other words, combine our previous example with this one. So let's see what happens here. So our previous example was print s, recall. So I'm going to say print s. And then we had s equals I love Chicago. Then we did the print. And then, of course, we're going to, since we're combining the previous example with this one, we're going to leave it as is. I love Paris, and then call the function. And of course, let's get rid of the print s. All right, great. So this is how we would, in fact, combine the two, which means that the first access with the s with the print s function, and we're hoping to get the global value and then assigning a new value to it. So assigning a value to it would mean creating a local variable s, which is I love Paris. Okay, so here we're trying to declare a global variable and then we try to assign a value. In other words, use a local variable as well. And this should typically throw an error because Python does not allow us to use variables that can be local and global inside the same function. Notice within the function, before you call the function, there are two variables, right? Since we combined them. Let's see what happens when we run this module. So click on run module, click OK to save, and notice here's the error. And Python says unbound local error, local variable s referenced before the assignment. So a variable can't be both local and global inside of a function. So that's important for you to understand. And at this point, the idea or the objective here is just to ensure and clarify so that you understand the concept of global variables and local variables and how to use them within your Python code. So importantly, a variable can't be both local and global inside of a function. So Python here decides what we want a local variable due to the assignment to the s, which is inside of the function f. So the first print statement essentially before the definition of s throws the error message above. So take a look at the concept of global variables and local variables. But typically in Python throughout our course and throughout the Python code, we'll be using local variables primarily. And if we need to somewhere use or declare global variables, what we'll do is we'll assign multiple parameters, right, within the function. But at this point, just understand the concept of global variables and that the use is typically discouraged, and Python doesn't allow use of both local and global variables inside of a function. So I hope this helps. Let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of dictionaries in Python and how do we use dictionaries, what they are, and the purpose of creating dictionaries within the Python language. So what is a dictionary? All of the compound data types that we've been working in our previous lessons, such as strings and lists, are essentially sequence types, which can use integers as indices to access the values they contain within them. Dictionaries are similar. They are yet another kind of compound type. They are Python's built-in mapping type. They map keys and values, in other words, which can be any immutable types to values, which can be, again, of any type, just like the elements of a list. So think of a dictionary as simply a mapping mechanism where it's mapping your keys to values. Let's take a look at how to create a dictionary. In common use, a dictionary is simply a collection of words that matched with the definitions. Given a word, for example, you can look up its definition. And Python has a built-in dictionary type with a set of parentheses, which you can use to create dictionaries with arbitrary definitions for character strings. Parentheses is essentially the syntax for creating a dictionary. Let's take a look at this simple example. In this example, we are creating a dictionary that's going to translate English words to Spanish words. So let me in fact demonstrate this quickly. Let's click on File within our Python shell. New File brings up the Python editor here. Okay, great. So let's go ahead and let's start our dictionary. In fact, let me move this here. So I'm going to start off with a comment. This is our first dictionary in Python. And then I'm going to begin our values and essentially use the dict instead of parentheses. So all I'm doing here so far is assigning, using a simple assignment statement, and I'm saying the Spanish variable is essentially dictionary, right? So the word Spanish is now the dictionary. Next, I'm going to in fact create or start my dictionary creation. Now, in order to create your dictionary, we can use something called brackets, right? Very similar to lists. So in lists, we use brackets. Dictionary, we can also use lists. And there are a couple of other ways that I'm going to demonstrate using the dictionary as well, such as using the braces, right? For instance, but for right now, I'm going to simply show you how to create a simple dictionary using and mapping keywords and values. Next is my Spanish. And I'm going to use my brackets, and I'm going to say the word hello, which equals or which translates to the Spanish word. Similarly, my next word would be something like yes in English, which translates to sí in Spanish, and then of course hello means hola. Okay. All right, great. So to save time, I'm going to copy and I'm going to recreate and simply change the values so I don't have to type over and over again, right? So this will be something like 1, and 1 in Spanish is uno, and the next word is 2, and the equivalent Spanish translation, and then my word 3. So essentially all we're doing is creating a list, right? So we're telling Python that here's the English words, and then I'm going to translate them to the Spanish words. So I'm going to say something like red, which is rojo. Okay, great. And you can keep building the list. So it depends on your own requirement how lengthy the dictionary would be. You can in fact take the entire Spanish language and create a dictionary in Python. So once you're done with your words, for instance, then we're going to tell Python to print some of these. So I'm going to print then the variable Spanish, and let's say I'm looking for the word yes, and then I'm going to print another one from my dictionary, and this time I'm going to use red. Okay, great. So this is a simple way of creating a dictionary in Python. Let's run this. Let's see what happens. Let's click on run module. Source must be saved. Click OK to save. Brings up my Windows Explorer. I'm going to navigate to my Python folder here and call it my dictionary. Save. And Python displays the output and prints out the 2 words that I asked Python to do so. So in this case, it's sí and rojo, which means yes and red. So again, a simple way of creating a dictionary using brackets, very similar to list, right? So all you're doing is mapping your keywords with your values. All right, let's move forward. Let me demonstrate next the concept of using definition within your dictionaries. So using a function, in other words, to encapsulate the task of creating the dictionary, is very helpful. And we can simply use the definition create dictionary set of parentheses and take the entire block of code and give it a name, and then eventually call the function within our code. So let me bring up the editor here, and let's click on the new file and close the previous one, make it so that it's visible. All right, perfect. So this time we're going to create a dictionary using the definition function. So essentially following the same steps, but since we are using a definition function, we're going to create the function first, then create our dictionary, and then eventually call it. So recall from previous lessons, in order to create a dictionary or a function, we first define def, I'm going to say create dictionary is the name, and then a set of parentheses, and of course the rule says that I need a colon. As soon as I use colon, Python automatically indents it. And I'm going to give it some text here as well, such as this will return a tiny Spanish dictionary, right? So notice the 3 quotes is multiple lines of text if I need to. All right, great. So here's my dictionary. So I'm going to start creating my dictionary once again, which is again the same concept, set of parentheses, and let's see if I have it saved. So I'm going to use some of these words. So essentially the same word, and I'm just pasting and repeating the same words to save time. So here I'm going to say hello, yes, and then this was 1, and the other word was 2, and a couple other words were 3 and red, right? That's what we used last time. So I'm going to be consistent here, and my last word was red. Okay, great. So our dictionary is complete so far. Next, recall the rule in the definition function. Whenever we create, we need to create a return function. So return Spanish, and then we create a def main so that we can call it later. And here I'm going to say dictionary equals create dictionary, which is the name, and then tell Python to print it. So print some values here, dictionary, and I'm going to say print 2, for instance, and then also print dictionary, and also print, let's say, 1, and then finish it off with the calling the main function. Okay, great. So in this example, we're taking a look at how to create the definition function and use this block of code and call it later on in our program if need be. So we're doing the same thing. We're essentially creating a dictionary. Okay, so let's run. Click on run module. Okay to save, and I'm going to call it my dic2 and click save. And notice Python displays the output as DOS and uno, which means we were looking for 2 and 1. And just to see whether we can call our main function, if we just say main, call our function, Python automatically knows the block of code, the output, and displays the output accordingly. So using the function or the definition, we can also create dictionaries or use them within our dictionaries. Now dictionaries can also be created by placing a comma separated list of key and value pairs within braces, for instance. Unlike our previous example where we use brackets similar to those of lists, we can also use braces to create dictionaries. So earlier we used the dict constructor, right? The dict and set of parentheses. This was one way to create a dictionary. Here we can in fact use braces and accomplish the same task using a set of braces and mapping those keys and values. So let me in fact demonstrate. Let me open up our editor here. So I'm going to click on File and New File here. Close this one. So here my first comment is going to be we can create dictionaries using braces. and these are those curly braces on your keyboard. And what I'm going to show you here is that there are multiple ways we can create a same dictionary. So we're not going to create the entire dictionary each separate time. I'm going to show you multiple ways of using the curly braces and a combination of curly braces and brackets, so that when you're creating dictionaries, you're able to create them any which way that you prefer. Okay. So here, let's start off with a simple variable called a equals, I'm going to say dict, and let's say it's 1 equals 1, and then comma 2 equals 2. And see what's happening here. Instead of going vertical, I'm doing horizontal, right? So I'm mapping these keys and values for the word 1 to 1, and then for the word 2 to 2. And same thing for the word 3 equals 3. And then close our parentheses. So that's one way. To accomplish the same task to create a dictionary, let's continue on. This time I'm going to use a variable called b. And now I'm going to start off with the curly braces. Okay, so I'm going to use them with curly braces, and I'm going to say it's 1, it's to 1, comma 2 is to 2, and then comma 3 is to 3, and close it with our curly braces one more time. So this is another way you can do it. Let me show you a couple other ways. So it's C, for instance, and this time I'm going to include, let's say, the zip code here, for instance, or nest my zip code. And here my dictionary begins, such as 1, comma 2, comma 3, and then close my brackets, and then map them, of course, with 1, 2, and 3. Close my brackets, close my first set of parentheses, and then of course my second set of parentheses, because one set of parentheses is for the dict function, the other one is for the zip here. Okay, a couple other ways. D, for instance, there's another way. We can do something like open the parentheses and then start mapping and creating a dictionary using the brackets, and then do something like 2, comma 2, and then do 1, comma 1, and then last one, do our 3, comma 3, and we close our parentheses, then we close our brackets, and then our last set of parentheses for the dict function. All right, let's do one last thing I want to show you. Let's do E here, and the last part, the way we can do it is, and this time I'm going to use the curly braces and use 3 is to 3, comma 1 is to 1, and our last one is 2 is to 2. Close our curly braces and of course our parentheses. All right, perfect. So you see what's going on here is all we're doing is mapping our keys to values, whether we use our dict function, whether we use our curly braces or the brackets. So essentially, when we run this module, we are going to get the same output no matter what. So here we're going to do some print function here, of course. We need to see the output also. So let's say if I do print A and run the module, see what happens. Click OK. And the output is 2, 3, and 1. And that's what A is, right? Similarly, if I do a print B, for instance, and run the module again, I'm going to get the same. I'm just going to say 2, 3, and 1. And the same is going to be true for C, D, and E variables here. And I can check using my Python shell here whether this holds true for all of my dictionaries. I can check by saying variable A equals B, and the double equal sign in Python means equal as in mathematics, right? So A equals B, and if this is all true, then I'm going to get a true value, right? So equals C, and my variable D, and finally it equals E. So hit enter on the keyboard, and Python says that this is true, right? So all of these essentially give you the same output. Even though we've used brackets, we've used curly braces, we've mapped values in any other ordered way. In other words, these are not ordered. Some are different, some are left to right. So when Python sees all of these, it says, well, the output is the same no matter which method you use. So a couple of ways we can create dictionaries. They're very powerful in Python and very helpful. So let's practice and let's move to our next slide. In this lesson, I'm going to demonstrate the concept of lists and also why they're used, what are lists, how do we use them in Python. So what is a list in Python? Python has a great built-in list type named list. List intervals are written with square brackets. So typically we've been using parentheses for our definition functions and so on. But for lists, we use square brackets. So this is an important difference. So anytime within your Python code you see a bracket, for instance, that means it'll be a list. And the concept of lists are related to arrays of programming languages like C, C++, or Java. But in Python, lists are by far more flexible and powerful than your classical set of arrays. Generally speaking, a list is a collection of objects. And to be more precise, a list within Python is an ordered group of items or elements. So it's like creating a list of grocery items, for instance, or a list of cities, a list of states, and so on. Lists can also be an arbitrary mixture of elements like numbers, strings, other lists, and so on. In other words, we can embed lists within other lists, and they can contain both numbers as well as text or strings. The list type is essential for Python scripts and programs. This means that you will hardly find any serious Python code without a list. So they're very important, very common, and a powerful element in Python. Here's some of the main properties of lists. So whenever we start working with lists in Python, we need to make sure that we understand certain properties. First, that they're ordered. In other words, they're one after the other, right? Separated by commas. Second, they contain arbitrary objects, numbers, strings. Elements of a list can be accessed by an index, so you can search your list, in other words. They are arbitrarily nestable, which means that they can contain other lists as sublists. So you can create a list, and then you can create a list within a list, and so on. And finally, they are mutable. In other words, the elements of a list can be changed. You can add items to a list, you can delete items from a list, you can append items to a list, and so forth. So here are some of the basic properties. Here's some of the list notations. For instance, a list always starts with brackets, right? So you start with the opening bracket, then you enter your items within the bracket, and then you close your brackets. If there's nothing in the list, then an empty list would simply signify a set of brackets. Then we can have integers, 1, 2, 3, 4, and so on. You can have strings, you can have floating numbers, you can have list of strings, you can have a nested list, and you can have multiple lists nested. Alright, so once we know the concept of lists, let's get into how do we assign list to a variable. Okay? Simple assignment statement that we can create using a list. For instance, here's an example like languages equals, and then you start with your bracket, and then you list out items basically. So it's Python and C, C++, Java, Perl. These are all strings. The second example is list 1, which contains physics, chemistry, both integers and strings. And list 2 is once again purely numbers, and list 3 is strings once again. So let me in fact demonstrate. Let's go ahead and create a list. So creating list is just like assigning a value to a variable, right? So you create a variable like list 5 equals, and then you start your brackets, and then you can type, of course, since it's a string, so you need your quotations, and we can say something like red, green, blue, orange, and so on. So you get the idea, right? So here's our basic list. You end your list with a set of brackets, and you've just created a list. So if I say something like print list 5, Python is going to print the output or the complete list. So just a basic idea, and we've been doing this before, assigning variables, right? Simple assignment statement. So here you can take the entire list and assign a variable to the list itself. So once you have the list created, how do we in fact access values in the list? Let's say you have a list of 100 items or 1,000 items. You're running an e-commerce website and you have thousands and thousands of products. In other words, your lists are huge. So how do we access values within the lists? Let me in fact demonstrate this. So I'm going to click on File, open up my shell editor here, and we are going to create a list and then try to access values within that particular list. Of course, I'm going to start with a comment. This is how you would create a list. Okay, you start off by assigning a variable, declaring a variable. Here's list 1, for instance, and the values within this list are, let's say, well, physics, list of courses, I guess, chemistry, biology, history, or let's add one more subject here, and we're going to say psychology. Okay, great. Let me expand that. So here's a list 1. Let's create another one. Here's list 2 equals, and here we're just going to say 1, 2. We're going to put integers within this list. So let's say, assume that these lists are huge, right? So we have a bunch of subjects and we have list 2, which contains several numbers. So here we can first simply print the entire list, which I demonstrated earlier. But what if you have to fish out certain information from the list? In other words, specify or display as a result or an output biology class, right? In other words, how does Python know? How would you tell Python to simply list out the bio class? Well, recall from one of our earlier lessons, the way Python works is it assigns values, arbitrary values to the list, right? Like, for example, physics would be a 0, chemistry would be a 1, bio would be a 2, history would be a 3, and psychology would be a 4, and so on. And the same is true for negative indices, right? So counting backwards, would be -5, -4, 3, 2, and -1. So that way you can tell Python to print a certain element out of the list. So for instance, if I say print, all right, let's say list 1, and I like to print the, let's say, the number 3. I want to know what's third on the list. And let's continue on. I want to search for another one within the same list. And within the same list, I'm going to say, give me the value of 4. Close my parentheses. All right, great. Let's see what happens when I run this. So click on run, run module. Of course, save the module first. And I'm going to go to my Pythons folder within the data files here. and I'm going to call it my list. And what Python does, it displays history and psychology. In other words, the list item number 3 within the list is history. So once again, it's 0 for physics, 1 for chemistry, 2 for biology, and 3 for history. That's why history was printed as number 3 on the list. And of course, 4 is psychology. So keep this in mind when you're creating lists once again. Similarly, I can do the same for, let's say, list 2. I can say list 2. I can also do an array, right? A range of values. For instance, let's say within list 2 here, I like to find out everything that's between 1 and 2 ranges. And also within the same list, I'm interested in looking at 1 to 5. Okay, just as an example. Let's run this again. Run module, of course, save, click OK. And here's the results. Of course, we get our history and psychology as our first print statement here. And then the second one, what Python does, it fishes out information from list 2, gives me the respective values within the range. So lists are a very powerful way of working, and when you're working with lists, the sky's the limit. So based on your own requirements, you can create multiple lists. Here are some of the basic list operations. So not only list provides us a valuable way of grouping items together and accessing information from the list, we can also run different operators within the list. In other words, we can add 2 lists together, we can add values together, we can multiply lists, concatenate, and so on. So let me in fact demonstrate this as well. Let me bring up my shell one more time. So here, let's say I'm going to click on File, a new file, close the previous one. Here we're going to create some code and then take a look at how Python allows us to manipulate lists. All right, great. So here's my comment here, using operators in lists. Great, so just quickly create some lists here. How about list 1 equals, and let's say I'm going to mix and match this time around. I'm going to say some numbers and some text or strings. Chicago, just listing out some cities here. Boston, and I'm going to say New Jersey, and one more. How about Austin? Okay, so here's our first list, and similarly, I'm going to quickly create a list 2 here, and this one also is going to have, let's say, some numbers, 4, 5, 6, and some text strings. I'm just going to make something up here. A, B, C, X, Y, Z, and let's say one more. EFG, or you get the idea, right? So we can mix and match strings and numbers as well. Okay, so I have 2 lists here, simple lists. If I were to say something like print, and what I'm going to do is show you how we can use, for instance, some of these operators, right? So let me show you these operators again. For example, one of the operators is the length, right? So if I need to know the length of my list or the items within my list, I can use the len function, right? So within my print, once I have my 2 lists created, I can tell Python to tell me the lengths, for example. So here I'm going to say first list length, and of course use a colon, and now I'm going to use my length function, right? So it's len and then simply my list 1. Okay, so I like to find out the length of list 1 and close the parentheses again because I used the first parentheses for the print. Okay, same thing. I'm going to do another one, and this is going to be the second list length, and use the same function, len list 2. Great. Let's see what happens when I run this module. So click on run module, Click OK to save. And I'm going to call it list length and click save. So Python automatically tells me that my first list length is 5. In other words, there are 5 values within this list. So we can use the len function and it will give us the length of the list. Of course, we can also add 2 lists together or concatenate. Remember the plus sign. So let's say I'm going to use the same code here instead of creating a new one. Just add the 2 lists together. So I'm going to say print, and this is pretty straightforward. I'm going to say list 1 and then plus list 2. Okay, let's run the module again. Click on run module, OK to save, and the output is displayed. So Python is going to add 2 lists and display it in a single output. So 1, 2, 3 Chicago, Boston, New Jersey, Austin, 4, 5, 6 ABC, and so on. So all I did here was use the plus operator, and Python combined the 2 lists together. And of course, as the last example here, we can always multiply or use any operands, right, as far as your lists are concerned. So I can say something like print list 1, and let's say if I like to repeat, so I can say multiply or the asterisk sign times 5. Okay, let's run the module again. See the output, run module, click OK to save, and notice this time Python repeats list 1 5 times. So list is a powerful way to be used in Python, and we will use this almost every single time when we're creating code. You need a list of items, and then you can manipulate that list based on your own requirements or the program that you're writing. So practice using lists, and let's move to our. In this lesson, I'm going to demonstrate the concept of tuples in Python. In other words, how do we use them? What are they? What do they do for us? So while coding in Python, we either tend to use lists that we took a look at in previous lessons, and we also talked about the concept of dictionaries. But here, I'm going to describe, explain, and then demonstrate the concept of tuples. So what is a tuple in Python? A tuple is simply a sequence of immutable Python objects. Tuples are sequences very similar to lists. In fact, they are exactly like lists. The only difference between tuples and lists are that tuples cannot be changed, unlike lists. And tuples use parentheses, whereas lists use square brackets. So just a minor difference between a list and a tuple. The function, however, is the same. Here's the tuple syntax. They may be constructed in a number of ways. For instance, we can use a pair of parentheses to denote an empty tuple. We can use a trailing comma for a singleton tuple, such as a comma or parentheses a comma. We can also separate items with commas. And it's important to note that it is actually the comma which makes a tuple, not the parentheses. Here's a small example of a tuple. So let me in fact demonstrate this. So I'm going to click on our Python shell here. I'm going to open up our editor by clicking on File, New File. And let me resize so we can in fact see. All right, great. So here's how we're going to create our first simple tuple. Again, recall it's just a list, right? The only difference is you can't change a tuple once you create it. So let me begin. Let's do a comment here. This is our first tuple. And all we do is we define a variable here, simple assignment statement. And we're going to use, let's say, some subjects here like physics. Just building a list here. Chemistry, biology, and we can combine some numbers as well. Let me create another one, which is tup2. and this equals just a set of numbers, 4, 5, and 7. Okay, great. And then I'm going to tell Python to print the output. And I'm going to say something like this prints tup 0. And then I'm going to put a comma and then actually do the tup 1. And then end this. Make sure our convention stays the same. All right, great. So here's our first print statement. Let me in fact create another one. So I'm going to say something like print, and this prints. I'm going to use my second tuple here, tup 2, and here I'm going to give it a range. You can always, and we've done this before. So in a previous lesson, we took a look at how to print very similar to lists. Okay, and of course our tup 2 here for the output. And the output is range 1 through 5. Close my brackets and close the parentheses. All right, great. So just a simple tuple. Let's see what happens when we run this tuple. So let's click on run module. Of course, Python always asks you to save the module before you run. So click OK. And this brings up my Windows Explorer. I'm going to navigate to my documents folder, my data files, and Python folder. This is where we've been saving all the modules. So we're going to call it tuple. Click save. And Python gives you the output. So this prints tup 0, which is physics. And the second tuple prints 2, 3, 4, 5. Okay, depending on your requirement or your specified as per your own code. So just a simple tuple that we created, right? And you can build upon this as per your own requirement. Now, what happens, for instance, if we need to update a tuple, right? Now recall, tuples are immutable, right? Which means you cannot update. But let's see what happens. So first, let me in fact write this so that you would know. So tuples are immutable, which means you cannot update or change the values of tuple elements. Okay. However, what we can do here is that you can change, let's see, the values within the tuple. So you can change the values here of tuple elements. Okay, so we can't update the tuple, but we can always change the values of the tuple elements to create a new tuple. Okay, so this is how you would essentially create. So let me in fact hit the enter key so we can see it on the same editor here. And recall we're using the 3 quotes, which means that we can always add multiple lines, and this is what that means. Okay, so I'm going to close this, and let me increase the size of our editor here. Great. Okay, so tuples are immutable, which means you cannot change or update the values, but what we can do is we can always create a new tuple. So let's say we created this first tuple up here, which has physics, chemistry, biology, a list of courses, and the second tuple had some integers or numbers. Let's see what happens when we create another tuple here. So let's say it's tup 1 equals, all right, let's just write some numbers here, say 12, I don't know, 34, or we can do a float number, 34.56. And then let's do another tuple, tup 2 equals, and here we can use some strings like ABC and XYZ. Close the parentheses. Okay, perfect. Now, the following action is not valid for tuples. For instance, if I were to do something like toop10 equals 100. Well, Python is not going to allow me to do so, right? So I need to make sure that I use the correct syntax. So let's see what happens when I run this. Click on run module, click OK to save, and Python executes and provides me the output. So here, for instance, notice at this point it's only printing the toop10 and toop2, which is similar to the first results. Nothing is happening or has happened to our toop1 here, right? Because we haven't specified the print statement for this particular addition in this instance. So let me in fact get rid of the first one. Okay, and just use our simple comment and our multiple line comments here. And here's an example of toop1 and toop2. Okay, so let's say, for example, if I need to say something like, I'm going to write this down so we know as a comment. So following action is not valid for tuples. And which action is this? So I'm going to write it down so we can see. For example, toop1, and then if I were to say 0 in brackets equals 100. Okay. And what we can do here, so I'm going to say, so let's create a new tuple as follows. So here, since toop10 equals 100 is not a valid action, to overcome this issue, we can create a new tuple. So how about say something like toop3, right? That'll be a new one. And simply do a toop1 and use a concatenation, add toop2. And of course, I need to give my print so that it prints the output. And I'm going to say print the toop3 variable. Great. Let's see. Run this. Click on run module. Click OK to save. And Python now provides me the output. So it says 12, 3.56, and then adds the other tuple to it, ABC, XYZ. So here, again, we cannot really change the tuple, but what we can do is we can add a new tuple to existing tuples. So this is how you would go about making additions to your tuple, which is, again, it's a list. Minimize this. Okay, so why do we use tuples? Tuples are faster than lists. So for instance, if you're defining a constant set of values and you're ever going to do this, it is iterate through it, for example, use a tuple instead of a list, right? So it makes your code safer if you write protect data. That does not need to be changed because tuples are immutable, and it also protects your code. Tuples can be used as keys in a dictionary, but lists cannot be used this way, since dictionary keys must be immutable. So, a few advantages of using tuples as opposed to using lists. And here are some basic tuple operations. I demonstrated the concatenation, for instance. We can add two tuples together and obtain the output. But what I want to show you here before I end this lesson is how do you delete a tuple, right? So if you have this tuple created, how we delete it. So let me bring our editor back up. So here's tuple 3, right? Toop3 that we created that added toop1 and toop2. So to delete a tuple, write a comment. This is how you would delete a tuple. In fact, it's pretty straightforward. So you would use del function for delete and simply say toop3. Okay, that's really that simple. And let's run the module. Click on run module, click OK to save. And now toop3 has been deleted. But how do we know? Well, going to my shell prompt here, if I say toop3 It's going to give me an error saying tube3 is not defined. Whereas if I did not have this delete code within my module, let me delete this, run the module again just so that you can see, click OK to save. So here's our results. Now if I were to type tube3, I'm going to get my output in Python. Okay, so deleting is fairly straightforward. The function is del and then your variable that you wish to delete. Okay, so practice using tuples. Remember the differences between list and tuple, and of course the advantages of tuples as they're a powerful element in Python. So practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of loops in Python. So what are loops, different kinds of loops, how to use them within our coding. So this is where you get a flavor of a very powerful concept, which is loops in Python. So essentially, what is a loop? Typically, when you write code, and we've been doing several examples in previous lessons, statements are executed sequentially. In other words, Python reads the first line of code and executes it, and then goes and reads the next line of code and executes it, and so on. So the first statement in a function is executed first, followed by the second, and so forth. There may be a situation where you need to execute a block of code several number of times. So for instance, let's say you are playing a number game or a number guess game, right? So the first line of code prompts you to enter a number, and then it keeps iterating, in other words, looping around several times until you're able to guess the correct number. So pretty straightforward example. Another situation where you may need to execute a block of code several times would be, for instance, if you're browsing the internet and you enter your username to register on a blog site or something like that. And once you register, you enter your username and password. And if your password is incorrect, what is happening here is it going to loop and continue to ask for the correct password. And until and unless you enter the correct password, you'll not be able to log in. So this is the concept behind a loop. Here's a small scenario of logic of loops. So a loop statement simply allows us to execute a statement or a group of statements multiple times. And you get to define how many times you wish the program to loop. So for instance, here is a simple logic where we have the diamond shape as the decision, which is specified by a condition. So if the condition, for instance, is true, then the conditional code is going to execute and loop around. If the condition is false, on the other hand, then it's going to break or continue to the next line of code. Here's our different types of loops. So for instance, within Python, we can have a while loop. And what that does is simply repeats a statement or a group of statements while a given condition is true. It tests the condition before executing the loop body. A for loop, on the other hand, simply executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. We can also have nested loops. In other words, you can have a loop within a loop. You can also use one or more loops inside any other while, for, or do while loop. So here, I'm going to demonstrate the while and for loops just so that our concepts are pinned down. Here's the difference between for and while loop before I in fact start demonstrating the concepts. Let's take a look at here the basic concept or the difference between the for and while loop. The for loop simply allows you to run through the loop when you know how many times you'd like to run through the problem, such as, for instance, if the variable I and I is less than 10, you need to specify how many times you want this variable to loop around. And this will continually increase I until the condition returns false. Any number can replace the 10, even a variable. So, in other words, the for loop is where it's a definitive number of times. You tell Python, that loop around 10 times, 20 times, 30 times, 500 times, and so on. And finally, it will quit once the condition is no longer being met. And this is best used again for loops that you know how, when they should stop. So again, just think of a for loop as a definitive number of times, the main gist of the for loop. The while loop, on the other hand, allows you greater flexibility in what you put in it and when it will stop, such as, for instance, if you were to do a while I is less than 10, you can also substitute in a Boolean parameter such as true or false for the value of 10, as well as many other types of variables. The main difference, or the key difference between the for and while loop, is the organization between them. So if you're going to increase to 10, it is a lot cleaner and neater and more readable to use a for statement, because you know that there's a definitive value of 10 and you want the program to loop around 10 times. But on the other hand, if you were to use an existing variable in your program in your loop parameters, it'd be nicer to write a while loop. So in a for loop, you must create a new variable, and that is not true for the while loop. Okay, so if you're using a for loop, then you need to create a new variable and then tell the variable to loop around. Whereas if you use a while loop, you do not need a variable. All right, great. Let's do some examples, right? Let me demonstrate the concept that we talked about of for and while loops. So I'm going to go ahead and click on File and open up our editor here. So click File, New. And this brings up our Python idle editor. I'm going to move this aside so we can see. So let's see if we can do a simple for loop. In order for us to do the for loop, I'm going to, let's say, create a list here, right? Remember, recall from previous lessons. I'm going to simply say something like words and just a bunch of words in a list. And recall list begins with a bracket, right? So I'm going to say something like cat, my dog, and let's see. Let's see, just making words up here. A window. And let's do one more. I'm going to say I love Python. Okay, so just a simple list that I've created. Next, I'm going to use my for loop. Okay, so I'm going to say the syntax is for, and notice how Python color codes it. It knows automatically as soon as you type for, it's going to say, it's going to turn the color. So I'm going to say for W in words, and my colon. Automatically Python indents it, and I'm simply going to say print W. Okay, so here we have a simple list, and we're going to run a for W in words and print W. So let's simply run this, see what happens. Click on run module, and the source must be saved. I'm going to click OK. It brings up my Windows Explorer. I'm going to navigate to my Python folder. Under data files, Python, and we're going to call it for loop. Click save, and Python is going to execute the code and display the output, which is once again just the cat, dog, window, and I love Python. And of course, since we only have 1, 2, 3, 4 words defined, Python stops after printing the last word, which is I love Python. Of course, I can also add more complexity to my code, or I can build on this existing code. So for instance, if I were to say something like, here's my print, and I want to find out the lengths of these characters within these words. So I can do something like print W and also print the length and then W. Okay. If I run this code again by clicking on run module, click OK to save. And notice this time I get the same output, except I also get the number of words in cat, which is 3, number of words in dog, which is 3, Number of words in Windows, 6, and I love Python has 13 words. Let's do another example. So I'm just going to write a comment. This is another example. All right, great. So next I'm going to say something like primes. Let's do some prime numbers here. Primes equals, one more time, a simple list. Let's say 2, 3, 4, 5, 7, and so on. So I'm just going to say 7. Once my list is defined, I'm going to say for prime. This is a new variable. Remember, when we do the for loop, we need to define a new variable, because first our variable was primes, and this time is prime. And in the previous example, it was words, and it was w as a new variable. So in this instance, for prime in primes, colon, and I'm simply going to say print prime. Okay, great. So again, once again, run it. Click run module, click OK, and Python prints the output. Perfect. Let's do a couple more quickly so we get our concepts pinned down. All right, this is yet another example. Okay, here we're going to do something different. I'm going to use the for count, for instance, as opposed to building a list. So I'm going to say something like for count in, and then I'm going to say 1, 2, 3, 4, and 5. Put a colon. Next, I'm going to say print. Okay, what do I want to print? Let's say I want to print down. Then I'm going to print up. Next, I'm going to say something like print count. I can also print a couple of the lines, or maybe something like print yes times the variable count. Okay, so you get the idea, right? As we're working with the for loop and for in loop. Again, these are definitive number of times I want Python to execute. So if I run this time, click on run module, click OK to save. Notice Python executes the code accordingly. So it prints down up 1, and then down up 2, and of course it multiplies yes times count as it moves along. So the first time it counts twice, and then thrice, 4 times, and then 5 times, because I have 5. So loop is a powerful way of coding in Python. Okay, I'm going to do one last example here for the for loop. This is the third example. Okay, great. So here I'm going to do for count in 1, 2, 3, 4, and 5. Oh, maybe another 6. Okay. Now the rest I can always copy, so I'm not going to type it. I can always go up to my existing code and make sure I have a colon here, and then print or paste the existing code. And once again, I can always change anything within the print commands, right? So I can say something like print done counting, and do another one for count in red, green, orange, and let's use a square bracket because it's a list. Okay, great. So here's our list here, and then I can simply say print color, and of course I need my variable here. So instead of saying for count, I'm going to say for color in red, green, and orange, and then print color. Okay, great. So let's execute this code. Run module, click OK, and here we go. Here's the results. Okay, so we practice using the for loop in Python, very powerful. And next, let's take a look at some of the while loops. Okay, so let me minimize this. Okay, while loops iterate over a given sequence. Okay, so for example, I have a couple of examples here, such as x equal 1, while x is plus 1. And this is just another way of writing x equals x plus 1, by the way. And of course, we need to make sure that we do specify x equal x plus 1, otherwise it's not going to work properly. So let's take a look. Let me demonstrate this. So let me bring up our editor here, click on File, New File, close the existing one. Okay, great. Perfect. So now we're going to do some examples of while loop. Okay, so let's start with a comment here so we know. So this prints out 0, just printing out some numbers here, 1, 2, 3, 4, and so on. In fact, there should be commas here, so it's easier. Perfect. So here's our comment. Next, I'm also going to put another comment here so we know the while loop simply repeats as long as a certain Boolean condition, which is true or false, right? Condition is met. Since I have multiple lines, I'm going to use my 3 quotations instead of a comment. Okay, and notice Python changes the color in green, so you know that the code is correct. All right, so we're going to do a while loop, and it's going to repeat as long as a certain condition is met. Perfect. Let's start. So I'm going to say something like count, this is the name of the variable here, equals 0. And then I'm going to say while count is, let's say, less than 5. Of course, I can use greater than 5, equal to, not equal to, and so on. Colon. Python automatically indents it. And I'm going to say print count. And then count plus equals 1, right? And again, if I put a comment here, I can simply say this is the same as count equals count plus 1, right? So instead of writing this count plus minus 1, I can always also write count equals count plus 1. But in Python, it's better to use plus equals 1. Let's see what happens when I run this code. So click on run module. Of course, the source must be saved. Click OK. And this time I'm going to call it while loop as the name of my Python module. Click save. And Python executes the while loop and it prints out 0, 1, 2, 3, and 4. Because this is exactly what I want Python to do. So it looped around until the condition was met. In other words, started from 0 and it looped until the condition, which was less than 5, was met, and at that point it printed the variable. And count plus equals 1 simply told Python to loop around until the condition is met. If I do not have this line, for example, let's see what happens. So I'm going to delete this just for demonstration purposes. Click run module, click OK, and notice Python is going to keep looping around and it's going to say 0, 0, 0, 0, 0, and it's not going to stop. It's a never-ending loop because all I'm saying is while less than 5, so 0 is always less than 5, and Python is just going to keep on printing 0, keep on printing 0 as long as you have your computer on. Okay, so let's undo here and run again so we get the same output. Run module, click OK, and this time Python executes the code. So now you know the importance of using the count plus equals 1. All right, great. Let's take a step further, for instance. So I'm going to write a comment here. This is how you would break a loop. Okay, so we use the break statement in Python to tell Python to stop or break the loop. And I'm going to write something here also so you know that something like break is used to exit for loop or a while loop. We can use the break in both instances. Great, so break is used to exit a loop, whether it's a for loop or a while loop. Perfect. So next, I'm going to say, use the same example. This time I'm going to use the break statement within the code, right? So here's my comment again. I'm simply going to use the same example so it's easier for you to see. Here's my comment. Go to my next line, and here again count equals 0, and I'm going to say while true, and then print count, and then do count plus equals 1. And here I'm going to say if, right? So I'm going to use a condition here in this instance. So I'm going to say a simple condition: if count is greater than or equal to 5, for instance, break, right? So this is where you would use the break, and I'm going to indent this also. Or equal to 5, colon, and then break. Let's try again. Click run module, click OK, and here we go. Okay. So this time it's not a never-ending loop. In fact, Python breaks it. So the break statement can also be used to exit a loop. And you can use the break statement in a for loop or a while loop. So in this lesson, we talked about the basic concept of loops, what they are, how they're used in Python, and then the types of loops. Primarily, we took a look at the two basic ones at this point, which is the for loop and the while loop. So practice using these loops, and let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of using graphics within your Python code. Now, what this means is that we can draw shapes and patterns in Python language. So here, let's take a look at what graphics are and how to use them within Python. Before I actually get into the code, let me just briefly clarify the Cartesian coordinate system. The way Python works, for instance, is that you have to specify points on a coordinate plane. In other words, tell Python, right? So remember that we need to provide instructions to Python what needs to be done. So a Cartesian coordinate system is a system that specifies each point uniquely in a plane by a pair of numerical coordinates, which are assigned distances to the point from two fixed perpendicular directed lines. So this is similar to your x-axis and y-axis, a simple concept in math, and that's measured in the same unit of length. Each reference line is called a coordinate axis or just axis of the system, and the point where they meet, in other words, where the two lines meet, is its origin. And usually an ordered pair, which is 0, 0. In other words, a point on x-axis will be at 0 and the point of y-axis will be at 0, which will form the point of origin. Here's what it looks like. So in this diagram, there are 4 points that are marked and labeled from their coordinates. For instance, the points 2 and 3. So 2 from the x-axis and up to 3 on the y-axis, where the two lines meet. This would be the coordinate called 2 and 3. Similarly, it can be -3 and 1, or -1.5, -2.5 in blue, and the original 0, 0 is in purple. So you get the idea. So the reason why I brought this Cartesian plane up is because when you draw things in Python, or when you draw patterns in Python, we have to specify coordinate points. The turtle graphics is a popular way for introducing programming. and is pretty common as well. There are many modules in Python that provide very powerful features that we can simply use in our own programs. We use the turtle module by importing it into Python, and then once the turtle module is imported, we can make use of different methods or provide different commands, and Python would execute those commands as per our requirements. So here are the different commands. For instance, once you import the turtle graphics by providing the import turtle command in Python, the most commonly used commands are degrees, clear, radian, reset, up, down, left, right. So in other words, you can tell Python what to do. If you need to draw a line or a circle, you can use any one of these commands. And these are again the common ones, and there's a comprehensive list available as well. So here's a simple example. Let me demonstrate how to draw patterns in Python, just so that you get the concept of how to do this within your Python code. So I'm going to go ahead and bring up my editor here by clicking on File, New File, and this brings up our blank editor shell. So I'm going to move this right here so we can see. So our first line of code will be, I'm going to start off with a comment. So I'm going to say something like, this is how you would import the turtle module. And the command is simply import turtle. Okay. So here I've simply typed import turtle, and notice how Python color codes it. So here, for instance, if I need to say something like, after of course I've imported the turtle module, I can say turtle dot forward. I can use a method here, and then I can say move 90 degrees, and of course I need to spell the word turtle correctly. And what this would do is simply move a point on the coordinate plane forward. So let me in fact run this and see what happens. So let's click on run module. Python wants me to save. Click OK to save, and this brings up my Explorer window where I'm going to navigate to my Python folder and simply provide a name of the file to be saved, or a name of the module to be saved here. So I'm going to call it graphics and click save. And what this does, it brings up the canvas area or the Python turtle graphics window, and it draws up a line forward to the right using an arrow. So let me move this aside so we can actually see, and also our code as well. There we go. Let me do something like turtle dot right, and I'm going to say 120 and see what happens. Let's run this again. Run module. OK to save. And at this point, notice as soon as I provide the 120, what Python does is simply changes the direction. And of course, if I say turtle dot forward one more time, say something like 90. Now if I run it again, click on run module, OK to save. And notice at this time, since the direction is changed at 120, and then I told Python move forward one more time, 90, it's going to move in that direction. So you get the idea. You can draw up shapes, you can draw up circles, you can draw rectangles, squares, and any other pattern. Sky's the limit depending upon your own requirement. Let me in fact create a new file here, close the existing one. Here's our code window. All right, great. I'm going to close the turtle graphics also. Perfect. So here I'm going to do another example, okay, just so that we understand graphics completely. In the previous example, we took a look at how to draw lines and how to tell Python to move forward, left, up, and down, but that could be lengthy. For example, if you need to draw 10 different rectangles or circles or triangles or whichever shape, you'd have to write quite a bit of code telling Python each time what needs to be done. And recall from our previous lessons, we took a look at the for statement or the loops, right? So we can tell Python to quickly do something for us. So here I'm going to demonstrate, for instance, let's say import turtle, and then I'm going to specify a variable. How about Alex here? It's just a name. Then I'm going to say turtle dot use the method here. And once I've defined a variable, then I can say for I, in other words, do the iteration, right? So for I and here's a list using a brackets. So I'm going to say 0, 1, 2, 3. Okay. And then complete our list. Use a colon, because every time you use a for statement, Python automatically indents it, and then specify what needs to be done. So now here I can say move Alex forward, okay, about 5, 0, and then Alex should also be moved to the left 90. Okay, so it's going to iterate 4 times, like 0, 1, 2, 3, right? For and I. Here's my list, and I'm telling Python to move the variable forward 50 and then left 90. And let's see what happens when I run this module. Let's click on run module. Of course, need to save the module first. Click OK. Brings up our Windows Explorer window. Let's navigate to our Python's folder under data files, Python. And let's just give it a name. Call it my graphics. Click save. And what Python does, it brings up the turtle graphics window and draws up, in fact, a square for you. Because essentially in our code, here we're telling Python, first we're defining a variable and then we're telling it move 4 times. In other words, iterate 4 times. And Python does exactly that. So this is another way you can draw up shapes quickly in Python using the loops and telling Python what needs to be done. So in this lesson, the concept of graphics was introduced and demonstrated by giving a few examples. Practice using other methods in graphics. It's a powerful way and a fun way to tell Python what needs to be done. And let's move to our. In this lesson, I'm going to talk about the conditional execution concept in Python. We have been working with several statements such as the if statements, which is a conditional statement, the else, and so on. Here, I'm going to clarify the concept further by diving into the conditional or the Boolean logic within Python language. So the conditional statements. In order to write useful programs, we almost always need the ability to check conditions and change the behavior of the program accordingly. So the conditional statements give us this ability. For instance, as I mentioned earlier, the if statement. So every single time, if it's raining outside, you would need to take an umbrella. If it's sunny outside, then you would not need an umbrella, and so on. So it'll be an if, then, and else. And that's simple logic. Even in plain English language, we use it all the time. The arithmetic expressions simply evaluate 2 numeric values, whereas a Boolean expression, sometimes also called a predicate, may also only have 1 or 2 possible values, such as false or true. So a Boolean expression is an expression that is either true or false. So for example, let me go to my shell here and demonstrate this. So if I say something like 5 equals 5, and notice the 2 equal sign in Python in essence means equals, which is not the same as a single equal sign in mathematics. So if I say 5 equals 5 in Python, okay, without giving a space, of course, so 5 equals 5, one more time, and Python is going to say true. If I say something like 5 equals 6, Python is going to say false. So this way Python knows that the values are either true or false using the Boolean expressions. Here are various comparison operators. Some of them we've been working with in previous lessons, but here's a list again. For example, x is not equal to y. Python would use x exclamation mark equals y, which implies that x is not equal to y. Similarly, x is greater than y, using the greater than sign, the less than sign, less than, greater to, and so on. We can also use and or between comparison operators in Python language. Okay, so a powerful way of using these comparison operators along with your Boolean logic to build your code. Here's another example. So let me in fact demonstrate this quickly. So let's say if x equals 6 and y equals 2, and if we need to evaluate whether x is greater than 2 and I can say something like x over y is greater than 2 or not. And Python says it's true, which means if x is 6, y is 2, of course my first expression here is x is greater than 2, which is true because 6 is greater than 2. And I'm also evaluating whether x divided by y is greater than 2 or not. So if I divide x by y, which means 6 divided by 2 is 3, which is also greater than 2. So this expression also evaluates to be true. So therefore, Python says, okay, the first expression and the second expression both are true. Let's do some other examples. So here we have, let's say x equals 8, for instance, and let's evaluate. Let's say something like 1 is less than x is less than 10. And I'm going to quickly write a comment so that you know. This is, by the way, the same as 1 less than x and x is less than 10. Okay, hit enter and Python says it's true. But if I say something like 10 is less than x is less than 20, Python is going to say it's false. I can also say something like not and then specify like 10 is less than x is less than 20. Python is going to say it's true. So again, you can use any of these comparison operators and evaluate expressions based upon your own requirement. I'm also going to show you a list of different expressions and the way you can use these comparison operators and Boolean logic. So let me go ahead and bring up our shell editor here. So click on File, File New, and this brings up our blank idle shell here. So here, for instance, I can say something like, I'm just going to demonstrate various possibilities of you can use these comparison operators and use Boolean logic. Or x is 10, y is 20 here, for instance. And I can say something like b is my variable. And if I say x equals 10, now what do you think this would do? This would simply assign a true value to b. Okay, so this would say simply like assigns true to b. Okay, similarly, if I were to say something like b equals x is exclamation mark and my equal sign equals 10, and what this would do is simply assigns a false to b. Okay, let's take a step further. What if I say b equals something like x equals 10 and y equals 20? This would assign true value to b. Okay, so this way you can build your own logic and take a look at. And once you have assigned these values, of course, you can evaluate, right? You can test and check and see whether these values are true or not. And the reason why I bring this up, the conditional execution, is because when you're working with your if statements or your logic or other logic statements and you're building your code, understanding the conditional execution is important, and especially knowing what's going on behind the scenes and what is Python doing here. What are you giving Python to evaluate? And remember our flowchart concept. When you're actually creating a flowchart for your entire program, you would then incorporate these conditional execution concepts within that program. Let me in fact demonstrate one last example, and I'm going to use quickly the shell here. Minimize this. Let's go to our shell, and I'm going to say something like a equals true, okay? And I'm going to say b equals false. Great, so two variables, a equals true and b equals false. Let's tell Python to print this. So what if I say something like print a equals, and then use my variable a, and then I'm going to say print b equals, and then my variable b as well. And Python is simply going to print the two values. Say a equals true and b equals false. What happens when I change the value of a? So now I'm going to say the variable a is false, and then use the same print statement and see our results. So here, of course, our a equals our variable a, and then our b equals our variable b. Okay, same print statement. All I did here was simply change the value of a to false. And this time, when I hit enter on the keyboard, notice Python says, wait a minute, a equals false and b also equals false. So this way, you can work with the Boolean logic. You can tell Python what needs to be done, what to specify by specifying the variables. So practice using these comparison operators over and over again. These are very important as we build more code. These are very helpful. And let's move to our next lesson. In this lesson, I'm going to demonstrate the concept of if statement in Python language. Now, we have been working with if statement off and on in various lessons in the past, but here I'm going to strictly focus on the if statement itself and different variations of the if statement as well. So in order to write useful programs, we almost always need the ability to check conditions and change the behavior of the program accordingly. These conditional statements give us the ability, and the simplest form of this conditional statement is the if statement. Think of this as a simple logic. If it's raining outside, I would need an umbrella. If I'm hungry, I would need some food, and so on. And of course, we can build upon the if statement as well, such as if I'm hungry, I need some food. Otherwise, else, I'll stay hungry, or something like that, right? So the concept of the logic is if, then, else. And that's the conditional statement that we are going to use. Here's a simple example. So for instance, the syntax of the if statement is of course if, and then you define a variable, simple assignment statement. If x equals 0, you also specify a colon. Just like other functions that we've been working with, for example, the definition function, we also specify a colon, or the for function, and so on. So we have to end the if statement with a colon character, just a colon, and the lines after the statement are indented automatically by Python. And if that's not happening, that means we're doing something that is incorrect. Let me in fact demonstrate. So let's click on File to open up our editor by clicking on New File. This brings up the editor window. Let me just resize it so we can see. There we go. So I'm going to start off with a comment. This is a simple if statement. And then define our variable, x equals 0. And then of course we begin to test this variable. So I'm going to say if x equals 0, and recall in Python equals is a double equal signs, right? Even though we say in plain language x equals 0, but when you're coding in Python the operator is double equal signs. So if x equals 0, and of course my colon, that's part of the syntax of the if statement. As soon as I hit enter on the keyboard, Python indents it, and now I can do my simple print, and I can say x is positive. And if I were to run this module, of course I can click on run module to test it. The source must be saved. I'm going to click OK. And I'm going to navigate to my Python's folder within my Windows Explorer. Here's my Python folder. And I'm going to say if statement and click save. And Python is going to execute the code and tell me that x is positive. So likewise, I can use any operators to test the simple if condition. And again, the point to be noted once again is the fact that if you were to use just the single equal sign within your if statement, such as here I just changed the double equal to single equal. If x equals 0, print x is positive. If I were to run this just to demonstrate, click on run module, click OK to save, and notice Python is going to give me the invalid syntax because Python does not recognize this single equal sign. So a pretty common mistake that we do when we're writing code in Python. So be careful when you're working with these operators. Okay, so click OK. As soon as I put the double equal sign, which means now I'm testing whether x equals 0 or not. And if it's 0, x is going to be positive and Python is going to print that. Let's do another example. Let's do something like if x equals 6. And I'm going to test if x remainder, and recall our operators. And that's the percent sign. 2, and then equals 0, print x is even. Next, I'm going to add something more to it, right? So I'm going to say else, right? So first is going to see if x remainder 2 equals 0, it's going to print even. Otherwise, in other words, else colon, it's the same format, same syntax, just like the if statement. I'm going to say print x is odd. Simple logic. Let's see if we run this. What does Python do for us? Let's click on run module, click OK to save, and notice Python prints that x is even. And the reason why, because x equals 6 and 6 is an even integer. What happens if I change the value? So if I change the value of x from 6 to 7 and then run the module, click on run module, OK to save, and then this time Python prints x is odd. So a very powerful way of testing your conditions by using the if statement. And then of course we added the else as well to complete our logic. So no matter which number you have up here that you specify for the variable x, whether it's 7, 8, 9, 10, as long as it's an even number, Python is going to say it's even. If it's odd, Python is going to say it's an odd number. Let's take a step ahead. Let me move forward. Let me introduce a couple of variables. Instead of just using x as one, I'm going to use two variables. So let's say I'm going to delete this for now. I'm going to say x equals, let's say 6, and then y equals 5. So this time I've defined two variables. And now I'm going to introduce my if statement. So I'm going to test something for these two variables, x and y. So I'm going to say if x equals y colon print x and y are equal. So it's going to say print x and y are equal. I'm going to close the parentheses. And then I can specify my else statement, else colon. Now here I'm going to do something different. Instead of just simply saying if x equals y, print x and y are equal, I'm going to tell Python to incorporate, or I'm going to add another if. In other words, I'm going to nest if within this. Okay, let's see what happens. So I'm going to say else if x is less than y, colon. Notice our syntax remains the same and Python keeps indenting it as we nest multiple ifs in our program. So here I'm saying if x is less than y, I'm going to tell Python to print x is less than y. And then I'm going to do else. And notice my indentation, right? It's important that you take a look at how Python is indenting its code. So each block moves in its own specified manner. So here I'm going to say else, and then I'm going to say print x is greater than y. Okay, perfect. So once again, our logic is simple. We introduced two variables, x and y, and we said if x equals y, print x and y are equal. Else, if x is less than y, print x is less than y. Else, print x is greater than y. Let's test it. So let's click on run. Run module. Click OK to save. And notice in this instance, Python displays the output that x is greater than y. And we can see it from our code here that x is 6 and y is 5. What happens if y is greater than 6? In other words, if I change the value of y to 7 and keep x at 6, let's run the module one more time, click OK, and this time Python says x is less than y. And of course, if they're both equal, for instance, x is 6 and y is also 6, and run this module one more time just to test, click OK, and now Python says x and y are equal. So powerful way of using the if statement. And you can of course not only use the if else, but you can use multiple if statements as well. Let me do one last example. This time I'm going to try to use a real world scenario using the if statement. Okay, now that we have the concept in our minds. So let's get rid of this. And this time I'm going to use a variable called wait. So in fact, I'm creating a program now, right? So the wait equals, instead of defining an integer, because your weight could be 70.5 pounds or 68.6 pounds. In other words, it could be a float number, right? So it doesn't have to be an integer. When you're standing on the wing or the scale, it displays in decimals as well. So which means in Python it's a float number. So I need to tell Python that the variable weight could be a float number as well. So I'm going to say it's float. And then I'm going to ask the user for an input. Let's say I'm going to say input. And then I'm going to say how many pounds does your suitcase weigh? Close my first parentheses and close my second parentheses. Let me in fact expand this so we can see the entire code. Perfect. So here I've defined a variable called weight equals, it's going to take a float number and I'm going to prompt the user. Remember the input function that we worked on earlier? So it's input, how many pounds does your suitcase weigh? And the reason why I closed with two parentheses is because I used two parentheses in the beginning. So once I have my input here, for instance, next I can say if weight is, let's say, greater than 50, colon, print, and here I'm going to say, how about there is a $25 charge for luggage that heavy. Of course, make sure our spellings are correct. So if the weight is above 50, greater than 50 pounds, print there is a $25 charge for luggage that heavy. And let's do another print. So I'm also going to tell the user that thank you for your business, because we want to be polite, right? So if they're going to pay extra $25 to us, we need to be polite. So thank you for your business. Next, I'm going to say else, right? So if, for instance, the weight is less than 50, right? So what needs to be done? So else, colon, simply do a print. So here, all I'm saying is, so far, if the weight is greater than 50 pounds, there's a $25 charge for the luggage that heavy, and thank you for your business. Else, in other words, if it's less than 50, then what should I tell the user? Then I'm going to say, have a safe journey. Perfect. So you get the idea, right? Using the if statement in a real world scenario. So if I run this, for instance, module, click on run module, click OK to save. And what Python does, it asks a question or prompts the user for input. How many pounds does your suitcase weigh? So here if I say it's, let's say, 70 pounds, hit the enter key, and Python says there is a $25 charge for luggage that heavy, and thank you for your business. If I run this module again, click OK to run it, and how many pounds does your suitcase weigh? If it's less than 50, for instance, it's 45, Python says have a safe journey. So a powerful way of using the if statement, the else statement, and of course, we can nest multiple if statements within our program. So I hope the concept is clear. Practice with the if statement. You can of course use the if statement in your definition functions, and depending upon your logic, it can extend to creating an extended code as well. But the syntax, the concept stays the same. You can use a simple if statement, or you can use multiple if statements. So practice, and let's move to our next lesson. In this lesson, I'm going to demonstrate some of the additional if statements. We did work with the standard if and else statement here. I'm going to add and incorporate some of the additional if statements, such as the elif. So typically, we've been working with the if-else statement in Python. This statement is an extension to the Python if statement. And we've already seen that the if statement will only execute the statements when the given condition is true, and if the condition is false, it will not execute the statements. In the real world, however, it would be nice to execute something when the condition fails. Here's once again the syntax for the if-else statement. So first, we specify a test condition, and if this condition is true, then the following statements will be executed. In other words, all the true statements. Else, if the condition is false, then these statements will be executed. That is the false statements. Here's an example, a simple example of the if-else statement. So here, in this example, the variable is marks, and we use the integer and input function to prompt the user to enter the subject marks. And if the marks are greater than or equal to 50, Python is going to give the output, congratulations, you cleared the subject. Else, Python is going to say, you failed, better luck next time. Let's quickly do this before I demonstrate the elif. So let's click on File, New File, and this brings up our editor. So here, I'm quickly going to say marks equals integer. Of course, you can use float. For example, the marks could be in decimals as opposed to just being integers. So in fact, let me use float. So it'll be float, input, and then a set of parentheses, and I'm going to prompt the user to say, please enter your marks. Keeping things simple here. A couple of parentheses. Let me increase the size of this window. Great. And next, I'm going to use my simple if statements. So if marks greater than or equal to 50 here, colon, that's the syntax. Python automatically indents it. And I'm simply going to give a couple of print statements here. So print congrats, and then another print statement. I'm going to say you passed. Great. Else, what Python should do is print. In other words, if the marks are not greater than or equal to 50, Python is going to say you failed, better luck next time. And a couple of statements simply, better luck next time. Great. And the S1, S2 here that you see are simply statement 1, statement 2. These are just comments, right? So you can also type your comments here as well if need be. But here's my simple if. Let's see what happens when I run this. So click on run module, click OK to save. And let's navigate to our documents folder within our Windows Explorer under data files and Python. I'm going to say my if statement. That's the name of the module. Click save. And Python prompts me for the marks. So if there are 77, enter, congrats, you passed. If I run again, the same module, please enter your marks. I'm going to say 45. You failed, better luck next time. So a simple if statement that Python executes that we just wrote quickly. Let me minimize this. Okay, great. So here's our editor. I'm going to minimize our editor. And again, we've done this before. We've used the if-else statement. And I'm sure you've practiced so that it's easier and easier as you move forward. Now here's something new, the elif statement. So this is another feature of the if command, is the elif statement. In other words, this statement stands for else if and implies that if the original if statement is false, but the elif part is true, then simply do the elif part. If neither the if or elif expressions are true, then do what is in the else block. Okay, so this adds to the if statement. Here's an example of the elif statement. So here we have our name, which is simply an input, your name. And then we use our if statement. If your name is Brian, it's going to print that is a nice name. Elif name equals John Hamilton, it's going to print John Hamilton. In fact, it's going to print some text in this particular example. Elif equals Michael Palin, then it's going to print some text. And then if neither of these conditions are true, it's going to print the else block, which says you have a nice name. Let me in fact demonstrate this. Let me bring up our editor here one more time. Move this here so we can see. Let's click on File, New File. I'm going to close the previous one. Let me resize so we can see. Great. There we go. So I'm going to write a small program. In fact, let me start off with a comment here. So enter your name. And then I'm going to define, of course, a variable first here. Name equals, I'm going to use input. And simply say your name. Next, I'm going to use the if statement, right? So if name equals, and recall, you have to use double equals, right? Because Python knows that now you would like to find out what this name equals to. So I'm going to say name equals, I'm going to say Brian. And since I'm using an if statement, I'm going to use a colon, enter. And then, of course, I'm going to do my print. And I'm going to say that is a nice name. Close my parentheses. Here I'm going to use elif, right? So instead of using else, I'm going to use elif because it's going to check to see whether any of these conditions are true before it executes the else block, which I'm going to do it later. So here I'm going to say elif. In other words, check another name equals, and let's say John Hamilton. That's the one we used earlier. And then of course a colon again. And this time I'm going to tell Python to print I am a soccer player. Close the parentheses. Next, I'm going to use elif one more time, or you can use it as many times as you like. And I'm going to say elif name equals Michael. Use my colon. See how Python automatically indents it as you're writing code? Let's say you're building a list of these names and you want to check every single time whether this name is entered correctly or not. And whenever the user enters the correct name, Python would give the output. So in this instance, I'm going to say I am a rugby player. And next, I can use the else statement. So if none of these conditions that I just coded are true, then Python is going to use the else. And what's it going to do is going to print, you have a nice name. Okay, so here's what's happening. First, you define a variable, ask for the input, your name. If you enter Brian, Python is going to say that's a nice name. If you enter John Hamilton, Python is going to say I'm a soccer player. If you enter Michael Palin, Python is going to say I'm a rugby player. If none of these conditions are true, Python is going to say you have a nice name. Let's try it out. Let's click on run. Run module. Click OK to save. And Python brings up the Windows Explorer. Within my Python folder, I'm going to give it a name. I'm going to call this module my if statement. Click save. And Python prompts for a input, your name. So let's say, for example, if I were to enter something like Brian, Python is going to say that's a nice name. If I run this again, and again, I can quickly run this. The shortcut is using your F5 key on your keyboard, right? So you don't have to click on run every single time and run the module. You can simply choose the F5 key. Okay, so that's a quicker way to keep testing your module. So here, once again, I'm going to say my name is, now what happens, let's see if I say Brian. Obviously, that is the name that I typed earlier. Nothing wrong with the spelling. The only difference is that instead of a capital B here, I'm using a lowercase b. And Python is not going to recognize this because you've specified in the code that Brian has to be with a capital letter B. So here, even if I enter the lowercase b, hit enter, Python is going to say you have a nice name. It's not going to say that is a nice name. Python is only going to say that is a nice name if you enter the correct word. Otherwise, it's going to say you have a nice name. And where is this coming from? This is coming from the else block right here. So if none of these statements are true, Python is going to say you have a nice name, and that's exactly what Python does here, because Brian, even though it's spelled correctly, you've started off with the lowercase b. So I wanted to point this out. You need to be careful. Okay. Similarly, if I run this again, your name, if I use Michael's name here, hit enter, it says I'm a rugby player, and that's exactly what it says here as an output. So this way you can use the elif statements within your code. So practice using the if, else, and the elif statements. Let's move to our next lesson. In this lesson, I'm going to demonstrate the while loop in Python. Now, we have been working with the if, then else statements, for instance. Here, I'm going to introduce the while statement, or the while loop. In other words, Python is going to reiterate until the condition becomes true. First, a word on compound statements. A compound statement, as we saw earlier, contains a group of other statements. In other words, it's a block of code and they affect or control the execution of those other statements in one way or the other. In general, compound statements can span multiple lines of code, although in simple incarnations, a whole compound statement may be contained in one line as well. So the while statement in Python is its most general iteration construct. What it does, it repeatedly executes a block of indented statements as long as a test at the top keeps evaluating to a true value. So in other words, you specify a condition, and as long as that condition is met, Python is going to keep executing and run a loop. When the test becomes false, in other words, when and only the test becomes false, the control continues after all the statements in the while loop are executed and the conditions are met, and the body never runs if the test is false to begin with. In other words, when we create a while statement, Python is going to look at the code, it's going to keep running the code as long as the values are true within your code, and only if the value becomes false, nothing's going to happen unless you specify otherwise. So here's an example. For instance, if I were to say something like while, this is the syntax, while 1 colon, Python would indent the code, print, type Control-C to stop me, something like that, or any text. Let's see what happens when we in fact type this. The first just prints a message forever by nesting a print statement in the while loop. Recall that an integer 1 means true. So 0 is false, 1 is true. Since the test is always true, in other words, it's just 1, Python is going to keep executing the body forever or until you stop its execution. And this is typically called the infinite loop. In other words, it's a never-ending loop. Python is going to keep printing type Control-C to stop me, and it's going to continue forever, ever, and ever, until of course you use a break statement, for instance, in your code, or you turn your computer off. But Python is not going to stop. Let me in fact demonstrate. So let's click on File, New File to bring up our editor. Let me move this aside. Perfect. So here I'm going to say a comment. This is how an infinite loop works. So I'm going to say something like, let's say while 1 colon, simply print something like you cannot stop this. Let's see what happens when I run this simple module. Click run, run module, click OK to save. And this brings up our Windows Explorer. I'm going to navigate to my Python folder here and give this module a name, something like while1, click save, and Python is going to execute this while loop and is going to continue to execute. Notice it's just printing new lines and lines and lines, because all you did was specify while1, which is true, print, you cannot stop this. So this is an infinite loop in Python. And of course I can use the break statement. So for instance, the next line I use my break statement. Python is going to break the statement right here if I run this again. So let's run module, click OK, and Python now simply says you cannot stop this once, because right after I print the output, I told Python to break the while loop. All right, great. Let me do another example here. So here, for instance, let's say I like to specify the number of times I like Python to loop around as long as the statement is true. So let me start over and delete this. I'm going to run another or create another code here, for instance, and I'm going to say something like, let's say count equals 0. Specify a variable here, and then use my while statements. So while count, let's say, is less than 10, and of course I'm going to use my colon, otherwise Python is not going to indent this. And then I'm going to tell Python to print, and I'm going to say something like, hello, I am a while, and count is the variable again, count, close the parentheses. And here I'm going to tell Python to count plus equals 1. We've used this before. Recall, it's just like saying n equal n plus 1, right? So iterate as long as it's less than 10. And if I run this module, click run module, click OK to save. And in this instance, Python prints the output 10 times, 0 through 9. Hello, I'm a while, and the count is 0, 1, 2, 3, all the way up to 9, because this is what I specified. So let me minimize this for now. So here, just a simple concept of while statement. As long as all the conditions are true, Python is going to keep looping around until you specify or you stop the execution. Here's more examples. So I demonstrated a couple of examples. For instance, count equals 0, while less than 10. We just took a look at this. In fact, it printed hello, I'm a while, and the count is count plus equals 1. Now when using the following code, we print the 9 sentences, and the less than is not the same as less than or equal to. And always remember to actualize the count. If not, you get an infinite loop. And creating a loop that prints out all the numbers from 1 to 10 squared, for instance, each on their own line. So we can also create a loop based on our own requirements. Let me do a couple of more examples. So let me bring up our editor here. Here we go. Let me get rid of this. Okay. Let's do something like, so I'm going to start off with a comment here, for instance. I'm going to say something like, the following script calculates the sum of the numbers from 1 to, let's say, 100. Okay, perfect. So just a standard comment. The reason why I broke this into 2 number sign comments, so it doesn't span the entire line, so it's easier for us to see. Okay, great. So now I need to define a couple of variables here. So I can say something like n, my first number is, well, all the way up to 100, because I like the 100 count. And then use the sum equals 0. Next, I'm going to specify a counter, because it's going to start calculating the sum, right? So I'm going to say something like counter equals 1. And then I'm going to use my while loop, because this is where you would, in essence, use a while loop, because it's going to loop around until all the calculations are made, and it calculates the sum of the numbers from 1 to 100. Otherwise, it's not possible with the if statement. It's going to take you a long time by writing each line and so forth. Okay. So while counter is, let's say, less than or equal to n, and n is my 100, right? That's the variable. Here's my colon. Python should add, right? So Python should do sum equals sum plus my counter, right? Okay, see how I'm using my variables and telling Python follow the logic here, right? In other words, keep looping around as long as the counter is less than or equal to 100. And counter in this instance is 1, right? So it's between 1 and 100. So from 1 to 100. And that's exactly what I created so far. So once it's done looping around, what's it going to do? It's going to do sum equals sum, which is 0 plus the counter plus 1. So it's going to do 0 plus 1, 0 plus 2, and so forth. It's going to keep doing this like 1 plus 1, 1 plus 2, all the way up to 100, and do all the combinations. So once I've specified the sum equals sum plus counter, next I'm going to say counter plus equals 1, which is again the same as x or n equals n plus 1 or x equals n plus 1, right? Add 1 to it. And once I'm done, I can say print the output, right? So I'm going to say print sum of 1 until, let's say percent d colon and percent d, and then use the percent one more time, and of course my variables, which is n and sum, and close my parentheses. Let's see what happens when I run this simple script that I created using the while statement. So click run module, click OK to save, and Python displays the output and gives me the sum of 1 until 100 is 5,050. So I hope you get the idea so far. Let me do one last example here just to reinforce some of the learning concept here. So I'm going to delete this for now, and I'm going to say create another script here. So let's say sum from 1 to the let's say given upper bound, right? So we understand further. Upper bound, and here I'm going to define my variable, which is like n, and this is going to be an integer, and I'm going to ask the user for input. So input, and I'm going to say enter the upper bound, close my couple of parentheses. Next, I'm going to say I equals 1, just another variable here, and then sum equals 0. Then I'm going to use my while loop. I'm going to tell Python to start the iteration. So while, I'm going to say I is less than or equal to n. Okay, put my colon. What should Python do? It should sum plus equals I, and of course I plus equals 1. Print the output. Simply in this instance, I'm going to say print sum. And of course the p is lowercase, print sum. Perfect. So here, just another simple example of using the while loop. Let's click on run module, click OK. In this instance, Python first asks me enter the upper bound. So if I enter something like 5, Python says it's 15. Okay, so this way you can work with the while statement. It's a very powerful statement in Python, especially if you're using with other conditional statements like if, else, elif, and then of course our while loop. So I hope this helps. Practice, and let's move to our next lesson. In this lesson, we're going to work with a couple of projects. In other words, we will simply create Python programs just to recap whatever we have learned in previous lessons. And more importantly, these will be programmed from start to finish, and essentially we'll develop a few games. How about that? So in this project, we're going to create 2 programs. First, a number guessing game, and second, a rolling the dice game. So 2 games, 2 different programs, and each program would obviously have a different output depending upon the game. So we're going to start from scratch and develop these games. First, we're going to create a guessing the number game, or guess the number game, for instance. In this project, we're going to tell Python to create a program where users will guess numbers. And if they guess the correct number, fine. If they do not, then they will be given some chances. We will use the random module. It's a built-in module in Python that we can use. We can import the random module, and the standard random module simply implements a random number generator. The syntax is pretty straightforward. You simply type a line of code that says import random, and then use random.randint, and then specify the parameters. So let me in fact begin. Let's click on File, new file to bring up the Python shell. Let me make this fit this window. Perfect. So first is our guessing game. So I'm going to start off with a comment. This is our first number guessing game. Now obviously if you were to start off with this, you would think about this game first. In other words, we have logic in our minds, a simple logic that we like to first obviously define a variable, specify certain parameters, tell Python the range of numbers, for instance, and then maybe do an input for the user, right, to enter the first number or guess a number, and then subsequently keep guessing, which means there is some kind of iteration within this logic, right? So maybe we'll use the if, else, while, or loop, in other words, so that until and unless the user guesses the right number, Python is going to keep asking for a number, right? So there's definitely a loop involved in this logic as well. So the first line of code is importing a random. So it's simply import random. And then I'm going to put another comment here. Once again, you can use comments to identify or explain each line of code or blocks of code. It depends upon your own requirement. I'm just going to say defining variables. And here's our first variable, for example, n equals random dot rand int, and then of course the range that I like to specify, for instance, from 1 to, let's say I want the user to guess from 1 to 99. Okay, so this is my variable, and then I want another variable. I'm going to call it guess, and this is going to be an integer, and here I'm going to ask the user for input. So input, and I'm going to say enter an integer from 1 to 99 and close my parentheses. So here's simply a couple of variables. First variable is random.randint. In other words, we imported the random module, and next we're telling Python to ask or prompt the user to enter an integer from 1 to 99, or in other words, guess an integer. And notice I use a variable called guess because it's easier when I reuse it subsequently within the code. I can easily reference or call this variable and use this variable. Okay, my next comment is do a loop, right? So this will be a while loop because we're going to keep guessing. So I'm going to say while n, which is our range here, random.randint, n, well, I'm not going to say equal, I'm going to say not equal to, where n is not equal to guess, colon, and then of course Python automatically indents it. I'm going to tell Python to print, but not yet. I'm going to use the if statement now, and if the guess is less than n, then print guess is low, right? Because if it's less than the number that Python generates as a random number, I'm going to tell here that print your guess is low. Or I'm just going to say, of course, if I use a print, make things simple here, guess is low. And if the guess is low, then of course I need to also mention that guess integer, and then use another input because I want the user to use another input at this point, and say the same thing. Enter an integer from 1 to 99. Okay, so see what's going on so far? All we're doing is we're importing the random, we're defining some variables, we're doing the while loop here, and within the while loop we're also specifying the if conditions, right? So the first if simply says if the guess number is less than n, print guess is low. In other words, guess again. And here I can say elif, recall the elif, right? So if all the statements are true, it's going to keep asking until it becomes false. So I'm going to say elif guess is greater than n. So in this instance, do what? Do print guess is high. It's just the opposite. Guess is high. Next, of course, I need to define guess again, because if the guess is too high, then I want to prompt the user again to guess lower, right? So I'm going to say integer one more time, input, and then prompt the user. Of course, I can simply go up here and copy this and paste, so I don't have to type the entire text again, and simply close my parentheses. So at this point, I'm doing a while loop, and within my while loop, I'm saying if the number is low, guess again. If the number is high, of course, guess again. And in both instances, Python is going to print. If the guess is low, that means the user is going to guess a higher number. And on the other hand, if the guess is high, then the user is going to guess a lower number. And next, of course, I'm going to say else and print here, you guessed it, right? And here I'm going to break the loop. And recall, if I do not use the break, the while loop is going to become an infinite one, right? So I need to make sure I break. And then, of course, finally, the print. Perfect. So here's a simple guessing game that we created. We use the import random. We specify the range 1 to 99, and you could do so 1 to 250 depending upon your own criteria. And then we said guess, prompt the user for an input. Next, we simply did a while loop, and then we nested the while loop with the if, elif, and else statements. Let's see what happens when we run the module and see whether our number guessing game is correct or not. So let's click run module. Of course, the source must be saved. Click OK. Brings up our Windows Explorer. Let me navigate to my Python's folder here. Under Documents, Data Files, Python. And I'm going to say My Game as the name of the module. Click Save. And Python prompts me to enter an integer from 1 to 99. And again, this is coming from this line right here. So let's say I'm going to go ahead and guess a number between 1 to 99. I'm going to say it's 50. Hit the enter key. Python says guess is high. Enter the integer from 1 to 99 one more time. So again, now I'm in the loop area, right? So here, since I've already guessed 50 and Python said it's high, that means the number is obviously lower than 50, right? So what if I say 40? Python says guess is still high. What if I say 30? Now Python says the guess is low. So I know that the number is between 30 and 40. So if I guess 35, Python says guess is low, which means the number is higher than 35 and lower than 40. So here, how about 37? Perfect. So Python says you guessed it. So the correct number is 37. So a very simple yet powerful guessing game that you created in Python. So practice, work with it. And of course, you can build upon this. You can add more criteria to it. You can enter more input statements, for instance. You can do additional loops. You can expand this game to make it a little bit more interesting. Maybe do more print statements so that the users are engaged within this game. But I just wanted to demonstrate quickly how to create your own games in Python. Let's do another one. Let's do another game. So let me close this. So once again, the guessing number game, pretty straightforward. Next, let me do the rolling dice game. We're going to create another game. Of course, use the same random module. It'll be good practice. So in this game, we will create a game to generate random numbers when the dice is rolled. So whenever you use dice and you roll the dice, you get some numbers, right? And you really don't know what numbers you're going to get. Maybe you get 2, maybe you get 6, maybe you get 4, maybe you get 5, and so on. And once again, we'll use the same random module. So I'm going to click on File, New. And this brings up our Python editor here. So let me just expand this so we can see. So here my first comment is, this is a rolling dice game. And in this instance, I'm going to use the same module, import random, to generate some random numbers, right? And of course, our next step is defining our variables. So let's say I'm going to define a min variable here, and that's 1. And of course, within our dice, the maximum value or the number or the integer in a dice is 6, right? Great. So I've defined two variables after I imported the random module. So here I'm telling Python the minimum value is 1 and the maximum value is 6. And I'm going to specify roll again because I'm going to keep guessing, right? So I'm going to say roll again equals yes. And the reason why I use the underscore after the word roll is just to specify or connect the two words together in English. Roll again. I don't have to use the underscore. I can simply say it as one word, which is fine. Okay. But just to keep the distances so it's easier to read, I use the underscore as a variable name. Next, I'm going to do my while statement. So while roll again equals, and of course in Python equal means double equal sign, equals yes, or roll again equals y. And the reason why I wrote this, because when Python says, do you want to roll again? And you simply say yes, yes, which is fine. But what if you were to just say y and hit the enter key? Python would not do anything unless you specify here. So either you can say yes, or you can simply type y and hit the enter key to roll again. And here's my colon because I use the while statement. Next, I'm simply going to print, and I'm going to say rolling the dices, ... Next, I'm going to print the values are, for instance, the values are ... Alright, so I'm doing the while, yes, roll the dices, the values are, and then of course I need to print the values, right? So I need to do print random dot rand int and then the values, right? So I'm going to say min comma max. And again, these will be randomly generated. Close my parentheses. But for right now, all we did was do a while statement. It's going to print, roll the dices, print the values are, and then print the output as the numbers. Okay. So next, I'm going to say roll again. And here I'm going to ask the user for the input. Roll the dices again. Ask a question, close the parentheses, and of course my else, finally print for playing this wonderful game. Let's see what happens when we run this game. So let's click on run module, click OK to save. And here's my Windows Explorer. I'm going to navigate to my Documents folder, Data Files, and Python folder. And I'm going to say Dice Game. Click Save. And Python simply displays the output and says rolling the dices, the values are ... 3. Roll the dices again. If I say yes, Python is going to roll the dice again. But notice at this point the values are 3 at this point. Only, in other words, 1 dice is being rolled. And here's why when I use this line of code where it says print random, rand int, min max, it only uses 1 set of dice. So I simply would copy this and paste it again. Of course, do my indentation, make some space here. So I'm going to repeat because there are 2 dices. So Python is going to generate a number here and a number here. Let's run this again. Run module. Click OK. And this time Python says rolling the dices, the values are 4 and 5. Roll the dices again. If I say yes, Python gives me a couple of more values, 1 and 5. Roll the dices again. Even if I say yes or just the letter Y, and the reason why, because I've told Python that either I can use yes or I can say Y. So roll the dices again, letter Y. Python is going to roll the dice again, and I'm going to get a new set of numbers and prompts me input. Roll the dices again, and since at the end of my code I simply said else print thank you for playing this wonderful game. So in this instance, even if I write anything or any number, letter, text, Python is going to print thank you for playing this wonderful game. So roll the dices again. I'm going to say no. Thank you for playing this wonderful game, and the program ends. So you've seen Python, very easy to use language, logical language. All you need to do is just understand your logic first, define your steps, create a flowchart first, and then start creating your code. And the more you practice, the easier it'll become for you, and you'll start remembering the syntax, you'll start remembering the methods, the modules, and the way Python works. So I hope this helps practice, and let's move to our next lesson. In this lesson, we're again going to do a couple of projects. In other words, we'll create additional Python programs to reinforce some of the learning concepts that we've been covering so far. So in project B, for instance, we will create 2 different Python programs, and both relate to either creating averages or working with some sort of mathematics. Okay, don't worry, I'll keep things simple so that it's easier for you to follow. The important aspect here is to understand how to write programs. So in this first program, we will calculate miles per gallon. So let's say you drive your car every day and you like to figure out and calculate how many miles per gallon does your car run, and we will prompt the user for input for both enter the miles and gallon, and then have Python calculate or do the calculation for us. So let me jump right in. Let's click on File. Let me open up our Python editor. Click on New File. Let me resize. Perfect. So start off with a comment. So I'm going to say calculating miles per gallon. Now, before I even start creating the program, keep this in mind that every programmer or developer or coder, whether you're using Python or any other language, you'd have your own way of doing things, right? Maybe your own logic, maybe you'll have a couple of additional steps that you like to incorporate, and so on. The idea here is to make sure or keep this in mind that whenever you're working with any programming language, draw up something, right? So think about the code in a logical manner. So here, for instance, I'm going to keep things simple. I'm in fact going to start off with a print statement, and I'm going to say print this program calculates miles per gallon, and of course close my parentheses and give it a space here. So next, let me write another comment here. Get miles driven from the user. So I'm going to ask input from the user. So here I'm going to ask input from the user. And what is that input? I'm going to say something like miles driven, or define a variable here, equals input. I'm going to say enter miles driven, right? Just asking the user a simple question. Once I've defined the variable, a simple assignment statement. Next, the miles driven could be a float number, right? It doesn't have to be an integer. So either I could say float input, or I can say convert the integer into a float. So both ways are correct. In other words, I can use the same statement and type float to a parentheses input, or I can always use something like convert text entered to a float point number, right? And to do this, I can say something like miles driven, right? Same variable, equals, simply use float, and then say miles driven. So instead of a one-step process, I simply divided or created a new step, where first I defined miles driven equals input, asking the user for an input, and whatever the user enters is going to convert the text here to a float point number. So even if the user entered an integer, Python is going to convert it into a float text number. Next, I'm going to ask the user for a new input. So I'm going to say get gallons used from the user, right? So the user is also going to tell us how much gas was used or how many gallons were used. So here I'm going to define a variable, gallons used equals, once again, input, and enter gallons used. And next I'm going to do the same thing. I'm going to convert again. Right, so I'm going to say convert text entered to a float point number. And once I'm done with my comment here, I can simply say gallons used equals float, and once again gallons used, right? Make sure we keep our same variables here. Great. And finally, I'm going to say calculate. This is where a formula would come in, right? Calculate and print the answer. And to do this, I'm going to say the variable miles per gallon equals miles driven, and this is our first variable up here, right? Enter the miles driven right here, and I'm going to say divide by gallons used. This is how you would get your answer. And finally, print the output. So I'm going to say print something like miles per gallon, and then the variable itself. Perfect. So a simple program of calculating miles per gallon. Right off the bat, I printed out this program calculates MPG, where I can specify, of course, miles per gallon instead of MPG, so users understands, right? So whoever looks at the program knows that this program is going to do something. Next, ask the input for the user. Simple variable, asking for the input, converting the input into a float point number, then asking the user for the gallons used, converting that into a float point number, and then finally simply calculating the actual miles per gallon by dividing miles driven by gallons used and printing out our answer. Let's click on run, see what happens. Run module. Of course, save your module first, click OK. This brings up our Windows Explorer. Navigate to the Python folder, and I'm going to say miles per gallon as the name of the module. Click save, and Python tells me, or gives me a title in fact, that this program calculates miles per gallon. Wonderful. Enter miles driven. Let's say I drove, I don't know, 95 miles. Hit enter. Next, I need to enter the gallons used. So maybe I used, I don't know, 12 gallons. Hit enter, and Python tells me that 7.91 is what I used as miles per gallon. So just as simple. I can remove the float, and then I would have the answer as integers. I can add more to this code, for instance, so that I can build upon this existing program. Maybe I want to find out the distances or the costs, or add more code regarding price and multiply price by the gallon to come up with how much did I spend throughout my journey. And of course, sky is the limit, so it's up to you. Great. So simple program. Let's do another one. I'm going to do another program here. So I'm going to click on File, New File, and close the previous one. And let me resize this so that we can also see. Next, let's see what kind of program should we create. How about some averages, right? So we're going to take some test scores and we're going to create some averages of test scores by students. Let me in fact minimize this and see slide here. So here in this project we will create an average for test scores of students, and we will use test scores of 5 students, 3 or 5. It doesn't really matter. I just wrote 5 students so that we get an idea. Let's bring up our editor one more time. Back up. Here we go. Great. So let's start off with a comment creating averages. So I can say something like student 1 equals integer and ask for the input from the user. So I can say input and then enter test score for student 1. Similarly, I'm going to say student 2. Of course, the easiest way is to copy it because I'm going to use multiple students and that is going to require the same input, right? So all that is going to be changed is perhaps the student 1, 2, and so on. So I'm just going to copy this and use the keyboard shortcut as Control-C to copy, and then Control-V to paste, and make sure I change my student 1 to 2 because this line asks for the input for student 2 score. Similarly, I can simply in fact copy this entire line now, Control-C, and simply change student 2 to 3 here, and of course my name of the variable as well. So here's my 3rd student. Similarly, I'm going to have my 4th and 5th students. So I'm going to have 5 students. There's 1, 2, 3, and this is my 4th, and this is my student number 5. And likewise, I need to make sure that I keep consistent, right? So I don't make any mistakes. Perfect. So 5 input statements. Next, of course, I'm going to calculate the average. Pretty straightforward. Write a comment here. Calculate the average score. And here's the formula. So I'm going to use the average variable here and simply say student 1. Next is my student 2. And of course, student 3. And a couple of more, student 4. And then last one is student 5. So far I have 5 students. Close my parentheses, and I'm of course going to divide this by 5. That's how you come up with the averages, right? So it's 1 through 5 students, you divide them by 5, you'd get your average. And next, of course, I need to print the test score by giving a print command. So here's my print. The average score is, and Python is going to give us the result. Of course, I need my variable here because that's how Python would give the result. Perfect. So 5 students. I'm going to enter the integers for all these 5 students, or the scores of these 5 students, and there could be any scores. And Python is going to calculate the average. Let's see what happens when I run this. So let's click on run module. Of course, the source must be saved. Click OK. And I'm going to call it AVG as average. It's the name of the module. Click Save. And Python asks me enter test score for student 1. Let's say student 1 scored 90. Great score. Enter test score for student 2. Maybe 88. Enter test score for student 3. How about 92 once again? And then my 4th student scored maybe 77. And my 5th and my last student, in fact, topped the class by scoring 95 out of 100. So once I've entered 5 students, and this satisfies the requirements of my input, right? 1, 2, 3, 4, 5. If I hit enter, Python is going to calculate the average automatically, saying the average score is 88.4. And this is how Python prints it. So once again, Python, extremely powerful programming language, easy to use, very logical, straightforward. You just have to practice with some of the functions and methods and understand how to code in Python. And of course, the more you practice, the easier it'll become. So I hope this helps. Let's move to our next lesson. So here we are at the conclusion of the Introduction to Python Programming for Beginners course. What have I learned in this course? So this Python introductory course provided you with a solid and comprehensive understanding of core Python features and functionality. This course also demonstrated various concepts by means of extensive hands-on tutorials. And the combination of both theory and hands-on tutorials simply reinforced some of the learning concepts that you can practically apply within your work environment or any other projects that you may be doing. What did we cover in this course? In Module 1, we took a look at the introduction and agenda of this Python course. Module 2, we talked, and I demonstrated various basic concepts in Python, such as methods, functions, variables, simple assignment statements, and so forth. And Module 3 is where we got into the integer arithmetic and we started creating small programs, understanding the logic and concepts of how Python works. Module 4, we dived into functions and variables. In Module 5, taking a step forward, we talked about function definition. In other words, defining functions, how to write a block of code, and then calling those functions by a single name. And Module 6 was object orientation. Here we took a look at graphics, for instance, how to draw rectangles, how to tell Python to draw various patterns and shapes. And then we also talked about the concept of methods and using methods in Python. In Module 7, once again, we created our own number guessing game, for instance, creating averages and other programs in Python just to reinforce all of the above learning concepts that we covered in this course. So the whole idea of this course essentially is to make sure that you get a nice flavor of Python and of a programming language. Just like I mentioned earlier, practice makes perfect. The more you write code, don't worry about the mistakes. Python is very easy, user-friendly. In other words, color codes your coding that you're doing so that you know exactly where you make mistakes and how you can rectify your mistakes. And the more you work with it, the easier Python will become for you. So with this, I thank you for taking this course and I look forward to having you in my next. Welcome to this course on Python penetration testing using Kali Linux. My name is Syed and I'll be the instructor for this course. I've been in the training industry for a little over 20 years and I've trained thousands of students who have become successful penetration testers as well as programmers. So let's take a look at what this course is all about and the structure of the course. There are about 35 or 36 lessons in total within this course. I'm going to start off with lesson 1, which is downloading Python. Lesson 2 is the difference between Python interpreter and idle. And lesson 3, I'll demonstrate the nuts and bolts of a sample Python program. So we'll understand what functions are, methods, classes, and so on. So I'll identify all of those within this lesson. Lesson 4, moving forward, I'm going to demonstrate how to create and work with Python strings. Lesson 5 is getting user input. So for example, when we write a Python program, you're prompting a user to input some data, such as a simple form. Lesson 6 is reading and writing files, how to go about actually accessing files from your own computer. And lesson 7 is working with Python expressions, mathematical expressions, the operators, logical, and so on. Lesson 8, moving forward, is working with global variables. And lesson 9 and 10 are lists and dictionary fundamentals. Lesson 11 are tuples, which are similar to list, but they're immutable. And lesson 12 is all about loops. Moving forward with the conditional execution in lesson 13, and working with our ifs and while loops in lesson 14 through 16. So the objective here is to make sure that you understand the basics of Python programming. Lesson 17 is where we get into the actual penetration testing concepts. Lesson 18, we'll work with 5 phases, and I'll demonstrate what those 5 phases are. Lesson 19 is hands-on into building a web server. Lesson 20 is installing VirtualBox, because we need a virtual machine to install Kali Linux. So I'll demonstrate how to install and go about finding the Oracle virtual machine, downloading it and installing it, as well as all of the configurations. Lesson 21 is downloading and installing Kali Linux, and 22 is all about downloading Python for Kali Linux. So this is where we get into the actual installation of Python within Linux, and then installing the Wing IDE editor so that we can write Python programs, and that's in lesson 23. Lesson 24 is creating our first penetration program using Python. Lesson 25 is working with the TCP protocol, setting up a client using Python programs. And lesson 26 is TCP server. Lesson 27 is reading binary raw packets. So we'll create a Python program to capture those packets and take a look at what those are. Lesson 28 is port scanning using Nmap. It's a wonderful tool that I'll demonstrate. Lesson 29 and 29b is about sniffing. So first I'll demonstrate how sniffing works, and then we'll create our own sniffer, in other words, our own Python program. Lesson 30 is all about SQL injection. So I'll demonstrate how to check for vulnerabilities in your backend database. And this lesson in fact has 3 parts, so there are 3 lectures to this concept of SQL injection, and we'll create a Python program to demonstrate how this works. Moving forward with lesson 31 is brute force with Kali. This is also a 2-part lecture. So I'll demonstrate how to write a Python program that is going to use the brute force and check for our passwords. Lesson 32 is creating a port scanner using Python. So we'll also create a program that's going to go out there and scan all of the ports on our network and identify which ports are open or not. So as a penetration tester, you need to be able to be proficient with all of these tools so that you can successfully test network against any vulnerabilities. So the objective of this course is primarily to work with Python programming language and then create our own tools using the Kali Linux platform to test our own network and become penetration testers. So without further ado, let's jump right in and let's move to our next lesson. In this lesson, I'm going to talk about what penetration testing really is all about. Why do we do it? Who needs it? And why is it important? So let me talk about the vulnerability assessment first. It's basically the assessment of your entire network system to determine if it has vulnerabilities or weaknesses that need to be resolved or patched up. It can be performed by one person, could be your IT administrator, or a team of researchers or security engineers. This type of assessment is often known as a flaw or weakness that could be exploited by an outsider attacker or compromised by internal personnel. So it's both ways, right? So we need to protect our network systems from outside attacks as well as internal weaknesses as well. And it is necessary because many organizations and companies and health facilities, for example, are required to meet certain compliance standards. They are bound by regulatory standards, rules, and regulations that they must meet, such as the HIPAA rules, and we'll talk about those a little later as well. But this assessment is important. So let's get to the definition of the penetration testing in specific. A penetration test is simply a method of evaluating the security of a computer system or network by simulating an attack from a malicious source. And this malicious source can be created by the network administrator or the developer, for example, or the programmer internally, and then use the malicious software to attack the system and just to see whether the system responds, whether there's weaknesses in the system or not. So the process basically involves an active analysis of the system for any potential vulnerabilities that may result from poor or improper system configuration, known and or unknown hardware or software flaws, or any operational weaknesses for that matter in the process or technical countermeasures. So different ways that we can measure the weakness of the system. The basic intent of a penetration test is to determine feasibility of an attack and the amount of business impact of a successful exploit if discovered. And the last part is important, because if your system is attacked, for example, you could lose millions and millions of dollars in terms of sale, in terms of breach, in terms of data loss, and whatnot. So penetration testing is very important. Let's take a look at some of the security testing methods. So every organization uses different types of methods to validate the level of security on its network resources. There are organizations who barely test their network for security threats. On the other hand, there are organizations that test rigorously their network and to make sure that the network is up to the standards. So, for example, the penetration testing, also known as sometimes the ethical hacking, right, so to speak. Although in my opinion, ethical hacking is, well, just hacking and creating malicious software or using a certain program like Python or Java or any other different programs to create these scripts just to test the system. So whether you're testing for accuracy or whether you're conducting a thorough test, these are just different types of tests. For this course, we strictly confine ourselves to the penetration testing using Python. So who needs penetration testing? Well, obviously large organizations such as banks, financial institutions, government organizations, online vendors, or any organization processing and storing private data, such as passwords, subscriber lists, e-commerce data, transactions. The PCI Data Standards Section 11.3 requires organizations to perform application and penetration tests at least once a year. So this is not something that we just do for the fun of it. It's actually required and also safeguards our network system. So for example, the health regulations such as the HIPAA Security Rules Section 8 of the Admin Safeguards also requires security process audits, periodic vulnerability analysis, and penetration testing as well. So again, we need to make sure that we are bound by the legal and regulatory and compliance matters. Why do we really need them, right? I did talk about this briefly, but really computer-related crime is on the rise, right? We see hackers all the time hacking systems. They can hack large banks, they can steal a lot of millions of dollars and so on, right? So this is something on the rise, and as technology progresses and grows exponentially, the threat increases at the same time. So find holes now before somebody else does. So we need to be on top of things, right? And report problems to management immediately, whether it's internal threat or external threat. Verify secure configurations. Do testing and monitoring of your servers, of your network constantly. Make sure you have those alerts turned on. Security training for network staff, sometimes overlooked but equally important. We must train our existing staff and employees so that they can understand some of these security breaches. Discover gaps in compliance, and of course, testing new technology. So these are all the reasons of why we need penetration testing. So penetration testing viewpoints. Well, there are a couple of school of thoughts. There's external and internal. Penetration testing can be performed from the viewpoint of an external attacker or a malicious employee. So as a programmer, developer, or the network administrator, right? You need to create a program such as Python. We are going to create code or use Kali Linux, for example, and then use that system to either check our existing network internally or from an external perspective. It could be either overt or covert, and penetration testing can also be performed with or without knowledge of the IT department of the company being tested. So you could just shoot out a malicious code and program, or do a port scan, for example, just to make sure everything is current. So depending upon your own scenario requirements and guidelines and rules and regulations of the company, you would conduct the penetration tests. So in conclusion, we talked about what a penetration test is, right? Different methods such as internal audits, ethical hacking, penetration testing. Who needs penetration testing? For that matter, in my opinion, everyone needs penetration testing, whether you have a small network or you have a large size enterprise-wide network. As long as you're keeping private data, you need to make sure that your network is up to the standards. And we also talked about why we need penetration testing, and of course some schools of thought or some viewpoints as to when and how to conduct these tests. So in this brief lesson, I just wanted to talk about and give you an idea of what penetration test is all about, and different tools that we can use such as Kali Linux, Python. We can create all these codes and run these tests on our network. So I hope this helps. Take a look at some of these definitions, and let's move to the next lesson. Welcome back. In this lesson, I'm going to talk about the phases of penetration testing. So you just don't go about and start conducting various tests on your network, right? So there's a methodology that we must follow as ethical testers. And I'm going to talk about these phases as well as steps that are involved in penetration testing. First, you need to identify and create a tool set. Now by tool set, I mean you need some software, right, to test your network. So the better combination is using Kali Linux and Python. And Python itself has several key tools that we can use to test the network. So such as port scanners, brute force, and of course we can create our own as well. So this is the first sort of like at a macro level, think of coming up with the actual set of tools that you will use to conduct the penetration testing. Once you identify the tool set, next comes the 5 phases of penetration testing. Step 1 is building a threat model. So like I said, you just don't sit in front of your network and start testing, right? There has to be a plan in place. You need to know exactly the goals and objectives that you wish to reach. So in building a threat model, you identify risks and threats. You break the threat down into smaller parts, just like you would do create an outline, and then you would do different parts within that outline. In other words, different steps within that particular topic. So you build a threat model first. Then you move to step 2, which is actually creating the test plan. How are you going to go about doing so? So this is your roadmap for the security testing efforts. And also make sure to pin down the deliverables, right? The goals and objectives, activities, timelines, and the resources that are required. So this is your test plan. Again, step 1 and 2 are very important. You might have to involve the organization, right? Or if you're doing it on your own, either way, you must have the ability to create a test plan before you can actually go about testing your network. Step 3 is executing test cases. The vulnerabilities in the file system registry, for example, the user interface security, injection, design security, unsecured ports, and so on. So this is where you would actually go about doing the actual test cases. And step 4 is creating a problem report, which is simply a proof of the presence of vulnerabilities, which covers the steps to reproduce the severity of the vulnerability and the exploit scenarios. Okay, so these are basically your findings. And finally, in step 5, you perform a postmortem, where you're actually analyzing the bugs found and identify root cause of miss in development. And through RCA, you can improve the process for future projects. So if you take these steps in this particular order, you'll become a better penetration tester. And that's exactly how we are going to progress moving forward within this course using Kali Linux and Python. We are going to first create a threat model, create a plan, execute these test cases, which is the meat part of the course, is basically executing the test cases, and then creating reports and performing the postmortem. But overall, we'll be focused primarily on working hands-on with our tool set. Some of the steps in penetration testing. So just a quick recap on the previous slide, right? So we establish a goal, we gather the information, you do some reconnaissance, discovery, do some port scanning, for example, the vulnerability scanning and the analysis. Then you take control and exploitation. Maybe you want to use some brute forcing to check your network, social engineering, and finally reporting, evidence collection, and risk analysis. So more or less the same phases, but these are mainly the steps that you would go about taking when you conduct the penetration tests. Here's the overall general testing methodology. So once again, you start with the green part, which is the network reconnaissance, for example, service discovery, the identification of vulnerability areas, then the exploitation, and then the rating as well, and then the circle goes on and on. So again, this is just the network penetration testing general methodology that you can follow. So white hat testing, maybe a new word, maybe you've heard it before, like white hat or black hat. So penetration tests are sometimes called white hat attacks because in a penetration test, the good guys are attempting to break in, right? That's what we're testing, the vulnerabilities of your system. So the term white hat refers to an ethical computer hacker or a computer security expert who specializes in penetration testing and other testing methodologies to ensure the security of the organization's information systems. And this may be because of the rules and regulations in place that mandate such testing, such as the HIPAA regulations for the healthcare industry. On the other hand, the black hat testing is obviously non-ethical, right? These are the actual hackers that want to break in to a system and maybe steal information or do some malicious attacks on those systems. Okay, so we want to stay on the white side, right? The white hat testing. So in conclusion, we talked about a simple penetration tool set, various phases of the penetration testing. We also discussed the steps and the general testing methodology. And finally, we talked about the black hat versus the white hat or ethical hacking. So just go over some of the terms. You may hear them over and over again throughout this course. Get yourself familiarized with some of this terminology as well as the steps. So I hope this helps, and let's move to the next lesson. In this lesson, I'm going to demonstrate how to create a web server. But before we actually go about creating a web server using Python, let me talk about sockets. So Python provides basically two levels of access to network services. At a low level, you can access the basic socket support in the underlying operating system, right? Which allows you to basically implement clients and servers for both connection-oriented and connection-less protocols. On the other hand, Python also has libraries that provide higher level access, right? So the first one was lower level, right, to the operating system. And this one is a higher level access to specific application level network protocols such as HTTP, FTP, and so on, right? So sockets, think of them are just the endpoints of a bidirectional communication channel. And sockets may communicate with a process, between processes on the same machine, or between processes on different continents for that matter, wherever the servers reside. So let's go ahead and I'm going to demonstrate a couple of things here. First, of course, we will create our web server, and then I'll also demonstrate how to connect to google.com and ping Google as well. So let's go ahead. Let me start with the import socket. And let me go ahead and first save this. So I'm just going to do a Control S. And I'm going to save this within my data files folder. So navigate to my documents here, data files, come down to my Python. That's where all the files are. So we're going to say my server5.py, right? You can give it any name. And make sure you have the py extension, right, when you give a file name. So I'm going to go ahead and click on save here. And notice our Sublime editor automatically color codes it, right? So good thing. Let me put a comment here so we can also see. So this is our first step basically. So first of all, we are importing the socket library. Okay, that's where the comment is. You can of course place the comment on the second line if you like. Let me go ahead and place this on the first line, in fact, so it's easier sometimes to see. Perfect. So once you've imported the socket, next I'm going to place these comments so it's easier for you to take a look at and remember also. So create a socket object. That'd be a next step. So I'm going to say s equals, use the socket method, and simply do a print. And what am I printing here? A success message, right? So I'm going to say something like socket successfully created. And next, I'm going to reserve a port, or tell Python to use or reserve a port on the computer so that it binds to that port. Okay, so first I'm going to say, let's say, put a comment here quick. So reserve a port number, and I'm going to say port equals, and this could be any number. This could be something like 1, 2, 3, 4, 5. And next we're going to bind it, right? So bind to the port. So we've not really typed any IP in the IP field, for example. Instead, we have inputted an empty string, and this makes the server listen to requests coming from other computers on the network. And that's exactly what we're going to do next. Okay, so we're going to use the bind method. So I'm going to say s.bind, and here I'm going to say comma to the port. Okay, and that's what I meant by that. It was an empty string, because once again this is going to make the server listen to requests coming from other computers on the network as well. Alright, so next do a print, and I'm going to say something like socket binded, right? So another success message. So socket binded to, and then use our modulus s, and then of course our modulus port number. Perfect. So what are we going to do next? Once we've binded, next we're going to listen, right? So we're going to tell Python to put the socket into the listening mode. So let me put a comment here. So put the socket into listening mode, and s.listen, and let's say 5, and of course print, and say something like socket is now listening. Great. Alright, so once we've binded the port, we've configured our listen, next we need a loop, right? So that a forever loop until we interrupt it, or if an error occurs. So let's say once we were to test this, we need to also interrupt ourselves. So we need to create a while loop. So let me put a comment here. So a forever loop until we exit or an error occurs. Great. So let's do our while loop. So it's while true flag here. And we're going to do, let's say I'm going to put a comment here one more time. So establish connection with client. I'm going to say C, and then our ADDR would equal s.accept. It's a method, simply do a print. And in this case, we're going to say got connection from, and I'm going to say ADDR. Of course, a quotation goes in here. Great. So let's run this. Let me go ahead and save this. So I'm going to say Control S. And then to run in Sublime, you have to do a Control and then B. Bravo, right? So do this. And line 24, of course, my indentation. So let's move this up here, comment also, and this also, and our print as well. Okay, because we're doing the while loop here. So save again, run it. And this time is line 12, and it seems like the protocol or network address port is already being used. So let's go ahead and change this. So 1, 2, 3, 4, 5, let's say 6. And then it's going to bind it to this port. Perfect. Save it, build it. All right, so it says port must be between 0 and 65535, which is great. So I had just a tad extra number, right? So let's fix this. So I'm going to say port 1456. All right, this time it should work. Control B. And now it says socket successfully created. That's our first print, right? That's what we did. We used the socket method. And then it says socket binded to port 1456. Perfect. And it says s.bind. And then, of course, socket is now listening, which is going to start to listen. And, of course, our while loop that is going to continue. So here we simply created a socket. Now let's test, right? So we need a client now. We can telnet or use a terminal window to test and see whether our socket that we created at 1456 is working or not. So let me go ahead and open up our simple terminal here. So I'm going to say something like telnet, just basic stuff here. Move this here so you can see. So here's our telnet prompt. So I'm going to say open localhost and then our port number 1456. And it's going to try to connect to the localhost, and it says got connection from our localhost, which is 127.0.0.1. That's the IP address, right? And then of course it tells me that it is now trying to connecting, and my server says it just received a connection from my telnet terminal. Perfect. So you understand how we can create a simple web server, and then of course make sure we can telnet into the port by creating or opening up or binding a socket to a certain port. All right, great. So practice with this lesson. And I also mentioned that I'm going to do the Google Connect, right? So we're going to do and try to connect with google.com. So in fact, let me do this quick here, okay? So I'm going to close this out, open up a new window here, and let's go ahead. So let's put a comment here. So I'm going to say let's connect to Google. Perfect. Let me go ahead and save this. So I'm going to say google.py. Let's give it a name. Perfect. So our next line would be, of course, to first import the library. So import socket. And then we also need to import the sys library. Let's go ahead and do the try. And then, of course, our variable s equals And here goes our socket method, and in this method we're not going to leave it empty, right? So we're going to say socket.af underscore inet comma, and then we're going to do socket.sockstream. Great. So we first made a socket, and then we resolved Google's IP, and lastly we connected to Google. So this is the whole idea of this entire code that we're writing, right? So once that's done, I'm going to go ahead and say print. We need that also. So socket successfully created. All right, so it's going to try to connect, and I'm going to say except if socket gives me an error as error, then it's going to print something else, right? So it's going to print socket creation failed with an error. Get our modulo, and then of course the percent, and then the error. Perfect. All right, next let me put a comment here. So is the default port for the socket, and this is going to be port, guess which port? It's the port 80, right? Because all HTTP requests by default use port 80. And next I'm going to say try. Here's the resolution comes in, right? So host, let's say IP equals socket dot get host name. And what's our host name? Of course it's google.com. And I'm going to say accept. It's the same thing that we did earlier. Socket dot GAI error. And this means that it could not resolve the host, right? So we need to also, right after the accept, we need to tell Python to do this. So I'm going to say print there was an error resolving the host. Great. And of course do the sys exit. And finally, a couple of more things that we need is of course connecting to the server, right? So let me put a comment here quick. Connecting to the server, and we just do the sconnect. S.connect, and of course we need the host IP that was defined earlier and our port. And finally we do the print that the socket basically was successfully, right, or connected. So I'm going to say the socket has successfully connected to Google, and then also specify the port. So with a slash on port equals, right, two equal signs means equals, %s, and then we need our host IP with a %. So host IP. Great. So our code is complete. Let's try to connect to Google and see if it resolves the name. Let me go ahead and save this and execute this. All right, what did we get? Line 15, host IP get host name, and the type error is takes no arguments, one given. All right, so the error is this that we need. It says get host by name, right? So I missed the by. Save this, run it again. Awesome. So it says socket successfully created. The socket has successfully connect to Google. Of course I need my spelling here. Successfully. The socket has successfully connected to Google on port following. Let's save it, run it again, so we have our sentence corrected. Awesome. So a simple way to connect and basically first we made a socket, then we resolved Google's IP, and lastly we connected to Google itself. You could try it with any other site as well. So if I want to say something like any other site like claydesk.com, and I'm going to say here, I'm going to change it to Claydesk, save it, execute it, and it also says socket successfully created, and it's still trying to get the host IP, and it says it's successfully connected to Claydesk on port 192.232.221.134. So this way you can use to find out and connect by creating sockets. So I hope this helps practice, and let's move to the next lesson. Welcome back. In this lesson I'm going to demonstrate how to go about downloading and installing a virtual box. Very popular VM known as the virtualbox.org. You can simply go to that site and download the Oracle virtual machine. And this is exactly what I'm going to show you, because this is something that we need for Docker. Before we install Docker, we will need to install the VM. However, there's a newer version of Docker for Windows only, but that's in beta version. Okay, so I'm going to in fact demonstrate both of these versions, but in this lesson I'm going to focus on how to go about in downloading the virtual box. So just open up your browser, go to google.com, and let's go ahead and search for something called virtual box. And the very first URL is Oracle VM VirtualBox, and the URL is virtualbox.org. So simply click on this link, and this takes you to the VirtualBox page. And of course, right in front of the screen it says download VirtualBox 5.1. It's in fact a very straightforward process. Okay, so all you have to do is just download and follow the steps, and you'll be able to install the VirtualBox on your machine. So I'm going to go ahead and click on download VirtualBox 5.1, and here I can select the platform or the version, right? So for example, if I have Windows, I'm going to go ahead and download and click on this link. If I have OS or Linux or Solaris, I can click on the respective links as well. Of course, I can also download and install extension packs and so on, and of course guest editions for Linux guests as well, and we'll be installing this later on and using these as well. But for right now, if you need to install just a simple VirtualBox, go to the download link, click on the latest version, and then choose the operating system that you are using. So in my case I'm using Windows, so I'm going to go ahead and click on VirtualBox 5.1 for Windows hosts. So click on this link, and of course simply choose the folder where you'd like to save this, click save, and this is going to download the executable file for you. Alright, great. So once the VirtualBox 5.1, which is the latest version, is downloaded, simply go ahead and click on this, and this will bring up just a simple security warning. Just click run, and it will start the installation process, and the wizard will come up and walk you through the installation of the VirtualBox on your computer. So the Oracle VM VirtualBox, welcome to the Oracle VM setup wizard. Click next, and of course it's going to select all of these options that you need to choose in order for you to install, and of course you can also change the location of the program itself. So I'm going to leave it as is. Just simply click next. It'll create a shortcut on your desktop on the quick launch bar and also register your file associations. I'm going to go ahead and click next. And just a simple warning message about network interfaces. Installing the VM box networking feature will reset your network connection and temporarily disconnect you from the network. So no big deal, it does it on the back end anyways. So just click yes, and it's going to install the VirtualBox on your computer. And it brings up the user account control dialog box. Simply go ahead and click yes. If you don't get this message, that's fine. If you get this dialog box, all you have to do is just click yes, and it will again continue with the installation process. And once the installation is complete, make sure this checkbox is checked where it says Start Oracle VM VirtualBox 5.1 1.0 after installation, and just simply click finish. And what this will do is it'll open up the VM for you. So once again, a fairly straightforward process in setting up a VirtualBox on your machine. And here's the Oracle VM VirtualBox Manager, and notice I already have Kali Linux running on this VM, and of course once we install other programs like Docker, for example, it'll run those instances as well. And I'll demonstrate how to set those up by clicking on details and then setting up your settings and settings options and creating a new VM as well. Okay, but just wanted to demonstrate how easy it is to install the VirtualBox on your machine. So as a practice task, go ahead, go to virtualbox.org, and then of course download it and install it and then work with it. So with this, let's move to the next lesson. In this lesson, I'm going to demonstrate how to download Kali Linux and then do the installation on our virtual machine. So just go to your browser, open it up, and navigate to this URL, which is kali.org/downloads. And of course, you can always search on Google, just search for Kali Linux downloads, and you will get this link. Click on this link and you will be navigated to this page. Now, once on this page, you'll have several options. So let me walk you through what those are briefly, and then I'll demonstrate which one to download. So first that you'll see are the Kali Linux download images. So these are the ISO images. In other words, you can burn them on DVD and then do the install. Okay, so you can download them using the torrent, or you can download the direct ISO image. So this could be 64-bit, 32-bit, and depending upon which one do you wish to download. And the size of this is about 2.6 gigabytes. So it's a fairly large size file. And along with this file, you'll also download the security sum, right? The SHA-1 sum as well. Just a small file that gets downloaded once you download the torrent or the ISO image. The other option, if you scroll down, notice you'll have the option to download Kali Linux, VMware, VirtualBox, and ARM images. So if you're looking for, let's say, the Kali Linux VMware, the folks here have generated different flavors of Kali, so you can use these as well. And if you scroll down, you can download images securely. And of course, last one is if you want to play with these custom Kali images. Okay, so you can run the commands such as apt-get, and then you get the images, only if you're feeling a little adventurous. Okay, but for our purpose, I'm going to do a plain vanilla install, full install of Kali Linux, the latest version, which is 2016.1. And just go ahead and click on the torrent link, and it will open up your torrent browser, or if you have torrent installed, if not, you can directly download it. Okay, so I'm going to leave that to you as a simple task. Just simply download, and it will download the image, save it to your computer in one of your hard drives. Okay, let's move on. So once you have it downloaded, next is when you open up your virtual machine, the Oracle VM box that we installed and downloaded in one of the earlier lessons. You just open up your VM box. So let me go ahead and open that up. Here it is. So once you have the Oracle VM VirtualBox Manager open, this is where you can now install and create a VM for your Kali Linux installation. First, you have to create a virtual machine. Now, I already have, let's say, the Kali Linux version installed because I've been working with it. So I'm going to do it fresh installation so you can actually see how it's done. Just a simple prerequisite before we actually start creating a VM and installing Kali Linux, make sure your hard drive has a partition or area where you need to install. So for example, let me in fact show you this. Let me bring up my disk management here. It's much easier when you actually see things, right? Perfect. All right, so here's the different drives or partitions that I have on this computer. So my ClayDesk C, which is the primary partition, which is right here. And then I also created a partition called K Linux, which is my K drive. Has about almost 14 gigabytes of space. So you can create a partition right from your Windows machine. If you're not running a Windows machine, you can use a third-party software like Partition Magic, and there's so many out there. Just use those simply and create a partition. Now, when you install Kali Linux, you don't have to create this partition, by the way, okay? Kali Linux will, during the install, prompt you to create a partition. But it's my recommendation that you already have created a partition before or prior to Linux installation. And here's the reason why. Several of my students, for example, have installed Kali Linux and accidentally used their primary partition. And what happens is during the install, Kali Linux will format your drive. So there you go. So you don't want your C drive formatted, right? So good idea, good practice to create a partition first using either a third-party tool, or you can do it directly from Windows, right? So for example, just right-click on your partition, click on shrink volume, and it'll walk you through the creation of the partition. So you can do this way, or you can use a third-party tool like I mentioned earlier. So in any case, this is important. So you want to be able to make sure you have this partition created. Great. Let me minimize this. So back to our Oracle VM. So let's go ahead and first create a VM for our Kali Linux install. So I'm going to click on the new button here on the menu, and this brings up the create virtual machine dialog box, prompts me for a name. I'm going to go ahead and call this Kali 2016. Everything is default, and instead of being in the expert mode, I'm going to go ahead and click on guided mode so you can walk you through. It's easier for you to see that way. Okay, so the first step is name and operating system, right? So one more time, I'm going to say Kali 2016. The type is Windows. If you're running a different operating system, of course you can select that. I'm running Windows. And your version as well, whether it's Windows 7, 64-bit, XP, Vista, and so on. Okay. All right, so click next. Memory size is important, where you need to select the amount of RAM that you need to allocate to this VM. So for the Kali Linux, for example, I'm going to say, let's say about 2 gigs of RAM. Click next. And next is the hard disk. Now this is where the recommended size is about 25 gigs. I already have about 15 gigs of space, which is fine, no problem, but recommended is about 25 gigabytes. You can either create a virtual hard disk, or you can use an existing disk file. So we don't have an existing disk file, so I'm going to leave this option as is and click create. The next dialog box simply asks us to choose the type of file. So we will leave the default VDI, which is the virtual box disk image, and click on next. The storage is going to be on physical hard disk, which is going to be dynamically allocated hard disk. Will only use space on your physical hard drive as it fills up, right? So we want to be able to use and choose this option. Click next. Here's the file allocation size. So we need to select the size of the virtual disk in megabytes, right? So this is important. It's not in gigabytes, it's megabytes. The size is the limit on the amount of the file data that a virtual machine will be able to store on the hard disk. And of course, I can move the slider up and down depending upon the size that I wish to allocate. So I'm going to go ahead and say maybe, I don't know, something like 10, and click create. And here are the settings for our new Kali 2016. Right now it's powered off, right? Because all we did was created a virtual machine with all of these settings as specified. Now once the machine is created, next step obviously is to do the install, Kali Linux install on this virtual machine. Now we did download the ISO image, right, from our torrent image, or the torrent download, or the ISO torrent image that we downloaded and saved it in the previous lesson that I mentioned once I started this lesson. All right, perfect. Go ahead and click on start, and this is going to go ahead and start our virtual machine. The first thing it says, please select a virtual optical disk or a physical optical disk containing a disk to start your new VM from. So I'm going to go ahead and simply navigate to the partition, and here's my Kali Linux, and here's the download file, right? So this is the ISO image, and notice the size I scroll to the right, about 2.8 gigabytes, right? So that's the correct ISO. Just select this, click open, and click on start. Perfect. So our status in the background says Kali 2016 is running, and it brings up the boot menu where we can start our Kali installation. Okay, so let's see if I can click on view and full screen mode. Just say switch. All right, so here's the first option, right? The boot menu. Several ways we can do the install or start the install. So the easiest way, the best way, recommended way is the graphic install. So I'm going to go ahead and choose graphic. I'm using my keyboard, by the way. So click graphic install. And next, it brings up a menu which says select a language. So simply select English, click continue. The location is US, click continue. These are pretty straightforward default settings, okay? The keyboard is, of course, American English, click continue. And now it's going to detect and load the components from the CD or the ISO image, right? So it's going to walk us through step-by-step installing Kali. All right, so configure the network. Please enter the host name for this system. So I'm going to use Kali 2016. And of course, I want to make sure I use the same convention. So click continue. Next is the domain name, which is part of our internet address to the right of your host name. So I'm going to call this again Kali 2016. If you have a domain, you can use that as well, or any name would be fine. Click continue. Here's the root password. Okay, so you want to be able to create a password. We need to set the password for the root or the system administrative account. So I'm going to go ahead and give it a password here. Typically a strong password, by the way. Click continue. Next, configure the clock, which is the Eastern Standard Time or Central Standard Time or wherever you are. So click continue. So here's the important part. The installer can now guide us through the partitioning of a disk. And Kali Linux brings me to a window where it says partition disks. This is the drive that I'm looking for. I can, of course, configure the volumes. I can work on guided partitioning, or I can select the VBox hard disk as well. I can undo changes to partition or finish partitioning and write changes to disk as well. Okay, so let me walk you through the guided partitioning so it's easier for you to see. So click continue, and let's click on the guided use entire disk option. Click continue. So here's the SCSI disk that we just created. Click next, and I can now select, or the disk will be partitioned using one of the several different schemes. So all files in one partitions, which is recommended. Click continue. And of course, I can simply choose finish partitioning and write changes to the disk. So go ahead, click next or continue. If you continue, the changes listed below will be written to the disks. Otherwise, you'll be able to make further changes manually, right? So the following partitions are going to be formatted. Partition 1 and partition number 5, and choose yes, because now it's going to make the following partitions, format them, and then do the installation. So click continue. All right, so once the installation is complete, next is configure the package manager, which is a network mirror. It's simply used to supplement the software that is included on the ISO image or the CD-ROM. Okay, so make sure this is selected as the yes option. Click continue. And this is where the proxy information comes in. So if you need to use the HTTP proxy to access the outside world, we can enter the proxy information here. Otherwise, we can leave this blank. So if you want to use it, then you must use it within the format as shown, such as HTTP, username, password, and then the host. So we're going to leave this blank for none. Click continue. So at this point, it simply says that install the grub bootloader on a hard disk. So click continue. And this is where I can choose and select my hard disk here. This is my VirtualBox hard disk. So simply select this and click continue. And this is going to go ahead and install the bootloader on that VirtualBox. And finally, the installation is complete. So click continue. And it brings up to our loading screen, and then finally it's going to load and bring up the interface. Perfect. So it asks for the username. So I'm going to go ahead and say root, click next. The password, it's the same password that we gave earlier, and click sign in. And here we go. So finally we're into Kali Linux, right? So I can simply, for example, just to make sure I have the prompt, right click and click on open terminal, and this brings up my prompt. So in this lesson I just want to demonstrate how to download Kali Linux and of course set up a virtual machine and then install Linux on it. So practice, hope this helps, and let's move to the In this lesson, I'm going to demonstrate how to install Python on Kali Linux. Now, we did this in the previous lessons, but here we're just going to work within Kali Linux now, and then I'm going to download Python, both versions. So I'll demonstrate and I'll show you which ones you can download. By default, when you install Kali Linux, it comes with the Python 2.7 version. So you're good to go in that respect. But if you need to install the latest version of Python 3.5, for example, or whichever one is the latest, I'm going to demonstrate how that's done. So let's first, a couple of ways we can do it. We can use the terminal or we can use the GUI interface as well. I'll show you both ways. All right, so let's open up our browser here. It's called the Iceweasel. Maybe it's going to be merged with Firefox pretty soon. So here you just navigate to python.org and then you to the downloads page, and you'll notice you'll see the download Python version 3.5.2 or the 2.7.12. So it depends on whichever version you'd like to download and install. So let me bring that back up. Great. So let's go ahead and simply click on the Python version 3.5.2 because that's the one that we've been using so far. Okay, so I'm going to go ahead and click on download, and I can scroll down and take a look at the release date for the 3.5.2 version, which is pretty current. It's June 26th. And then of course it also tells you the new features in 3.5 series as compared to the earlier versions. So there are some differences, right? So as you code in Python, for example, you may have to use brackets or within your print statement. That's one of the differences between 3.5 version versus the earlier versions. So it depends on whichever version you're comfortable with, right? And find out the zip file here, which is the tarball file, or I can download the XZ compressed file as well. So I'm going to go ahead and do the XZ file. This is a compressed file. Brings up a simple message that you've chosen to open the Python 3.5.2.tar.xz, which is fine. So I'm going to go ahead and click Save File. And once the file is saved, you can simply navigate to your folders and just have a look whether it's there or not. So I'm going to go ahead and click on the folder here, which opens up the Explorer, and I can see various folders that are stored within the Kali Linux. So here are all the folders. So for example, if I click on, let's say, downloads, you'll notice I have the Python versions installed. Of course, we downloaded previously also, so therefore you'll see all these files. Okay, so we have the Python 3.5.2.xz file. Now what I can do is I can uncompress it, right, or unzip it, in other words, or I can move it to a certain folder before I do the install. So instead of within the downloads folder, I can use the a different folder, for example. Okay, so I'm going to go ahead and simply choose the Python file, and let's go ahead and move it to the desktop. I'm going to close this for now. Once it's moved, close the download screen. All right, let's bring up files. Let's move it to a different folder. I think that's better instead of placing it on the desktop. So let's go ahead and click on the folder one more time here. And let's see, maybe I would like to create a new folder or just use any one of these. So how about this ClayDesk? So let's put this within this folder. So I can simply right click on this and open with the archive manager, or I could choose extract here as well. So here's the Python folder, Python-3.5.2. So I'm going to go ahead and move this to the desktop. And the reason why I do this on the desktop is just easier to work with the terminal. You can just change your directory to your desktop, or this is fine too. So whichever way you're comfortable placing the Python files in. So let's go ahead and close this. Close this. So here's our folder. And let me open up the terminal. So before I, in fact, begin the Python installation process, I'm going to go ahead and just make sure everything within Kali Linux is updated. So I'm going to go ahead and just simply do an apt get update. So let's do sudo apt get and just type update. And this will ensure that I have the most current and updated files and packages within Kali. So once the update is done, let me go ahead and just do an ls here to find out our directories. So navigate to the desktop, so change my directory, do the ls. So here's our Python folder. So let's go to our Python 3.5.2, and just to make sure we have all the files. Perfect. All right, so let's get started with the installation of Python 3.5. Now we have downloaded it, right? And we have extracted the files on our desktop. You can see there's a folder behind us, right? So I'm going to go ahead and simply first do the ls and just make sure we have all the directories. And let me change the directory to desktop, verify, do the ls, and we have the Python 3.5.2 folder. So let me switch to the Python directory. So that's 3.5.2. And let's have a look what's inside the folder. Great. Now, in order to install, we need to first create a make file, right? So in order to do this, I have to run, let's say, // and then configure. And what this will do is it will create a make file within the Python directory. And this is going to take some time. So let me go ahead. Once we're done, do the ls again. And you'll notice there is a file called makefile. So next, of course, let's run the makefile, and the command is just make. Hit enter. Great. So our Python setup is now complete. So let me clear the screen here. So once the installation is complete, let me go ahead and just type Python just to make sure. But notice it still shows you the default version, which is 2.7. So let's go ahead and exit out of here. In order to bring up the Python 3.5 version, you just have to make sure that you do Python 3.5, and you'll have your Python default to 3.5.2. Great. So I hope this helps practice downloading Python and installing Python on Kali Linux. With this, let's move to the next lesson. In this lesson, moving forward, I'm going to demonstrate how to download the Wing IDE editor for Python. So we can use any other editor as well, but since professional developers, we use the Wing editor. You can download a 30-day free trial, which I'm going to demonstrate how to do that and how to download the editor so that we can easily create programs using Python and do our penetration testing. So let's go ahead and open up our browser, the Iceweasel. So once the browser is open, let's navigate to our URL or search for, I believe it's wingware.com. Perfect. So let me maximize this so it's easier for you to see the entire page. So Wingware is the Python IDE. Okay, so it's a very powerful debugger. It has intelligent editor work together to make interactive Python development fast, accurate, and fun. So several things that we can do with this editor. We can write the code faster, fix the bugs, navigate code with ease, edit our favorite key bindings, and customize and workspace and other features as well. So let's go ahead and navigate down to our download page here. So let me see if I can find it. It says download free trial. Let's go ahead. Let me make sure that we have our Debian version to install, right? So I'm going to go ahead and click on download and choose the Wing IDE Professional. Here we go. So once you get to this page, notice there are several options such as the Debian package, 64-bit, RPM, or tar installer. So I'm going to go ahead and simply choose the 64-bit Debian package, and I need to go ahead and save the file. So click OK. So once the file is saved, we need to navigate to the folder where the file is. So let me minimize this. So once it's downloaded, let me go ahead and just verify, make sure that it's in the folder. So I'm going to go ahead and click on Files, and then within my Downloads folder, so here it is. All right, so this is the Wingware or the IDE for Python. So next, let's go ahead and install this. So let me close out of here. I'm going to use the terminal. Open up our terminal. So once I'm in the terminal, for example, let me go ahead and do the installation. There might be areas where we need to install dependencies. So I'm not sure whether I have them already or not, but in any case, we will know. So I'm going to go ahead and run the package here. So it's dpkg, and then and then I'm going to use the Wing IDE. I think it's 5_5 version .1.8.1 AMD64.deb. Alright, just let me verify this so we don't make any mistakes. Let me go back to our folders, download. Alright, so this is our Wing IDE 5_1.1.12-1. So this is going to be, let me go ahead and fix this quick. So it's 5.1.12-1_AMD.deb. Perfect. So let me go ahead and execute this. Or before we even get to dependencies, let me in fact change my directory here. That was one of the first things that we needed to do. So download, it's actually downloads. Let me do the ls here. Alright, so here's our Wing IDE 5 version. So let's execute the package here again. Alright, it says error processing, install, and let's verify whether we have the right path here. So it's dpkg space I, and then it's Wing IDE 5_1.12-1, and it's AMD64. So I forgot the 64 here. Perfect. Let's try it again. All right, perfect. So it's now reading the package and unpacking the Wing IDE file. So the dependencies were automatically installed. Otherwise, you can just run the apt-get command to install the dependencies. Okay, so if you don't get those, you can always run the apt-get command and then execute the dpkg package. So let's go ahead and take a look at how our Wing IDE editor looks like. So let me go ahead and navigate to all applications here, show applications, and let's go ahead and just search for Wing IDE, and here we go. So let me click on the Wing IDE Professional 5.1, and it's going to open up the editor. And of course the license agreement comes up. Simply click accept. Also brings up any updates that the Wing IDE has or are available for you to download. So I'm going to go ahead and click on install. Make sure you have this automatically check for update box checked. Good idea so that everything keeps current. So let's click on install. So once the patches are updated, for example, it just tells me that restart the Wing IDE. So I'm going to click on restart now. And of course it says no license found and gives me options because it's a trial version. So you can either obtain or extend a trial license, for example, purchase a permanent license, install and activate, or do a 10-minute emergency session. So I'm just going to go ahead and obtain or extend a trial license, click continue. Click continue one more time to activate the trial. Perfect. So it gives me a little bit of time to work with the Wing editor. Great. Click OK. So here we are within the editor. Great. So this is a WingWare Python IDE, and we'll be using this for our penetration testing. So I hope this helps. In this lesson, I wanted to demonstrate how to go about installing the Python IDE. So practice, and let's move to the next lesson. Welcome back. In this lesson, moving forward, now the fun part begins. I'm going to go ahead and create our first penetration test program using Python. So the example I'm going to use is a simple locked zip file that you have, and you just don't know the password. So you need to crack it open or find out how to go about extracting the password. Okay, so as long as you have the concept and you have the code, of course, you can apply it to your own environment as well. So let's begin. First, let me show you what's available, and then I'll begin the Python code. So I'm going to go ahead and first navigate to my folders. So here I have a test folder. So I'm going to open this folder and show you two things. First is, of course, the locked zip file, or the RAR file, whatever that is. In this example, we're using the zip file. It's called locked.zip. And the other one is the dictionary.txt file. Now this contains different passwords to the zip file, but I am not sure which one is the correct password. So I'm going to go ahead first, show you the dictionary file. So here's the file, right, which contains all these passwords. So I'm not sure which one is the correct one. And again, this is just a sample set. You may have thousands and thousands of passwords, and complicated passwords, not as simple as these, like New York, Chicago, password 12345, and so on. So a simple dictionary file, dictionary.txt. Let me close this. And here's our locked zip file. So if I were to try to open this file, now this file has something called a picture, but it's locked. If I were to double click on this, it asks me for a password. And again, I'm not sure. 12345. This is wrong password. How about New York? I'm just guessing, right? So it still says wrong password. So how do we go about using Python, create a program using our penetration testing techniques, right? And how do we crack this open? How do we open up our locked zip file? So a fairly simple program that I'm going to demonstrate as our first stepping stone before we move forward into more complex areas such as brute force attack, port scanning, and so on, right? So let's click OK to this, or cancel. Close this. Great. So next, I'm going to go ahead and create our code. So I'm going to open up the Wing IDE Professional 5.1, which is the Python editor, so that we can start to write our code to unlock this zipped file. I'm going to go ahead and click on continue working because we are on a trial license. By the way, you can use other editors like Sublime, for instance, and you can configure those. Those are free editors, okay? So if you don't want to use this, no problem. It's the same thing, same concept. All right, so I'm going to go ahead and create a new file. So let's call it file new. I'm also going to go ahead and close these files, right? So I'm going to close all first and then start. Don't save any of these files. Let's start afresh. So here we go. So first I'm going to go ahead and write the Python code. Maximize this so it's easier for us to see. All right, let's go ahead. So start with the import. Some modules here. So the first module we're going to import is opt parse. The second one is the import zip file, because we are going to be trying to crack the zip file. And then of course our third is the threading. I'll get more into threading later on, okay? So not to worry at this point, just we're importing these modules, right? And this is called thread. So once we have structured the modules or imported all these modules, let's go ahead with our code. So let me go ahead with the definition, call extract, and I'm going to call it zip. Name of the file, which is zip file, or let's call it Z file, and then password. So here's our first definition. What goes in the definition is that it's going to try to extract the password, and then if found is going to print the password, except move on, right? So that's the logic. So go ahead, let's say try, and I'm going to say Z file dot extract all, and then our password is pwd would equal password, some variables here, and then of course I'm going to print if found, right? So let me first put a plus sign here. So password found, put an extra space, and concatenate this with the password, and then use the /n for the line, and then I'm going to say except pass. Great. My next definition would be our main function, and here I'm going to go ahead and use the parser, and this is going to equal to opt parse dot option parser, and then of course I'm going to give it a usage. In other words, eventually when we get to the end of the program and execute this program, it's going to prompt us. Okay, Python is going to ask us, all right, enter the name of the zip file that you want to crack open, and along with the zip file, enter the name of the dictionary.txt file, or whatever the name of your text file is, which contains all these passwords that you've forgotten. So that's why we use the option parser. So I'm not going to use all of these arguments. I'm just going to use a few. So I'm going to say something like usage, and then %prog, and of course I'm going to concatenate this with -f, and then our zip file name, right? So it goes in the greater than or less than sign. It's called zip file, and then our dictionary file is also required. So I'm going to go ahead and say -d for dictionary, and then it's spelled dictionary.t, well, not txt, just dictionary is fine because we don't know at this point. All right, let's close the parentheses. Next, I'm going to go ahead and say parser dot add option, and then use the -f, comma, and I'm going to go ahead and do some variable dest, for example. I'm going to say zname, comma, and then type is going to be equal to the string, and just enter a new line. I'm going to call it help would equal specify zip file. So that's one of the add options for the zip file. And of course I'm going to also have to add the add option, parser.add option, for the dictionary file. So I'm just going to go ahead and save some time and copy this and paste it, and everything else stays the same except the -f changes to -d because that's what we use for dictionary, and then this changes to dname instead of zname. Type is string, which is fine, and then we are going to specify the dictionary file instead of the zip file. Okay, great. So you follow along. It's just the same thing. I just copied it and also specified the dictionary details in addition to the zip file. All right, so once we're done with this part, next I'm going to go ahead and assign, let's say, option, or options rather, with an S, and our arguments goes, and this would equal the parser dot parse underscore args and the method. Great. All right, once we have this, next I'm going to do a loop, right? So I'm going to do a conditional statement here. So I'm going to say something like if options dot zname equals none, then also go ahead and add options dot dname for the dictionary also, right? Because we have two things going on here. This also equals none. Put a colon. All right, next let's do a loop. So first I'm going to say print, or a conditional statement rather, parser dot usage, else the zip file name or zname should equal options dot zname, and our dname for the dictionary should equals options dot dname. So this is again part of our main function. That's what's happening here. So next I'm going to go ahead and do z file equals zip file dot zip file, and then of course the zname. And next I'm going to go ahead and do the pass file equals open, and then our dictionary. Okay, so that's how it's going to match it up. And then do our for line in pass file, because it's going to run line by line. It's going to check one password. If it doesn't find it, it's going to move to the next one. And then if that's not correct either, it's going to move to the third one, and so on. So it's going to continue on till it finds the password for the locked zip file. And that's what we're essentially doing here for the line, for line in pass file. So go ahead and read lines, right? That's exactly what it should do. And then password equals line dot strip, and then I'm just going to use the n here for the line, and then our threads, right? So I'm going to say t equals thread, and our target would equal extract underscore the zip file, and then args would equal the z file comma the password, and then we are going to tell Python to start, right? To start the threading. So once we're done, then we need our main function. So I'm going to say if, enter a line here, name equals our main, call the main function. Awesome. So you see what's happening here, right? Simple program, simple logic. We need to open up our zip file. We don't know the password. We need to find the password. We need Python to go and look up the dictionary.txt file, loop around each of the passwords, match it up with the lock.zip file, and then see if it finds it. And if it finds it, it's going to unlock it and show me the contents. Okay, perfect. Let me go ahead and save this, and I'm going to call it, let's say, openzip.py. Go ahead and save it in the test folder so everything stays in one place. Click save. Great. Let me minimize this. So here's our openzip.py, and of course our two files still exist within the test folder. Let's go ahead and execute the Python folder and unlock the zip file. So let me go ahead and open the terminal here. Since we're using Kali Linux, you need to be comfortable with the terminal. Great. Do the ls, and we have our openzip.py. Let me run it. Python openzip.py. Great. So this time it asks for the arguments, right? And it asks us the name for the zip file that we want to crack open, and of course along with that we also need to supply the dictionary. So here I'm going to go ahead and say Python openzip.py, and then -f with the name of the file. In this instance it's up here, right? So it's locked.zip. So locked.zip, and then of course our dictionary and this name would be dictionary.txt, which is right here. Great, let's enter. And excellent. So it found the password called login, right? So this is the correct password for the zip file. And notice what it did was that it also populated and extracted the picture. In other words, the contents of the locked zip file. So if I were to, let's say, open the JPEG image, it'll say, congrats, you cracked the zip. Okay, so this way you can simply open up a locked zip file using a simple Python program. So for example, if I were to, let's say, click on the locked zip this time and try to open it, asks me for the password, and the password found was login. Enter. Perfect. It displays the picture. So I hope this helps. Practice, and let's move to the next. In this lesson, I'm going to demonstrate the importance and working with establishing and building or creating a TCP client using sockets in Python. And this is useful when you work with the Kali Linux or within the penetration testing environment. It's important to know the concepts of how client interacts with the server and eventually how the server responds and interacts with the client. So in this lesson, I'm just going to focus on the creation of sockets and building a client, and then of course testing the port as well. So, and we'll be using the local host, and I'm using the Sublime text editor that we've been using in the earlier lessons within this course, and you can use this and apply or use the editor within Kali Linux as well. So it's one of the same things. The important thing is that you need to understand how sockets work, how does the bind and listen, and how everything works within Python. So let's begin. First, I'm going to import the socket library. Let me put a comment here. So first, we are going to import the socket library. Let me go ahead and save this. So do a Control S, and I'm going to call it 5.py, and maybe reference also to say Kali so we remember. Perfect. So let me put a comment here. So I forgot the number sign. There we go. All right. So go ahead and do import socket, and next we create an object, right? So we create an object for this particular socket. So next we create a socket object, and then do a print socket successfully created. All right, so pretty straightforward. Import socket, print out a statement, and then I'm going to reserve a port or assign a port, and this is going to be, let's say, port equals 1979, and I'm going to go ahead next and do the bind to the port using the s.bind, and then I need, let's say, comma, and then the port, and of course I also need the print here, and this is going to say socket binded to, and then the %s, and then to the port as well with the %sign. Great. So once the socket is bounded to the actual port, in our instance is 1979, next we need to simply put the socket into the listening mode. So let me just write the comment here, listening mode, and this will be s.listen 5, and then of course we need the print as well. So in this instance I'm going to say socket is now listening, and then we need a loop, right? So this loop is going to run until we exit, or we specify, or we end the program. Otherwise it's going to keep listening. The port is going to bind itself to 1979 and it's going to keep listening. So the client is going to be ready as long as anything that comes within its way is going to keep listening. So any server, for example, or any other machine that wants to connect to port 1979, it's going to stay open until we close it. We are going to put a comment here, a forever loop until we exit, and simply do a while loop here. So while true, and I'm going to go ahead and do the establish connection with this client, right? So let me put a comment here, establish connection with the client, and then do the C comma the ADDR. This is going to equal to the s.accept because it needs to accept the connection. That's the method. And then finally, let's go ahead and do the print, and we are going to say got connection from, and then whichever address, right? And this goes within the quotations. Perfect. All right, so simple program, right? So we are going to just open up a port, create a client who is going to listen on port 1979 and is going to keep listening until we close or exit the program. So let me go ahead and save this and build this. Okay, line 25. Okay, I have an extra set of quotations which I don't need. Save it again, build it. In line 13, the S bind is not defined. All right. So we use the bind method to the port, but we never created our object. Wow, great. All right, let's do this. So let me fix up the comment here quick. So here's where we need a variable. So S is going to equal to socket dot socket method. Perfect. All right, now we have our object. See, if you don't have the object, it's not going to find it. Save it, run it. Great. So it says socket successfully created. It's binded to 1979, and the socket is now listening. And let me go ahead and just fix up the quick spellings here. Great. All right. So since I fixed up the spelling and I ran it again, it says, well, wait a minute here. The port was already open, right? So only one usage of each socket address is now normally permitted. So no problem. We'll just change this. 1979, so it'll be 1989. How's that? Save it, run it. Perfect. So now socket successfully created. It's now binded to port 1989 and is now listening. All right. So our client is now active. All right. Let me go ahead and test it. So let me go ahead and open our browser here, and let me connect to localhost, and then port number was 1989. Now, as soon as I hit enter, right, or try to connect to this client, nothing's going to happen here. It's not going to connect because all we did was we opened up a socket and assigned the port number. However, when I go back to my editor, notice something on the bottom. It says got connection from our local host, which is 127.0.0.1. So this means that we have successfully created a client who's actively listening on this port, and any time a packet comes across to this port, and it displays as the result. So this is a very good way of the penetration testing environment, where you can just open up a port and just keep listening, right? You are on the lookout, for example, of potential threats from outside attackers or something like that. Okay, so that way it's easier to create a client and make sure you are listening to this port that you just opened up, and it's going to keep open until you close it. So just a quick rundown on establishing a client using Python. So I hope this helps practice, and let's move to the next. Welcome back. In this lesson I'm going to talk about how to set up a server. So in the previous lesson we took a look at how to create a client, right? In this lesson moving forward, let's take a look at how we establish or create a server, and then how does the server functions and when we test it. So let's go ahead, and first let me in fact write a comment here. So the web server, that's what we're looking at. Let me go ahead and save the file here. So I'm going to call this file server cali.py. Perfect. Let's begin by importing the socket, and next we just simply define the host and then the port. Okay, so let's go ahead and do the host here, then our port number, and this would equal, let's say, I'm just going to give it a port 8888 for 8s. And right after this is basically setting up the port number, host and the port. So if I'm using my local host, then I'll just use localhost and then the colon and then connect to the port, and it will open up a web page, right? Because this is the server. So let's go ahead and next do the listen for the sockets here, and this is going to be socket dot our socket again, and then we specify the parameters or arguments. So socket.af underscore inet, and then to the socket dot bind it to this socket stream. Now once we've done this, next we need to also create, let's say, the set socket or the reuse address. So let's go ahead, let's do listen socket, and here I'm going to set this up. So set socket, or instead of set socket, and let's continue with our sol underscore socket, comma, to the so, and then our reuse address. Perfect. Next we need to bind it. So let's do the listen socket dot bind, and of course we need to bind it to the host, right? So we are going to say host and of course the port as well, and I need the host and the port in its own parentheses, and of course our last listen for the socket will be for the 1. Alright, so next simply do a print, because we need some kind of a message, right, that it is serving HTTP on port, and then of course it's going to display the port number with the port itself. And once this is established or created, next we do a while true, just like we did with the client earlier, and this is going to be for the client connection and then the client address, and this is going to listen to this socket, right, and it's going to accept once the client tries to connect to it, it's going to accept the connection. So we're going to say listen socket dot accept, that's a method, and then of course our request variable is going to be client connection, and this is going to be the receive, recv, and then the 1024, and do the print the request for decoding, and then we can use the UTF-8, UTF-9 and other formats as well. So the common one is of course decode into the UTF. Almost all websites use this. So once we have specified this, then we need the response. So we'll say something like HTTP response would equal, and I'm just going to do a new line here, HTTP, and then let's say 1.1 and just an OK message, right, 200 OK, and then here's where my message goes on, which is in fact going to be displayed on the actual web page or the site once we connect to it. So let's say hello world, this is awesome, and our comment, and next we do the client connection. This is one of the last things, right? We need to send the HTTP response with the format to the client connection, and then of course close it as well. So send all and our bytes HTTP with the response and our format, which is again was UTF-8, and next we are going to do client connection dot close, and that's a method. Great. So this is basically how we set up our web server. Let me go ahead and in fact save this and build it. And of course we need to fix up our line 18 because this is in fact HTTP response. Let's try again, save and build, and this time we get something in line 7, and let's check that out. And of course we need the SOL socket to be in all caps because otherwise it doesn't really know what to do. Let's try it again. Great. So now we get a message that says serving HTTP on port 8888 because that's the port that we assigned. Let's test it out and see how it's going to look like when we actually use our browser. So I'm going to go ahead and open this up and just type localhost equals, and our port is 8888. Enter. Let's try again. Localhost. Great. So we get our message that says hello world. This is awesome. So this is a nice way to set up a server, and then of course already looked at how to set up a client. So this is another important area within socket programming. Just a brief overview or a high-level overview at this point in this course so that you get comfortable with the application of sockets for both the server and the client as well. So practice, and let's move to the in this lesson. I'm going to demonstrate how to read the binary raw packets. In other words, create a simple sniffer tool, right? That's going to go ahead and open up our raw sockets and then read from there. So let's go ahead and first open up our editor. So let's go ahead and click on the Wing IDE Professional for Python developers. Now once the editor is open, I'm just going to go ahead and write a simple program that's going to read the packets from our local host or any other site. Let's go ahead and click continue working. Great, let me maximize this. Let's go ahead and create a new file. Alright, so the first thing first, let's go ahead and do the import our socket here, the module. And next I'm going to create the raw packet object. Okay, so put a comment here, raw packet object, and that is going to be our sniffer basically, right? Next, let's do the sniffer equals socket dot socket again, and then of course we have our AFINET comma, and then of course our socket dot raw. So here is where I define the type, right? So I'm going to say raw packets, and then what kind or where to get them from. So I can say something like socket dot to, and then whether I want ICMP packets, TCP, it's up to me. So I'm going to use ICMP. So once we've created a variable for sniffer and told the sniffer to catch all the packets, all the ICMP related packets, right? Next we're going to bind. So bind it to a host. Now this could be a local host or whichever host you want to bind it to. So I'm going to say sniffer dot bind, and then my URL goes here. So for now let's say 0.0.0, and we go ahead and place this in a quotation, and then of course 0. Perfect. Alright, so once we bind it, next we need to make sure that the IP header is also included within the packets, right? So put a comment here quick, make sure that IP header is included also. Alright, so this is going to be sniffer dot set socket, and then I'm going to go ahead and say socket dot, and where is it? Up here, one IPPROTO, and this is for the IP, comma, and I'm going to say socket dot IP underscore HDR included, right? INCL, comma 1. So once that's done, simply go ahead and do a print. And for the print, I'm going to say sniffer is listening for incoming connections. and then of course finally do the get a single packet, and that's what we need to say is to print and tell the sniffer to get those packets, right? So something like comment here, get a single packet, and let's go ahead and do a print sniffer.recv from and receive from, let's say 535. Great. Let's save this. Go ahead and do the save here, and we are going to call it raw binary .py. I'm going to save it in the test folder. Click save. Great. So let's go ahead and execute this. So let's go to debug and make sure I set this as the main debug file, and go ahead and start and continue. Click OK. Alright, so attribute error, it says has no attribute called set socket, and the reason why is because we need to say opt, set sock and then opt. Great. Let's try it again. Save it. Perfect. So now it runs. So all these connections that are coming from this host are now being recorded, right? And that's exactly what we created in this basic program, where we imported our socket module, then we created a raw object called sniffer, we bound it to a host, and then we included the HP header, or the IP header rather, and then we printed and get a single packet from or receive from, and we printed that out as well. So let me in fact make this smaller here, bring up my terminal. Alright, so once we have it, let's test it out and see whether our code is correct and how does it really find the raw packets. So I'm going to go ahead and open up the terminal here, move this in the center. So within my terminal, let me go ahead and just do an ls find out, and let's do cd to test, ls again. Alright, perfect. So we have the raw binary.py file, right? And that's the exact same file that we just created containing the Python code. So, and it's stored in the test folder called raw binary.py. I'm going to run this file. So I'm going to say Python raw binary.py. And of course it works, and it says sniffer is listening for incoming connections. Okay, so it's active, it's waiting. Alright, so let's test it. Let me go ahead and open another terminal window here. Move this a little bit down here so you can actually see. Perfect. So now if I try to, let's say, do something like ping, and let's say a site called google.com. And notice in the background here, smaller, it finds and it listens for the incoming connection. As soon as it finds it, it outputs the raw binary data. So that way, it tells you the URL or the IP address as well, the 173.194.124 and 38. And of course, everything is binary. And you can, of course, work with the binary raw data and then convert it to your own requirements. So in this lesson, I just want to demonstrate how to create a simple raw binary data sniff tool using Python. So I hope this helps practice, and let's move to the next lesson. In this lesson, I'm going to demonstrate the nmap within Python. So what is really nmap? Nmap is basically the network mapper. So if you have ever wondered how attackers know what ports are open on a system, or how to find out what services on a computer are running without just asking the site admin, you can do all of this with this wonderful tool called the nmap. And nmap is short for, again, network mapper, and it is a toolshed of functionality to perform various network scans. So it can be used for security scans, simply to identify what services a host is running, to basically fingerprint the operating system and applications on a host, or the type of firewall a host is using, or to do simply a quick inventory of your local network. So in short, it's a very powerful and a good tool to use and know. So I'm going to go ahead and demonstrate the Nmap tool within Python, and this is basically an open source utility for the network discovery and security auditing, right? So let's put it this way. So for your vulnerability analysis, you can use this tool, and of course we will be using Python to do this. So I'm going to go ahead and open up our shell just to see and walk you through some of the basic concepts as to how to download and install if it's not already installed. So we are going to go ahead and run the sudo. Let me first do the ls here, and I'm going to go to my test directory. So here I'm going to say sudo apt get and then install nmap, and it's going to make sure it installs the most current version of nmap. Perfect. So once the nmap is installed, and notice it's the 7.25 version, which is the beta 1 version, the most current one, has been installed. So next, let's go ahead and also install a package called Python setup tools that we'll also use along with this. So let's do sudo apt get and use the install again, and this time we're going to install python setup tools. Let's get that going. So it asks, do you want to continue? And we're going to say yes. Now once that's done, we are going to use the setup tools and install the Python nmap from those setup tools. So let's do sudo easy install and then python nmap. Let's do the ls. Great. Let's clear this out. Let's go to our Python. Alright, let's do import nmap. Great. So it's installed, otherwise it will give you an error saying there's no module called nmap. Alright, great. So it seems like the module nmap is installed. If not, this would probably give you an error at this time. So let's next go ahead and let me write a program in Python to demonstrate some of the techniques using nmap. So I'm going to go ahead and open up our Wing ID Professional. Great. So once that's open, I'm going to go ahead and click or create a new file. So first, let's go ahead and do the import of modules called opt-parse, and then we are going to import the nmap. Start off with our definition. We are going to use the nmap scan, and then of course our target host, and then the port, right? So that's TGT host, and then our TGT port. Define some variables such as nscan equals nmap dot port scanner. That's a method. Get rid of this. Then nscan would equal, or rather nscan dot scan. It's going to do the scan for the TGT host and port. Next, I'm going to define the state as a variable and call it nscan. And of course, first our host and then the type of protocol. So I'm going to say it's TCP, and then use the int to get our target port, and then of course our state as well. Great. Simply do a print here, put an asterisk, concatenate with the TGT host, and then of course with our TCP as well, and of course we cannot forget our TGT port plus sign, and then the state variable. So this is the def for the nmap scan. Next comes our main function. So def main, and this is where the opt parse comes into play. So we are going to say parser equals opt parse dot option parser, and then the usage is going to ask us this, right? Prog, maybe a new line here, or I can use the same line. Use the -h target host, and then -p for the target port. And then we need the parser for the adding the host, and then parser for adding the port as well. So it'll be parser.add option, and then we're going to say -h comma the destination equals tgt host. Define the type, which is going to be string, comma, and then let's do help equals specify target host. And next we're going to do the same thing, the parser.add option for the target port instead of the host. So I'm just going to copy this and paste it, and then of course make the appropriate changes. So this is going to be parser.add underscore option, and in this instance it's going to be -p first, and the destination is the target port, type is going to be string, and then help is going to be specify target port or ports, specify target, get rid of the host here, port or ports, and I'm going to say separated by comma, get rid of this, perfect. I'm going to say options, and then arguments, and this is going to equal parser.parse underscore args method. Let's do the if condition. So if option dot tgt host equals none, and same thing for the port. So options dot tgt port equals none, simply do a print parser dot usage and then exit. Alright, so this is the first part of the if condition. Else tgt host equals options dot tgt host, and same thing for the port. So tgt ports would equal our string options dot tgt port, and we're going to split that. We're going to say comma, perfect. Next, let's do a for tgt host, or rather port here, in tgt ports. Let's do the nmap scan tgt host and tgt port. And finally, let's do if name equals our main, and we call our main function. Great. So a simple Python program using the nmap. Let me fix up some of the spelling errors. So it's usage. And let's browse through our code, make sure everything is okay. Let me go ahead and save this. I'm going to save it in the test folder. And I'm going to call this nmap scanner.py. Great. So let's navigate to our terminal here, and let me exit out of here, do the ls, so we make sure we have our nmap scanner. So let's do python nmap scanner.py. Alright, let's take a look at line 11. The option parser, just a simple spelling error. Here we go. Let's save this. Let's go ahead and execute again. Nmap scanner. And line 26, another spell errors, 2 R's. Let's fix this quick, delete one of them. Same thing with this. Just some typos, okay? So let's save it again. Run it. Alright, so in this case, this is option, and here is options, so it's with an S. So let's fix that also. Here we go. Save it again. Let's execute one more time. And another print parser usage. So too many R's. Alright, so just going back and forth with our code and making sure we have the code correct. Okay, so let's run it again. Perfect. So this time it provides and asks for, alright, tell me the target host that you want to scan and the target port that you want to scan as well. So now I'm just going to go ahead and let's test it out with our target host and target port. So let's do Python nmap scanner.py and then the H, and then the target host is, let's say, our own host, which is 127.0.0.1, and then minus P, which is the port, and I'm going to say it's 80. So let's take a look. Let's do Python nmap scanner.py. Let's do 192.168.10.1 and then port 80. Let's do the minus H here. And it says the main TGD port. Let's fix that. So we have, it's not a comma, so this has to be a dot, right? All right, there's our error. So we finally found it. All right, so this is going to be dot split. Perfect. Let's save it again. Let's clear this out. So let's run Python nmap scanner.py. Make sure it's working. Great. Let's now specify the host and our port. So nmap scanner.py and then our port 127.0.0.1 and then our port 80. All right, let's try nmap scan in line 6 and line 23. And of course, instead of a comma here, this has to be a dot also. Let's scroll up. There we go. There's too many errors, guys, so not to worry. That's how it works when you're programming with Python. Alright, so everything seems to be fixed. So let's save this. I'm going to run it again. First, my nmap scanner.py, and then let's try our host. And finally, perfect. So it says 127.0.0 TCP port 80 is closed. So this way you can test out with various host names and ports, and just to see while conducting your vulnerability analysis on your network whether any of these ports are open or closed based on the IP address. So I hope this helps. Practice creating small Python programs using the powerful nmap scanner just to seek any open ports on your network and to find out whether certain ports or IP addresses are working or not within your network. So I hope this helps. Practice, and let's move to the next lesson. Welcome back. In this lesson, moving forward, I'm going to demonstrate how to actually go ahead and create a sniffer, our own sniffer using Python. We've been using off and on other lessons. We've been working with tools like PortScan and working with other tools. This is very important because this allows you to actually sniff all the packets either coming in or going out, so that you can analyze them for your own purposes. And this is a great tool for network administrators and penetration testers to in fact create their own sniffers based on your own requirements. So I'm going to go ahead and first show you a simple sniffer that's going to sniff everything, right? And then I'm going to build on that and actually create our own customized program using Python, so that we're able to sniff maybe just the MAC addresses, or let's say the source and the destination IP addresses. So let's go ahead, and first I'm going to go ahead and in fact open up our editor, which is the Python IDE. Great. Let's go ahead and create a new file here. So let's begin. First I'm going to create in fact two programs, right? So first just a basic sniffer so that you can actually see what that looks like. So the first program is just going to be something like, let me put a comment here. So packet sniffer in Python. Let me go ahead and save this test folder, and we are going to call it calisniff.py. All right. So next I'm going to go ahead and do import socket, and I'm simply going to go ahead and create an inet basically, and then raw packet. Okay, so that's all we're going to do here in this simple program. So start off with a variable s equals socket dot socket, and then go ahead and do the inet with socket here again, and this is af underscore inet, and then of course our socket, and then the raw that we're interested in, right? So this will be sock dot or underscore raw, and then maybe we're going to use what type. We are interested in TCP only, so I'm going to say socket dot underscore and then TCP. Okay, so and next of course let me put a comment here first. So receive a packet, and just a while true, and I'm going to go ahead and do the print. So print s dot receive from, and I'm going to use 6, let's say 5565. Great. So this is it, just a simple first sniffer, so you can actually see, and then we'll build our own tool, customized tool, so that we can capture maybe MAC addresses or whatever. Okay, so let me go ahead and save this, and let's execute this. Bring up our terminal. It's always a good idea to do the debug. By the way, I didn't do this debug. I'm directly going to go to my terminal and run the program. So let me navigate to my test folder here first, and let's do sudo. Sudo is for the admin privileges, by the way. Okay, if you don't do sudo, sometimes it's not going to run because of the firewalls in place. So we are going to do sudo and then Python, and then the name, which is calisniff.py. All right, hit enter. Let me bring up my browser so you can actually see now. Move these two windows so it's easier for you to see. Perfect. Now I'm going to navigate to a new website simply, and let's see what happens. So open a new tab and just pick a site. As soon as I open a new tab, notice it starts to capture and sniff all the packets. Now these are various packets, right? So if I open up more sites, for example, if I go to WingWare, Python IDE, it's going to keep capturing. It's going to capture everything. Okay, so let me bring this up here, and in order for me to stop this, I'm going to do a break here. So let's do Control C to interrupt, and let's take a look. So let me maximize this. So what's going on here? Notice it's capturing all the IP addresses, the hexadecimal values, different IP addresses from different sites that I've been visiting, right? So as I open different sites, it just captures all packets and starts to receive, because in our code. Let's go ahead and next let me show you in fact how to go about customizing our tool. Okay, so let's maximize our editor here. I'm going to open up a new file. So here we're going to actually go ahead and take a step further. Okay, So I'm going to start off with a comment. So packet sniffer in Python, our own version. All right, let's begin. So let's do import socket, and then I'm also going to import sys, and then the module called struct import everything. Now next I'm going to go ahead and convert a string of characters of Ethernet. Okay, and this Ethernet address basically I'm going to convert into a dash separated hex string. Now you need to have a little bit of background on the little endian and then the big endian values and then the byte order of things. Okay, so, and it's helpful, you can always take a look and learn about it. For our purposes in this lesson, I'm going to stick to our Python code as well. But just briefly, what is the endian format? Okay, so the big endian and the little endian are terms that simply describe the order in which a sequence of bytes are stored in the computer memory. Okay, so just so you know what these terms are when I say these terms. And they not only describe the order, but they also describe the order in which a sequence of bytes are stored within the computer memory. So for example, the big endian is an order in which the big end, most significant value in the sequence, for example, is stored first at the lowest storage address. On the other hand, the little end, or the least significant value in the sequence, is stored first. Okay, so you get the general idea and the gist of what the byte order is, and of course you can always reference that as well. But here I'm going to stick to the actual code. Alright, so now we understand, so I'm going to go ahead and simply do a comment here. I'm going to do the conversion here first. So convert a string of, let's say, 6 characters of Ethernet, and you'll see this in the output when we actually finish and run the program. And Ethernet address into a dash separated hex string. I put 2 comments so that you can see it in one screen. Alright, so let's start with a definition here. Def ethaddr, and then I'm going to say a. Alright, get a variable in here. So b is going to equal to, let's say, the %, 0.2x, and then the % again, 0.2x. I'm going to repeat this about 6 times. Okay, so the easiest way is to just copy it and then paste it again. Alright, so how many times is 1, 2, 3, 4, 5, and we have 6. Great. So next I'm going to go ahead and do the % and then our order. So ord a is going to start at 0, and then comma a1, right? That's a, and then of course our 1 goes in here. Similarly, place a comma, and then we need, of course, our a2, a3, a4, and a5, because the 0 counts as a value as well, so there'll be 6 of them, right? So let me go ahead and just copy this, and then we'll populate this. Copy. Alright, great. Let me paste it again. So we have the order of A0, A1, and then this is going to be A2. Of course, next is A3, A4, and the last one would be A5. So again, that's basically starting 1, 2, 3, 4, 5, and then of course our 6. Great, let me fix the syntax here. Perfect. So once we have this, next I'm just going to go ahead and do return B. Alright, next comes our packets and the AF packet, the raw socket, and that's what we need to specify. Okay, so next, just put a quick comment here, create a AF packet type for the raw socket, and that's basically at the packet level. That's what we're doing here. So let's go ahead and do try s equals socket.socket, and then we have our AF underscore packet comma, and then we have our raw socket, right? So it's sock.sock raw comma, and then of course our socket for the socket dot nt, I believe OHS, and then 0 times 0, 0, 0, and then let's say 3. Great. So we started off with our socket and then raw socket, and then we are going to say except socket dot error, and of course we need to print something, right? So if an error happens, we need to do a message and then do print socket could not be created and give us the error code, something like that. All right, so we have this, and we're going to concatenate this with the string for the message at the first level, which is 0, plus the actual message plus MSG for the 1. Great. All right, doing good so far. So we have this, and next we simply need to tell Python to receive a packet, and then we're done, right? So I'm going to go ahead and say first a comment here, so receive a packet. And of course we can build this, right? You can add your packet receive like TCP, UDP, ICMP, and so on. Okay, so I'm just going to keep things simple here so you get a solid concept across. So I'm going to say while true, and then of course our packet equals s.receive from 655, and it was 65. Great. All right, that's all. So of course we can build more. Let me fix up the spelling of true here. Perfect. All right, so here's our simple sniffer version, and what this is going to do is first convert and then of course run the program and get us the sockets that we're looking for, or the packets that we're looking for. Okay, so let's go ahead and finish this off, because once we have the while loop, we also need one more thing, right? Otherwise it's an incomplete program. So we need to parse as well. So, and what are we parsing here? We are going to parse the Ethernet address. Okay, specify the length, and then we can print the destination MAC address and so on. So it's a good idea to do this because we want to be able to see that as well. So once we've done with this, let me put a comment here. So packet string from our tuple, and let's do packet equals packet 0. Go ahead and also move this indentation. Perfect. All right, so next we're going to parse it. So parse Ethernet header, and ETH, the length would be, let's say 14. Scroll down. So I'm going to say Ethernet header would equal the packet, ETH, the length. We don't need quotations. In fact, a colon. Next, we're going to say ETH equals unpack, and then we are going to say exclamation mark 6s and then 6sh, ETH, and then our header. Next is of course our protocol. So ETH protocol, and this would equal the socket.nt. I believe it was OHS, right? So yeah, so it's NTOHS and then ETH2, and then finally we do the print our destination MAC address. Fix that. So let's do the print destination MAC, and then we need our Ethernet address packets, right? So I'm going to say ETH address ADDR, and then of course our packet, and open up our brackets and use 0 all the way up to 6. That's what I'm looking for. And finally do the plus with the source MAC address, right? So we're not just doing the destination, we're also interested in capturing the source MAC address as well. So let's go ahead and do source MAC and then define the ETH ADDR packet. It's the same thing for this. Make sure we stay on the same line, and this is going to be from packet. Well, the first one was from 0 to 6 for the destination MAC, and this one is going to be from 6 onwards to 12. So I'm going to say 6 to 12, and then finally a protocol. We need to concatenate this with our protocol colon, and then use our string str for the ETH protocol. Great, I think that'd be done. All right, ETH underscore protocol. All right, so we have our own program here that is going to first convert a string of 6 characters of Ethernet address from both the source and destination. We got our definition, and then we did the raw socket capture, and of course with the while it's going to bring in all the packets, including the source and the destination MAC addresses, with the length of being 14 as parsing the Ethernet header. Great, let's go ahead and debug first before we actually start run it. So set current as main debug file, start continue, click OK, and of course we need to save first. We haven't saved it yet, so we are going to call it our sniffer.py, or rather say our final sniffer.py. Make sure we save it in our test folder, click save. Alright, so it found something, so we need to fix that. Alright, so what's happening here is that we did the message and then the print, but we never did the sysexit. So let's go ahead and do the sys.exit. Alright, great. Now we can move on to the next one, which is receive a packet. Try again. So I'm going to go ahead and save this. Click on debug, start and continue. And it looks alright. Great, perfect. And let's run this program and see the output. So let me bring up my shell here, and let's clear out of here. Do the ls, make sure we have our file, which is our final sniffer.py. So let's go ahead and execute this. So sudo python our final sniffer.py. Alright, line 16. Let's check that out. Alright, so we need to fix this up. It should say socket, not just sock here. So socket.sock raw, which is fine. And then of course we have our NTOHS. Great, so let's save this again. Go back to our terminal. Let's try it again. Alright, line 23, s received from, just some syntax errors, guys. We can always fix those as we go along. And this is great learning also, by the way. Alright, so packet is our S receive, not the full word, actually it's RECV, and then from. Great, save this, go back to our terminal, let's execute again, and great, looks like it's working. So to test it, I'm going to go ahead and open up our browser. It's here somewhere, minimize this, there we go. So let's go ahead and let me go ahead and open a new, how about Kali Docs? I'm going to go ahead and open up other ones as well, Kali Linux, and so on. And notice what's happening is we're only capturing our destination MAC addresses, which is right here, and then of course our source addresses as well. Awesome tool, powerful tool. You can customize it based on your own requirements. So if you are a penetration tester for your own network, this is a great tool which you can use. So practice with this. I hope this helps, and let's move to the next lesson. Welcome back. In this lesson, moving forward, I'm going to demonstrate how to write a Python program and then use a tool called SQL map, right? Or SQL injection technique using Python. So essentially what SQL injection is, that we want to be able to test vulnerabilities as penetration testers on the backend databases of the web server, for example. So let's say you have the PHP MyAdmin database running or SQL server running, and you would like to check certain vulnerabilities within that database. So the SQL map, for example, is a tool which allows you to do that, and that lists the various databases and tables and so on. So I'm going to demonstrate in this lesson how to write Python. First, we'll set up a web server, because obviously we can't really go out there and test a live web server that belongs to someone else, because that's not right or illegal, right? So as ethical hackers, what we're going to do is I'm going to first set up a web server using Python, and then we'll use the SQL map tool to test for vulnerabilities. Okay, so the important objective and the goal of this lesson is to understand how to write a Python program, setting up a web server, and then testing it for SQL injection. Great, so let's begin. Here I have the default IDE open, or the Wing IDE open for Python. So I'm going to go ahead and start my program. And first I'm just going to write the comment. So let's go ahead and let's do, this is a simple web server which is vulnerable to SQL injection. Okay, so I'm just gonna write this comment so we can actually see. And what I'm going to do is I'm going to set up, let's say, my local host, right? So I'm going to give a URL and then open up a port and then finally run the server on that port. So let's go ahead and do SQL injection, and then I'm going to say make your query string, and then I'm going to just type in the comment here. It's going to be 127.0.0.1, which is my local host, and let's say I'm just going to use a port number, say 8090, okay, just for testing purposes. And then let me in fact move to the next line. All right, so once I have the URL and I have the port number, I also need to do, let's say, the time and then the row, and we'll use this row 1, for example. I'm going to equal this row to 1 to test for our injection. Okay, and I'm going to keep it so it does not allow SQL injection, but when I run it, I'm going to go over the code. And then row is 1, and then I'm going to use the and character index is going to be equal to 1. So this is basically our URL, right? Well, the URL is going to end from, let's say, up till here, 1. So the part that I just highlighted, right, that's what we're looking for when we use the SQL injection technique. but I'm going to write the entire URL just for sake of ease. So after 1, I'm going to have my character value equals, let's say, 95, and comparator equals greater than and sleep equals 1. Okay, so just some comment here so it's easier for us to see. Let me fix up the spellings here for the word value. Great. So let me in fact make this bigger. Perfect. So once we have the comment, next I'm going to go ahead and start the actual program, right? So let's go ahead and import some modules. So first I'm going to use event let, and next I'm going to use from event let import the WSGI. This is going to be for the web server, and then from event let dot green import the time, and then of course for URL parse import the parse underscore QS. One more module, which is our URL library 2. Great. So once we're done importing our basic modules that are required for us to create the web server and then actually test it, I'm going to go ahead and next, right down here, put a comment here. So next are my database constants. So my data s, for example, equals hello world, or hello comma, and then world. And then I'm also going to use, let's say, different comparators for the BBSQL uses, right? So let's quickly put a comment. So different comparators, and then BBSQL uses. And I'm just going to list out these various operators or comparators, right? So I'm going to say comparators equals, and then bracket, you can use, let's say, the greater than sign. You can use the equals, and then comma, you can use the less than sign. That's a comma, by the way, it's a quotations, less than. And then also after comma, I'm going to say false. So once we're done with this, then we get into our definitions, right? So I'm going to go ahead and let's scroll down and start with our definition. So let's go ahead, let's do def parse for the response and set the environment, right? So that's env, comma, and then start the response, colon, and next I'm going to parse out all necessary information and then determine if the query resulted in a match or not. Okay, so that's my next goal here. So I'm going to go ahead and do try. So right after try, I'm going to go ahead and do params, for example, and use our parse underscore QS, open the parentheses, refer to our module here, urllib2 dot unquote, and then use my env, specify the query string. So it'll be query in caps and then our string. Perfect. So right after this, I'm going to have to now extract out all of the SQLi information. Okay, so like my row indexes, my character indexes, test character, and so on. Okay, So let's go ahead and let me in fact place a comment here first. So extract out all of the SQLi info. Okay, so just a quick comment. Next, I'm going to go ahead and do the row index, and this is going to be an integer. So params or primes, and then I'm going to specify the row index within the brackets. Use the pop method 0, and then this is going to actually be -1, right? So I'm going to subtract 1 from here. My next variable is going to be character or char index, and this is going to equal again the int. And by the way, the row is not going to have -1, right? Not the row. In fact, this is going to come at the character index part. Okay, so not with the row. Row is just 0, so we're going to start with that part. So I'm going to get rid of this for now, and let's get with our character index. So this is int, and then params, specify the character underscore index, same thing, pop 0, and here I'm going to say it's going to be -1. Okay, great. Next is my test underscore char, and this is going to be equal to int, just repeating the same steps as above, params, and then I'm going to use, let's say, the character value here, character underscore value, and also use the same. So I'm going to use, let's say, .pop and then 0. So I also need now the comparator, right? So comparator equals comparators dot index, and next I'm going to say params and then specify the comparator with .pop at 0. In here I also need to make sure I use the -1. Perfect, because it goes with the character index and with the comparator as well. And finally, one more that I need to extract out all of the SQL is the sleep int, and this is going to be int params, specify sleep, and then .pop at 0. Now, by the way, when we're working with Python programs and trying to write this from scratch, it makes a little more sense as compared to using just a standard tool for the SQL injection. This way you can customize it according to your own needs as we move forward. So once I'm done with this, next part is to determine which character position we are at during the injection. Okay, so we need to specify that as well. So let's go ahead and let me put a comment. So next, determine which character position we are at during injection. Okay, so this is going to be our current character, and then I'm going to go ahead and say equals my data s with the row index, so row underscore index, and I also need the character index with this row. So let's go ahead and do character or just chr underscore index. So once I'm done with this part, right, next I need to be able to determine now which character position we are at during the injection. We're done with this part. Next, we're going to call the function. Okay, so let's go ahead and let me in fact put the comment here. So call the function for what path, right? or let's say what path was given based on the path provided. So to do this, I'm going to go ahead and do the response equals the types, use our env, and then specify the path info in caps underscore info, and then use the parameters like test character, current character, and then compare, and all of these, right? So all of the above that we actually used, we are going to specify within the path info here. So I'm going to go ahead and open the parentheses, and let's do test char comma current character, and then comma comparator. And I also need, let's say, the sleep int, or sleep underscore int rather, and then finally the start response. Close the parentheses, and then eventually do the return response. Make sure I have my except that start response with a bad request, right? So I need to specify this here. So it's 400 for the bad request, comma, brackets, and within parentheses, this can be for, let's say, the content dash type, and then my text plain. And this is also going to be inside the parentheses, not just the content type, but also the text plain as well. Great. So once I'm done with this, let me put an apostrophe or quotation single, close the parentheses, and I have one too many. Let me fix the syntax here. So let's get rid of this here, and I think we should be good because I opened the parentheses, and then we have the brackets, we have the content type. So next I'm going to go ahead and do simple return, and then returning an error if that happens. I'm going to use the R and then a new line. Alright, so we're done with our definition. Next definition is going to be for the time-based blind, right? So I'm going to go ahead and use def time-based blind and use the parameters like test underscore char comma current character comma my comparator, and then sleep int, and then the start underscore response. Make sure the spellings are correct. Great. And then colon, because I need to also use try here. So here I'm going to say, let's say truth equals CMP for the test underscore character, and then I need ORD for the current character underscore character, and I'm going to set this equal to my comparator. So at this point, the next step would be to basically do the query string and parse it into a dictionary, right? So that's what the idea here is at this point. So let's go ahead. Right after the comparator, let's do sleep underscore time and set this to be a float value for the sleep int, and then I'm going to go ahead and use the asterisk or multiply this with our truth. So next step is to do the time.sleep method. So this is going to contain, let's say, the sleep time, so underscore time, and then I'm going to start my response, so start response, and use 200 OK, comma, and then obviously the content type and text plain, right? Same thing as above. So I'm just going to go ahead and copy this from the top here. There's a syntax error. I'm going to fix it shortly. So after 200, comma, and then I also need a single quotation here. And fix the syntax up here and places single quotation. Perfect. All right. So far, so good. So once I specify the start response to be 200 OK, next I'm just going to do a return and then use the hello, for example, with an exclamation mark, \r, and then n as well, and that's for the new line. So except I'm going to go ahead and do start response, and this time this is going to be for the 400 bad request. So 400 bad request, comma, and then of course same thing, I'm just going to copy it from the top here and then paste it here. Okay. All right, let's go to the next line. Simply do a return, and I'm returning an error with \r and \n. All right, so moving on with our definition, next one is going to be for the Boolean based error, right? So Boolean underscore based and then error, and of course the same set of parameters. So I need, let's say, the test underscore char and then comma current character. Make sure my spellings are correct. Starts with a C. And I'm going to use, let's say, the comparator, comma, the env, and then start response underscore response, colon. And again, we're doing this for the Boolean, right? So let's go ahead and do try our truth equals CMP and then test underscore char, comma, ORD is going to be for the current character, and then this is going to equal to our comparator. And next, of course, the same thing. We're going to do the query string and parse it into a dictionary. Okay. So let's go ahead and let's do if truth, put a colon, start response. So here I'm going to check to see whether the start response is going to be, let's say, 200 OK, and then same parameters, content type and text plain, and then simply return some text. Hello, for example, in a bigger cheese is the cruel world, or any text that you like. Okay, so let's go ahead and do start response, open the parentheses, then 200 OK, and I'm just going to paste it again, the same content type and text plain, because I already had it copied from the top, by the way. So return, in this instance, I'm just going to say hello, we are doing great. Okay, so just some text here, and then of course with an R and with an N, new line. All right, and else, right, if that's the case, I'm going to go ahead and do else. Go ahead and do start response, and here I'm going to use the 404 file not found. We've come across this before, and now we're just programming. Great. And again, paste the same thing, content type and text plain. Go to the next line. Let's do a simple return open the brackets, not the curly braces, the brackets, and simply say file not found error /r and /n. And let's do except start underscore response, a bad request, right? So that's 400 for the bad request, comma, paste it again, same thing, contents. Make sure I get rid of this space here, or it doesn't really matter at this point. Fix the syntax up here. I'd like to have this in the single quotes. Perfect. And the color coding helps too, by the way, with these editors. So once I'm done specifying the except, next definition is going to be for the Boolean based size. So this is for the error. So next I'm going to go ahead and do the definition for def Boolean underscore based and then underscore size. And here I'm going to use the test underscore char. I'm going to use the character, or current character rather. So let's do current underscore character, use the comparator, env, same things, and then start response, start underscore response. Make sure get the spellings right here. All right, perfect. Colon, let's do try, colon truth equals. Now it's the same thing as above, right? So the first part was for the Boolean based error. Here this is going to be for the Boolean based size. So what I'm going to do is I'm just going to copy this and then change certain things. So let's go ahead and copy all of this, and then I'm going to paste it down here. All right. So let's check this out and make sure our syntax stays correct. So this is truth equals CMP. So right here, let's verify from this position onwards. So once I have the CMP test character, that's fine. My ORD is fine, which is current character, and this is going to equal to comparator. Great. If truth, which I have, start response 200 OK, content type, so far so good. Return hello, you just submitted a query. I can just change this. So you submitted a query, something like that, right? And I found a match, right? So and match was found. The rest is fine. Next I'm going to use the else, which is okay. Start response, and this is going to be not for the 404, this is going to be actually 400, right? Bad request. Great. Let's get rid of the rest of the text here, and then of course the content type and text plain stays the same, and this time I'm simply going to return, let's say, an error, right? So this is going to be error, bunch of R's, just some text. So once I'm done with this, next I need the dictionary of the types of tests, so we can pass the path to execute that type of test. Okay, so let me say that again. So next, after we're done with our Boolean based size, we're going to go ahead and use the dictionary of the types of tests so that we can pass our path to execute that type of test. Okay, so let's go ahead, let's go to the next line, scroll down, in fact place a comment here. So di CT of the types of tests. So here I'm going to go ahead and do types equals curly braces, the time, and this goes in single quotations. Make sure my syntax is correct. Perfect. And then here I'm going to go ahead and say time-based blind. So underscore based and then underscore blind, comma. Let's go ahead and do error, colon, and then Boolean based error, right? We defined that earlier. Comma. Let's do slash Boolean, put a colon, and then the Boolean based size. So we have both of these things. Perfect. Close the parentheses, just a single one. All right, great. So are we missing a set of parentheses here? It's actually a curly braces, not a parentheses. That's why. Perfect. Because we started off with the curly braces. All right, so once we're done with this, pretty much the last part that remains is actually starting the server, right? So let's go ahead and do that. Put a comment. So start the server. Let me go ahead and do the print and then n. Let me go ahead and do the print, a bunch of print statements, that's all. And I'm going to do bbsql http server and then a couple of n's. Next I'm going to go ahead and do the print and I'm going to say use to unit test boolean, use to unit test boolean, comma blind, comma, and error based SQL injection. Awesome. Next I'm going to go ahead and do maybe another print and say path can be set to time with a slash, comma, can be set to, let's say, error, comma, or boolean. And finally do the print and then new line. Great. So our code seems pretty neat, right? So we're just creating a web server, and next I'm going to run this web server. Once the web server is running, then we're going to go and open the terminal using Kali Linux and try to inject. And recall, if I scroll up, the URL that we're interested in checking the vulnerability is our local host at port 8090, and then I'm going to use the row ID equals 1, and this is of course from our database, right? Now in a live environment or a live web server, you are running, let's say, an SQL server at the backend or PHP MyAdmin or any open source database server. That's all you will need to test for SQL injection. Okay, so let me go ahead and in fact quickly fix the syntax up here, and this is going to be for, let's say, not import. I already imported the event let. I'm going to use from event let, import the WSGI, and then also fix the syntax here. This red underline kind of shows me that, wait a minute, this syntax is not correct, so you need to make sure you fix this. Same thing from here. So this is not for, it's going to be from URL parse. I'm going to import the parse underscore QS. Perfect. So let's go ahead and save this. So open up our test folder, and I'm going to call it, let's say, SQL injection.py. Go ahead, save. Perfect. And let me click on debug, execute the current file, and let's check line number 9. What do we have? Root test SQL injection py. Let me verify line 9. Alright, no module named URL lib2. It's probably the spelling, right? So it's with the 2 R's. I need to fix this. Here, just one URL lib2. And let me scroll down to see if there are any prominent errors that I can just pinpoint at this point. Alright, let's try again. Scroll up. And this is fine because this is URL lib. Great. So let's save this. Let's go ahead, run it again. And line 9, which is fine, well, this is going to be URL lib. Alright, this is the correct one. And the good thing about these editors, of course, if you make a syntax and it's not picking up, right? So once it picks up the correct module name, it'll just pop up a drop down just like this. Okay, so I'm going to go ahead and use the URL lib2. Same thing, just verify, and this seems correct down here. So let's save this, let's run it, and what do I have here on line 77, right? So let's scroll down and scroll to the right just to make sure, and let's scroll up to see what's going on. Alright, line, we fix this module, and then we have on line 77. So this is okay. So let's scroll down just to verify. Alright, so what's happening here is that we have defined the types, which is time-based, Boolean-based error, and now we never really ended it, right? So we printed, for example, these statements, which is fine. It's going to start the server, but then it's not really going to know what to do next. And our last statement, which in fact is the fact that we need to do the WSGI and then use the server method and follow by the event let and then listen to this port, because at this point it doesn't know where to go and how to go about doing so. So let's go ahead and complete this. I was wondering about that. So let's do WSGI.server, and then I'm going to go ahead and use the event let, comma, or use a method rather, to listen. And then what's it going to listen to? In fact, it's going to listen to the port 8090. So let's go ahead and do comma and then 8090. Okay. Once I'm done with this, I'm going to go ahead and do the parse response. Now our code is complete. So let's go ahead and save. Great. Alright, let's test it out. So I'm going to make sure, bring up my terminal. So right click, open terminal. And we are going to test the URL, right? So this is the URL that we're interested in. So first I'm going to go ahead and simply do, let's say, SQL map -u and then my URL. So let me in fact copy this. So it's HTTP, scroll to the right a little bit. So I'm going to go ahead and just copy the URL up to my index, row index 1, right? So right click, copy, and then let's bring up our terminal again. Let's do SQL map -u is the parameter, and then let's go ahead and paste the URL that I'm interested in finding out the vulnerability for the SQL, and let's go ahead and paste, and then I'm going to use the DBMS, right? So the DBMS is for or the DBS rather, is to check for databases. So let's do DBS and then hit enter. And this is going to run the SQL map. It's going to go ahead and test the vulnerability for this URL and give me a bunch of information. And we'll take a look at what that information is shortly. But first, let's wait till it completes the actual SQL injection test. So here, once it's done, let me go ahead and scroll up so I can explain what all of this is all about. Make this bigger. So what it did was it started the test, right? So testing the target URL, which was our port 8090 on a local host. And then the web server responded with an HTTP error 400 because that's what we had actually coded in the Python program. And the next bunch of lines indicate that it's going to check if the target is protected with some kind of WAF, IPS, or IDS, or any other type of security. And it says target URL is stable, testing if get parameter for the SQL syntax, row index is dynamic or not. Now we specified the row index as 1, right? So it was just static. We specified this. So now what it did was it tested to get the parameter row index does not appear dynamic, and it tells you this. So what's going to happen next is going to keep running the test, right? So it's going to keep trying to inject and find the vulnerability. And the test shows that the get parameter row index might not be injectable because it's static. Most backend servers, they have dynamic, right, parameters. So in our case, when we coded the Python program, it's a pretty secure program. So the next bunch of lines, what's it doing is testing for SQL injection on get parameter row index, Boolean blind, right? All of these parameters that we define is going to check each one of those. So the Boolean blind parameter replace, the SQL commands such as where, having, order by. It's going to use all of these commands just to penetrate within the database and get the list of all the databases and tables, if any. And that's exactly what it's doing all the way down here. And finally, if it doesn't find anything, it just says, well, row index is still not injectable. Here's the good part, right? So for example, let me scroll down. Notice the red part, right? It says critical all test parameters appear to be not injectable, but it says try to increase the dash level, right? We can use this parameter or risk or the reg exp. So we can also use tamper and so on, right? So it gives you other options as well. So let's go ahead and try one of these. So let's bring up our command again, and I'm going to use, let's say, level 2. Let's run it again and see what happens. So in this time, it's going to run the same test again, trying to penetrate the URL with the row index ID 1. It still says might not be injectable, but I increase the level of attack, right? So as I increase the level of attack, it's going to run extra queries. It's going to stack these queries up and then tell me and give me an option such as it's not recommended to perform extended union tests, right? So these are simply running queries, union queries, if there is not at least one other potential technique around. So do you want to skip? Well, I don't want to skip. I want to really find out what's going on. So I'm going to say no or N, enter, and it's going to continue from 11 to 20 columns, which is right here. That's where it says, and it's going to test again 1 to 10 columns, testing the MySQL union query, null, and then it's going to use the 11 to 20 columns. So this time it's checking from, let's say, the very basic start and then to the end. And finally, since our Python code says 400 bad requests every time an attack occurs, it's going to return a bad request. And in this instance, it returned bad request 900 times. It's not injectable. And that's the beauty of writing the Python code. So practice with the concept of SQL map and the SQL injection using Python programming. So with this, let's move to the next. And let me click on debug, execute the current file, and let's check line number 9. What do we have? Root test SQL injection py. Let me verify line 9. Alright, no module named URL lib2. It's probably the spelling, right? So it's with the 2 R's. I need to fix this. Here, just one URL lib2. And let me scroll down to see if there are any prominent errors that I can just pinpoint at this point. Alright, let's try again. Scroll up. And this is fine because this is URL lib. Great. So let's save this. Let's go ahead, run it again. And line 9, which is fine, well, this is going to be URL lib. Alright, this is the correct one. And the good thing about these editors, of course, if you make a syntax and it's not picking up, right? So once it picks up the correct module name, it'll just pop up a drop down just like this. Okay, so I'm going to go ahead and use the URL lib2. Same thing, just verify, and this seems correct down here. So let's save this. Let's run it. And what do I have here? On line 77, right? So let's scroll down and scroll to the right just to make sure. And let's scroll up to see what's going on. Alright, line, we fix this module. And then we have on line 77. So this is okay. So let's scroll down just to verify. Alright, so what's happening here is that we have defined the types, which is time-based, Boolean-based error, and now we never really ended it, right? So we printed, for example, these statements, which is fine. It's going to start the server, but then it's not really going to know what to do next. And our last statement, which in fact is the fact that we need to do the WSGI and then use the server method and followed by the event let and then listen to this port, because at this point it doesn't know where to go and how to go about doing so. So let's go ahead and complete this. I was wondering about that. So let's do WSGI.server, and then I'm going to go ahead and use the event let, comma, or use a method rather, to listen. And then what's it going to listen to? In fact, it's going to listen to the port 8090. So let's go ahead and do comma and then 8090. Okay. Once I'm done with this, I'm going to go ahead and do the parse response. Now our code is complete. So let's go ahead and save. Great. Alright, let's test it out. So I'm going to make sure, bring up my terminal. So right click, open terminal. And we are going to test the URL, right? So this is the URL that we're interested in. So first I'm going to go ahead and simply do, let's say, SQL map -u and then my URL. So let me in fact copy this. So it's HTTP. Scroll to the right a little bit. So I'm going to go ahead and just copy the URL up to my index, row index 1, right? So right click, copy, and then let's bring up our terminal again. Let's do SQL map -u is the parameter. And then let's go ahead and paste the URL that I'm interested in finding out the vulnerability for the SQL. And let's go ahead and paste. And then I'm going to use the DBMS, right? So the DBMS is for, or the DBS rather, is to check for databases. So let's do DBS and then hit enter. And this is going to run the SQL map. It's going to go ahead and test the vulnerability for this URL and give me a bunch of information. And we'll take a look at what that information is shortly. But first, let's wait till it completes the actual SQL injection test. So here, once it's done, let me go ahead and scroll up so I can explain what all of this is all about. Make this bigger. So what it did was it started the test, right? So testing the target URL, which was our port 8090 on a local host. And then the web server responded with an HTTP error 400 because that's what we had actually coded in the Python program. And the next bunch of lines indicate that it's going to check if the target is protected with some kind of WAF, IPS, or IDS, or any other type of security. And it says target URL is stable, testing if get parameter for the SQL syntax, row index is dynamic or not. Now we specified the row index as 1, right? So it was just static. We specified this. So now what it did was it tested to get the parameter row index does not appear dynamic, and it tells you this. So what's going to happen next is going to keep running the test, right? So it's going to keep trying to inject and find the vulnerability. And the test shows that the get parameter row index might not be injectable because it's static. Most backend servers, they have dynamic, right? Parameters. So in our case, when we coded the Python program, it's a pretty secure program. So the next bunch of lines, what's it doing is testing for SQL injection on get parameter row index, Boolean blind, right? All of these parameters that we define is going to check each one of those. So the Boolean blind parameter replace, the SQL commands such as where, having, order by, it's going to use all of these commands just to penetrate within that database and get the list of all the databases and tables, if any. And that's exactly what it's doing all the way down here. And finally, if it doesn't find anything, it just says, well, row index is still not injectable. Here's the good part, right? So for example, let me scroll down. Notice the red part, right? It says critical all test parameters appear to be not injectable, but it says try to increase the dash level, right? We can use this parameter or risk or the reg exp. So we can also use tamper and so on, right? So it gives you other options as well. So let's go ahead and try one of these. So let's bring up our command again, and I'm going to use, let's say, level 2. Let's run it again and see what happens. So in this time, it's going to run the same test again, trying to penetrate the URL with the row index ID 1. It still says might not be injectable, but I increase the level of attack, right? So as I increase the level of attack, it's going to run extra queries. It's going to stack these queries up and then tell me and give me an option such as it's not recommended to perform extended union tests, right? So these are simply running queries, union queries, if there is not at least one other potential technique around. So do you want to skip? Well, I don't want to skip. I want to really find out what's going on. So I'm going to say no or N, enter, and it's going to continue from 11 to 20 columns, which is right here. That's where it says. And it's going to test again 1 to 10 columns, testing the MySQL union query, null, and then it's going to use the 11 to 20 columns. So this time it's checking from, let's say, the very basic start and then to the end. And finally, since our Python code says 400 bad requests, every time an attack occurs, it's going to return a bad request. and in this instance it returned bad request 900 times. It's not injectable. And that's the beauty of writing the Python code. So practice with the concept of SQL map and the SQL injection using Python programming. So with this, let's move to the next. In this lesson, I'm going to demonstrate how to use the brute force using Python. So I'm going to go ahead and write a Python program that is going to allow to do brute forcing of a certain password list, right? So let's jump right in. And before I actually start writing the program, let me show you a couple of things, right? So we need a password list. You can download it from the internet, or you can create your own password list. Just a simple text file that contains a bunch of passwords. Because when you want to brute force something, it's going to check on each of those passwords before it can actually identify the weakness here. So as a penetration tester, you need to have the text file which contains all the passwords, and of course once we write the program, we'll execute the program and see how it works. So let's go ahead and open up our editor. So here's the Wing IDE for Python, and I'm going to go ahead and just create a new file. It's already created, so I'm just going to go ahead and start my program actually. So we need to import a couple of modules, right? So let's do import our first module, which is pxSSH, and what this class does basically extends the PEX-spec, right, to specialize setting up the SSH connections to the shell. And this adds method also for login, logout, and expecting the shell prompt. So that's why we need to use this particular module. Next, I'm going to go ahead and use the opt parse. So it will be import opt parse. That's for our parsing. Then I'm going to go ahead and use the time. That's pretty straightforward. And then of course our threading as well. I'm going to go ahead and import everything. So next I'm going to go ahead and define our connections. Okay, so let's say maximum or max connections. I'm going to set this to 5, and then the connection lock is going to be equal to our bounded semaphore, right? So we use semaphores, by the way, just so you know. It's simply a thread synchronization, right, construct that can be used either to send the signals between threads so that we can avoid the missed signals, right? Another reason why we use the semaphore is, think of that as to guard a critical section, like you would with a lock, for example. Since we're using these locks, we want to make sure these are well guarded. So once I set the connections to 5, and the connection lock is going to be equal to our bounded semaphore, and then I'm going to set the value equals to max connections, and if found, I'm going to set this to false, and if it fails, I'm going to set this to 0. Okay, so the preliminary aspect is done for the program. Now we need to create our definitions, right? For the connect, for example, that's where I'm going to start. So let's go ahead and do def connect, and here I'm going to specify the parameters, right? So for example, you want to connect to the host, username, password, and so on, right? So let's do host, comma, user, and then password, and then release, place a colon. Let's do a global found, and then also the global for fails. And then it's going to go ahead and try, set some variables. So variable s equals pxx or px ssh. ssh again, that's the method. And then I'm going to go ahead and try. So variable s equals pxx or px ssh. ssh again, that's the method. And then I'm going to go ahead and try. So variable s equals pxx or px ssh. ssh again, that's the method. And then I'm going to go ahead and try. So variable s equals pxx or px ssh. ssh again, that's the method. So And then I'm going to go ahead and use the login method. So s.login and use host, comma, user, comma, password. Those three things will be required. And then let's go ahead and do a print. And then use the plus sign within the set of brackets. And if the password is found, colon, I'm going to concatenate this with the password. Now once I'm done with setting up the print command, I'm going to set the found to be true. So this is going to be true with lowercase. And then of course I need the except, right? So except or exception as E, for example, and then do a condition. So if read, let's say non-blocking in string E, colon, go ahead and do the fails plus equals to 1. And then the time to sleep, for example, the wait time will be about 5. You can set this to any. And then let's go ahead and do the connect. So connect to my host, user, and then password, same parameters. And use the false. elif, that's my next condition, so I'm going to use elif. Go ahead and synchronize, so I'm going to use ch or cro rather with original prompt. And you can do this, we're going to do this in the string E or STRE, colon, and then I'm going to go ahead and use the time.sleep, set this to the same time as above. Well, maybe it'll reduce it, right? Because we have 5 up, so I'm going to use maybe 1 second here. Now, once I'm done with this, I'm going to go ahead and also specify the connect again. So let's do connect, host username, password, and then I'm going to set this to false, same as above. And then let's go ahead and do finally, okay, if release, and then use the connection lock. So connection underscore lock and use the release method. Okay, so if everything works well, then it's going to release the lock. And that's a method. So we're done with our first definition here. Next, I'm going to go ahead and do the def main. So let's do def main colon, and here I'm going to use parsers, right? So let's scroll down, start with our parser equals opt parse dot option parser, and the usage here is going to be, for example, let's open the parentheses and usage, and then %, I'm going to use prog and set this to host, because we would like the user to specify once they run this program, once we're done with this and they're going to run this program, they'll be prompted to enter a host, right? So if they want to brute force something, they want to enter host, so it'll be localhost or an IP address and so on. So this will be, let's say, the -h, and then my target host is what this will do. And then I'm also going to specify -u, for example, for the user, and then also the password list, right? Because we need the password list, so it can go out there and try to use each one of those passwords within that list. So I'm going to use the -f, and this is going to be for the password list. Great. So once I'm done with this, I'm going to go ahead and use the parser add. So let's go ahead and do parser.add option underscore option. Open the parentheses, and here I'm going to specify -h, comma, and that's for my target host, by the way, and the destination equals the target host. So this will be dest, and then I'm going to first fix the syntax here. So this goes here, remove the apostrophe, and then right after the destination is tgt host. So that's tgt host here, and then I'm going to go ahead and close the quotation, put a comma. The type is going to be, let's say, string, because that's just text we're going to enter. So that's just string. And then I'm also going to use, after the comma, let's say help equals, and then specify target host. So this is helpful for users who are using this program, right? So just go ahead and do specify target host. So once that's done, my next parser add option, so parser.add underscore option, this is going to be for the -f, or the password file, and then of course we're going to do this for the user also. So same things. Let's first go ahead and do the correction of the syntax, and then let's begin our add option for, let's say, the -f or -f, and then this is going to be for the destination equals, and then I'm looking for the password, right? So it's pass wd and then file, comma, the type here equals string, same thing, and then of course help, I can specify something like specify password file, right? So comma help equals, and I'm going to go ahead and say specify password file, and let's go ahead and fix the syntax quick. It should be an apostrophe instead of a quotation. Okay, all right, so let me go ahead and fix the top here also, just some quick fixes as we go along. Perfect. So once our syntax has been corrected, let's move on to the user, right? So parser.add underscore option, and this is going to be for our -u, comma, and then the destination here is going to be equals to user, and then of course I need to specify the type also. So after the quotations, comma, and the type, same syntax as above, right? So this is going to equal to, let's say, string, and then I'm going to put a comma, and then of course the help, of course, equals specify the user, right? So let's go ahead and do the specify the user text. Great. So I'm done so far with the parsers, right? Next, I'm going to go ahead and, of course, set the variables as well. But before I do this, I'm going to go ahead and do options, set the arguments, and then this is going to equal to our parser parse arguments. So, and then dot parse underscore args method. Great. Now I'm going to go ahead and do host equals our options dot tgt host. That's with a capital H, so we don't make the syntax errors. And then the password, which is passwd file, right? That's what I spelled above. This is going to equal options.password file. Great. And then finally, the user is going to equal to options.user. Perfect. Now I'm going to do the if condition, right? So let's go ahead and do if host equals none, or the password file equals none, right? Or the user equals none. So I'm just going to make sure I check each of these: host, user, and password file. Or password file equals none. And keep this in mind, by the way, I'm spelling the password as passwd file, right? So even though I say a password, it's spelled differently. So keep that in mind. All right, so if password file equals none, or the user equals none, colon, what should we do? We are going to go ahead and print the parser usage. So parser.usage, and then exit. Okay, open the parentheses, and then great. Let's scroll down. I'll make this bigger also so you can see. So once I'm done with the first if, right, next I'm going to go ahead and set a variable here. Let's say it should be fn equals open, and then open the password file, because once you execute this program, it's going to in fact display the password file as well. So it's passwd file, and then comma, and then R for read. Okay, so you can only take a look at it. And next I'm going to go ahead and do a for loop here for line in fn.readLines method colon and a found. Go ahead and do a print. And what are we printing here, for example? Let's say we're printing the asterisk within brackets, and then I'm going to say existing password found, and then of course exit, same as above. And just in case if it fails, right, we need to specify that also. So let's say greater than 5. I'm going to set this as greater than 5 colon. It's going to go ahead and do the print, and this time it's going to go and print, let's say in brackets an exclamation mark, and existing, I was going to say too many socket timeouts. Okay, so colon too many socket timeouts, close the parentheses, and then of course exit one more time. All right, so once I've done with this, then I need to specify the connection lock and to acquire the connection lock at this point. So let's go back a few indents and let's do connection underscore lock, and then dot acquire method. Password is going to equal to, let's say, line dot strip, and I'm going to use a new line for this. So, or not a new line, just going to have the R here, and then dot strip again for the new line at this point. So first it's going to read it and then print out in a new line. Instead of printing passwords in one single line, it's just going to tab to the next line. All right, so here we have our -n or \n, and next I'm going to go ahead and do the print, and this time I'm printing the negative sign within brackets, and I'm going to say I'm just testing, and then concatenate this with our str password. Great. And finally, almost done, so I'm going to specify t equals the thread target, right, equals connect, comma, my arguments equals my host, of course, and the user, and then password. And I'm going to now set this to true. I'm also going to do one more. Let's say child equals tstart, right? That's the method I'm going to use to get this going. And then finally, do our if main, or name rather, first. And then this equals our main. Great. So we're done with the program. Let's scroll up. So we created this for brute forcing our password list. So I'm going to go ahead and save it first in our test folder. That's the one that we've been using so far. And I'm going to call it brute force 5. I'm going to say brute force final.py, so remember, and click save. Perfect. So I'm going to go ahead and test it now, right? So let's move this aside, bring up our shell, and within my shell, I'm going to go ahead and navigate to the directory first. Of course, that's where the file resides. So let's do the ls here, for example. And then I need to go to my test, right? So just change directory to test. Let's do an ls and locate my file. I'm looking for the brute force final.py. So it's there. Great. So next, I'm going to go ahead and in fact use Python and run this file and see what happens. So let's go ahead and do Python. And then right after Python, I need the name of the file. So this is brute force final.py. Now notice at this point, if I were to just execute this file, and it's going to say, all right, line 58 error. Let's fix the errors first. So let's scroll down and let's check our main function here. Let's see what the error is. And of course, yes, I don't need the double quotations. I need these single quotations. Silly mistakes. No problem. We'll fix them. Perfect. Let's go ahead and save this again. Go back to our shell. Let's bring up the brute force final.py, enter. And did I forget a colon after main? Yes, of course. All right, perfect. Now we should be good. Save it again. Bring up our brute force final.py. And then, yeah, I was worried about that, the indent. Save it again. It's good practice, by the way. So let me go ahead and clear it. Start over. Perfect. So let's do Python and brute force final.py. All right, line 32, a couple of more errors. Parser equals opparse.option parser, and then the usage, and then line 32 and 59. So let's go ahead and take a look. Oh, 59 is our main, which is fine. Let's go to 32. So let's see if I can find the error in line 32 where it says parser equals opt parse. The error here, for example, and right here is option parser, and this is a capital P, by the way, right? Great. Let's go ahead and save. Let's bring up our shell one more time. Let's try to run it. And perfect. Now it works. So it's asking us for the parameters, right? So it's prompting us for the host, user, and then password. And that's exactly what we actually coded using Python. So now let me go ahead and in fact show you the next step also as to how to bring up our dictionary files and actually run the command for executing a brute force. Okay, and then of course you can use it on your own local host or other sites as well, as long as you have permission. Perfect. So I'm going to go ahead and use Python brute force final.py, and then of course my -h for my host. I'm going to use localhost as an example for demonstration purposes, and -u for the user, and this is going to be root, or it could be any user, right? Typically it's admin or something. I can always use, let's say, admin, and then my file, which is dictionary.txt file. Okay, now I already have this file saved. Let me show you this before I actually execute this line. So I'm going to go ahead and open up my files, go to my test, and here's the dictionary.txt. And if I open this, by the way, it just contains a bunch of random passwords. Okay, so in real scenario, obviously you're going to have millions and millions of these passwords, right? So when it's going to start to brute force, it's going to go over all of these passwords and eventually find the password. So let me close this. Just wanted to show you this quickly. All right, let's go back to our command. So it's Python brute force final.py, and then specify the local host, and then the admin, make it bigger, as the user, and then of course your dictionary.txt. So let's run it, and voila, we have our dictionary list, or the list of passwords, and it's testing all those passwords. Okay, so if you have obviously a bunch of passwords or millions of passwords, it's going to keep continuing to loop, and that's what we coded in Python. So practice creating a Python program using brute force, and let's move to the